Hello everyone. I welcome you all to the live session on Python full course by Intellipaat. In this session, multiple experts from top industries will be joining the session and will be covering the Python concepts from basics to advanced level, including hands-on demo and interview preparation.
But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us.
Now let's see the agenda of the day. Firstly, we will begin with Introduction to Python. Post that, we will tell you how to install Python on Windows. After that, we will be learning about what is data manipulation and what is numpy array. Post that, we will tell you how to create numpy array. Then we will be moving on to basic concepts of Python like data types, indexing, slicing, statements, linked list, operators, and lot more interesting things. After that, we will be doing a hands-on demo on how to build a REST API in Python to give you a better understanding of the subject. Then later on, we will tell you how to make a career in Python. Then finally, we have covered Python interview questions and answers. So guys, this session is going to be very interesting. So stay tuned and watch the video till the end.
What is Python? Well, ladies and gentlemen, you need to understand that Python is, a very nice programming language to work with at the basic level. And if you're thinking, okay, so what is it used for? Well, what is Python exactly? And all of these questions flooding your mind right now, well, let me answer that. Python is basically an object-oriented language where, all the data is considered to be individual objects and worked with it. So that is what object-oriented basically means. And it's a high-level programming language where, we don't use very complex syntax to work with. It is easily understandable and provides, very high readability as well. So by high readability, what do we mean? Well, high readability makes sure that even a non-programmer or a beginner can basically understand a lot of code when looking through a Python code. Well, it's as simple as that. And Python is primarily used for web development, application development, and much more. We know how much you guys are excited for web development. We know how much you guys are excited for understanding data science, understanding artificial intelligence, deep learning, machine learning, everything. And you guys might already know that Python is used for all of these applications, right? And that there's a reason for that. Basically, Python is known to be the world's #1 programming language. In fact, Java actually had this bragging right of being called the world's #1 programming language, and then Python came in, and pretty much from then on it has remained on the top spot since then. So the next question you might have is Python a new language? Is it an old language? Because if we do have very experienced developers among us who've been working with Java all their life, C++, C#, or anything, you might wonder, is Python a new language? Well, not exactly, because Python has been in existence since the 1980s. It's pretty much close to 40 years now. Python is almost a 40-year-old language, ladies and gentlemen. And the most important thing you need to understand is that it gained a lot of momentum. It gained huge popularity in the beginning of the 21st century, and basically since then, as I just mentioned in the previous slide, it has been rising and rising. And here's the person who created Python. His name is Guido van Rossum, and he's an amazing developer. You can check out more about him after the session, of course. And then coming to some quick Python facts that you might know or not know. Well, guys, do let me know if you know any of these. Let's consider Firefox. Firefox has over 230,000 lines of code, which basically calls to the working of Firefox, and it's all written in Python. How amazing is that? 230,000 lines of code of Python for Firefox, ladies and gentlemen. And then coming to Microsoft, of course, they have their own IDE. They call it as the Visual Studio Code, and this is basically used to promote worldwide Python development as well. And you can get pretty much free versions of this. And Python is open source, if you've been wondering. So Python has been used by the community, developed by the community, and implemented very well by the community as well. And then coming to Netflix, did you know that Netflix actually makes a lot of use of Python, especially in the field of data science? Well, everything from automatic image recognition, it might be a recommendation for all the TV shows and the movies we can watch on Netflix, and much more. But do understand that Netflix uses a lot of Python. And then coming to Uber, I'm pretty sure everyone knows about it, and they actually make use of Jupyter notebooks, and they make use of IPython to basically share and store all of the data with respect to the driver client interaction and all the ratings and all of that, and much more. As you can see on your screen, some beautiful usage of Python right here. Well, on that note, let's come to the topic of why one should learn Python. Well, The first point that I would actually tell you guys of why you should consider learning Python is how simple it is and how beautiful the readability is. So what do I mean? Well, here's a simple Java code which basically prints the statement hello world. You know, we've all been in our first stages of programming where the first piece of code we might have printed very well might be the hello world program, right? So here is how you would do it in Java. Okay, so how do we do it in Python? Well, look at how elegant, how beautiful, and how simple it looks, ladies and gentlemen. And I'm pretty sure if you had to write code and if you had to start out with, if you're a beginner, you would prefer Python for this. You know, there are no semicolons, it is very much readable, and even if you do not know a programming language, you can understand that print hello world pretty much, you know, probably equivalent to putting out an output which gives out hello world. You know, you can at least take a guess and understand. But then as soon as you look at the Java code, you might be taken aback. You might be like, whoa, what's happening, right? And this is one of the most beautiful reasons why I personally prefer Python and why we have thousands and thousands of developers who actually prefer Python as well. Coming to the next point, I believe it's convenience. Because again, of course, this point applies to multiple programming language out there, but the specialty of Python is that, you know, since it's basically platform independent, you can run it on Windows, you can run it on a Mac OS platform, you know, basically Apple's operating system, and you can use any of your favorite operating systems. You know, in fact, if you want to run Python on a PlayStation, well, you can do that as well, ladies and gentlemen. Yes, on your PlayStation, Windows, Mac OS, PlayStation, and many other operating systems for that note as well. So this, you know, makes it very convenient for the developers, for the people who prefer Windows, and of course for the population who prefer Mac OS to everything else. So understanding this point is very vital at this stage. And next is pretty much cross-language operations. Well, what do I mean by cross-language operations? Coming to cross-language dynamics, you need to understand that Python can talk and work well with all of the languages that already exist. See, for example, there are languages, from C, Java, C++, we have JavaScript, we have languages such as Rust, we have .NET, and we have all of these languages, platforms, firmware, libraries, whatever you want to call it. And basically, Python brings all of this together. And if you are an expert in JavaScript and, you know, you're trying to implement JavaScript using Python, yes, you can do that. Can you run some Java code using Python? Of course. And can you go on to use .NET alongside Python? Of course. Well, as you can see where this trend is heading, well, it is the number one language of choice for a reason, and I believe this is one of those reasons. So what do you guys think? Head to the comment section and let me know. Let us quickly walk you through the procedure of how you can install Python on Windows, guys. It's a very simple and a straightforward process. Now, I've broken it down to a couple of steps and let's go with it together, right? So step one is go to python.org and head to the downloads page, and let's do that side by side, guys. So let me head to the Python website. So it's python.org for the people who are wondering. I'll just go to download here. You can directly click on the link there as well. Since we're looking for Windows, Python pretty much detects that it's for Windows. So we already are at the page where we hit the download. So this pretty much forms our second step as well. So let me quickly save it in the desktop. It's about 25 MB if I think. Yeah, it's about 25.2 megabytes. This will take a couple of seconds to download, and in the meantime, let's quickly check out what are the next steps in our PowerPoint slide, guys. So step 2 is again click on the download, which we just did. And guys, as of this video being made, Python 3.8.0 is the latest stable version out there. So that brings us to step 3, guys. Step 3 will pretty much be opening the installer, and we should be presented with the screen. So let's quickly wait for the download to complete, and then we're going to open up the installation box. Hey guys, that took about a minute to install, and we're presented with this screen, which is the installation screen. Just before you hit install now, you can pretty much choose to customize the installation and install it at a place of your desire. Make sure you just click this button which says add Python 3.8 to path. Well, what it basically does is it sets your environment variables and it sets the path variable to Python. So as soon as you hit Python in your command line, you can just start using Python directly, guys. So that's what it does, and it would be recommended that you do this. Even if you would not do this, there would be no problem. There are other ways to launch Python and to use it. But if you are a beginner, if you just want to hit Python and then start out with coding, you can pretty much hit Python to path, guys. And you just hit install now, and this will ask me for my admin password because we have to install it as an administrator. So let me quickly type in my administrator password and we can work with it, guys. and I just entered my password. So pretty much it should take about I say around 2 or 3 minutes to get the entire setup process done. So in the meantime, let's check out what's step 4. Again, step 4 is check the last option to add it to the path and install, and step 5 is the important step, guys. So we need to verify that our installation has been successful. So for that to occur, we need to make sure our setup completes. So let's just wait a minute and then we can go ahead with the release of Python, and that's what we've been using, guys. So we can check out another code snippet as well, guys. So let me do a equal to 1, b equal to 2, c equal to 3, and so much more, right? So let us create a new variable d and then probably add a and b to it. So let me just quickly do this. We can print d. Well, d is 3. Let's multiply. You know what? Let's create another variable. Call it e. Multiply d and c. Let us print e. Guys, I'm just doing this to just show you that everything is working fine. So 3 multiplied with 3 is 3, and so much more. To just get out of the console, you will have to type quit followed by parentheses, and you're out of there, guys. So this is as simple as installing Python on your Windows, guys. And we just verified it using a simple piece of code as well, guys. But Python has another thing called as idle, guys. So idle is this pretty much interactive Python console that you can go about using. And the shell is actually ready. So we can go about typing again, hello learners, and done. So the Python 3.8.0 works perfectly on the idle shell as well. So this is another way to just verify the installation, guys. So coming back to the presentation, step 7 is again an optional step, but you will get there very soon in case even if you're a beginner or an advanced learner, guys. So install the libraries that you pretty much want. There are many libraries that Python supports, and the most popular ones are TensorFlow, NumPy, SciPy, Scikit-learn, Pandas, Matplotlib, Keras, PyTorch, LightGBM, and so much more. Well, these are machine learning, deep learning oriented libraries that are present on your screen. But then the next step of installing Python is to pretty much install all of the packages and libraries that you want to go work with further on, guys.
What is basically a data manipulation? Okay, so Python actually consists of a lot of libraries, okay, built in. That is what makes Python so much powerful, and that has increased the popularity of Python in these days. Okay, and many people are using Python for various tasks, not just data science, not just ML, or not just this AI, but Python has been used in other programming languages, other domains also, for various other tasks like web development and something like that, and software development also. So this thing is called data manipulation. So data manipulation is possible with the use of Python libraries. There are very powerful, very brilliant Python libraries which are available for you. You can just simply install them, and there is a lot of code already written in those packages. So you don't need to write all of your code from the scratch. You can just simply go on and use those code to make your program much more capable of doing a lot many things. Okay, so what is basically a data manipulation? So NumPy that we are going to study today, NumPy is basically a data manipulation. So data manipulation in the most basic sense is we have to convert whatever data we have collected, we have to convert it into a manner so that it is much more organized and it is much more easy to process. So that is the basic explanation of data manipulation. So what are the steps basically? So you know that whenever you are making any data science project, whenever you have to start making any ML project, you have to get some data. Without data, you cannot do anything. You cannot start any data science project. So you have to get that data. So how you extract the data? So if you have heard about the concept of API, basically when we collect data, when we acquire data from multiple resources, from multiple sources, API would be one more thing apart from what. So those are also the ways, like we have flat files, we have databases, we have CSV files, and we what other thing is there, we also scrap some websites. Okay, we scrape some websites to get whatever data we want, and we store those into some flat files like CSV. Okay, and when we acquired those data, what we have to do is we will be manipulating that data. So why does we need to manipulate the data? Why do we need to manipulate the data? Why can't we simply get the data and start working on it? Okay, so why there is a need to manipulate data is whenever you collect data, it is not going to be perfect. It is not going to be pure because you are collecting data from multiple sources. Okay, you are not just collecting from all the CSV files. You are using some Excel sheets, you are using CSV files, you are using databases, you are using APIs, you are using web scraping. So all from all the places we have got some data. And when you started working on your project, you have a lot of different data. So in those data, the data, whatever data that you have collected will not be consistent, will not be exactly same. Okay. Yes. Data cleaning is needed to fix the errors. Right. So for that purpose, to make the data, whatever data we have collected till this point, to make it consistent, okay, with each other, whatever data we have collected, to make it consistent, to make it basically pure, so that we can start working on it. So with that, we can start applying our algorithms, we can start applying our data analysis, whatever we have to do that thing. So for that purpose, we have to manipulate the data. Okay. Or maybe it is not in the format that you wanted, so you have to you can do that also, you can change their format also. So that also comes in the concept of manipulating data. Okay, so what happens when you have done the manipulation of the data? You get some organized and readable information. Okay, till this point, whatever data you have collected, it is rarely going to be, in real world, it is rarely going to be very much organized and readable. A lot of things would be just simply missing, or maybe not correct type is a type of data is there in some of the columns. Maybe some data is inconsistent. Maybe some of the units are not equal, like somewhere it is Celsius, somewhere it is Kelvin, somewhere it is Fahrenheit. So these are the things that could be there. So we need to make them consistent. So this is the thing. So for doing this data manipulation, we have a lot of libraries. The first one that we are going to cover today is NumPy. After that, we have pandas. This is also a very powerful library. Then we have SciPy, and then we have Matplotlib. So Matplotlib is basically used for visualization purposes. Okay. So why do we actually need to do the data manipulation? So as I told you that as a data scientist, you will be gathering data from various resources. So when you are gathering data from various resources, from various sources, what is going to happen? The data will rarely be consistent. So there could be multiple problems. Like if you see what is the problem that we have to tackle if you're doing data manipulation, is basically these four problems you are going to tackle. There would be missing values. Okay, and why would be there missing values? So when you or maybe anyone in the company is collecting data, they might be doing some surveys, they might be collecting data from somewhere, and it is possible that when we were collecting that data, the equipment might not be available. Okay, so if we are just going on doing surveys, if you want to collect some measurements, for that measurements, maybe equipment is not available. Or in some cases, user is not willing to share the data. Okay, so suppose if a bank has gone to collect some data from all of its users. So what can happen in that case? If they are asking about the income that the company that complete family generates, whatever income is being generated by the company, so they want to know that information. So what can happen is in many cases, the bank can see that they are just telling some part of information. They are not telling, for various reasons, they are not telling whatever data they acquire, they need to acquire. Okay, so in those cases, in those columns, or maybe there are some families who do not want to share their income data at all. Okay, so at that places, the data is simply missing. So that could be one case. What could be another case? We could have incorrect format of data. So what could be incorrect format of data? So when we have collected the data, so so what can happen is the date format could be different. The format of currency could be different. So in some places you have collected the prices maybe for any of the things. So somewhere it could be in dollars, somewhere the dollar is simply not written. So that could be the thing that adds to the complexity. So that both of the data, if you see 10,000 and if it is written $10,000, so both of the data is not equal. Okay, you need to make both of the data in correct format, in consistent format. Okay, so what other thing could happen? We could have a different units. So we have collected good data, but the unit is not same. Okay, so what could be the thing? we could have this unit difference like Celsius, Kelvin, Fahrenheit. If it is about distance, it could be miles and kilometers. And then we have some unnecessary data. Okay, so for this unnecessary data, why unnecessary data is coming? Okay, so if you can just understand that whoever was collecting that data, or maybe you as a data analyst were collecting data from various sources. So what was happening that you thought that this thing is going to be useful for me. Okay, I need to collect data based on these many points, these many attributes. Okay, but when you started to make a project, you have various projects for which you are going to use the data that you have collected. So suppose one project you are using, in that you found out that the data, the complete data that we have collected is not going to be helpful. I don't need the complete columns or the complete things I have collected. I just need a part of it. I just need to know about these points only. I just need to know about these features only. Okay, I don't need to get the whole data. So in those cases, what you have done is you have just simply collected unnecessary data, or for that project, that would be considered unnecessary data. Okay, so yeah, this is the thing. So for example, if you have unique ID columns, which is basically not important. So if some data is showing you some ID column, some ID row is there, 1, 2, 3, 4, it is written. It is not going to be any use to you. Okay. So basically that is what? That is just an index number. Okay. So we can simply get rid of that thing, and just we are going to be okay with it. We have not lost any important data. So let's start understanding what numpy basically is. So this was the basic of why we need to do data manipulation and what is basically data manipulation. So these are the things. And let us see the first tool which is available for the purpose of data manipulation. Okay. So the first thing that we are going to study today is numpy. So first thing, let's start with numpy. Okay, so what is numpy basically? So till this point, you have not interacted with any library. You just have written the code, whatever code you wanted to write. You just use conditionals, you use loops, and use just basic data types, which is available in Python. You did not interact with any package, any library. So this is the first interaction of yours with a library that is present inside of Python. Okay, what type of data are there and we deal with in real world. So you'll get to know that what kind of data is there. Okay, I'll show you examples. With examples, you'll understand. Okay, don't worry about it. Okay, so what does a numpy basically means? It stands for numerical Python, and it is one core library which is going to be used for a lot of numerical computations. So as you know that if you are working with any machine learning, with any data science project, you have to do numerical computations. Okay, because this mathematics and statistics is part of numpy. Okay, so you have to do that task using numpy. So if you don't have this numpy package for you to use, what you have to do is, if you have to do any mathematical calculation, you will be writing code for that. And in some cases, in most of the cases, what will happen, it will take longer time for you to think the logic of that and just write the code again and again for a lot of things. So what developers has done is they have written a lot of functions inside of numpy. So what they do, so all those functions have basically simple task of theirs. So what they will do, if you want to just add something, so for that there is a function available in this numpy package. If you simply want to do any other operation like divide, or if you want to find some statistical information, like if you want to find the mean, median, anything, so, or maybe what is the minimum value in any row. So for that purpose, we have numpy. Okay, right. So why do we need numpy? So it provides functionalities so that we can make multi-dimensional arrays. So where multi-dimensional arrays are used, so I guess you are comfortable with the concept of arrays. Okay, arrays are basically a data structure which consists of same type of data. Okay, so that will consist of, if you you can simply make all the data of integer type, you can make an array of all the float type, you can simply make the data of strings. Okay, so that you can make inside of here Python, and that all is possible with the use of numpy. Numpy makes it much more easier for you to make multi-dimensional arrays. So you must be thinking that if you have read about the concept of list, you can make multi-dimensional list also. So why do we need actually NumPy? Why do we need another library? Why do we need to learn about a new concept? What is the advantage of it? Eh? Right? You must be asking that. So this is the basic thing. If I want to make something, if I want to make a multi-dimensional uh, array, that I can do basically with the list also. Okay, so I can make multi-dimensional list, and list also basically looks like much like an array itself. Okay, so I'll show you what is the advantage of it. You will see that what is the basic advantage of it. Okay, so if you understand, if I tell you in basic terms, NumPy is completely memory efficient. It is a hell lot memory efficient than any other data type which is present by default inside of your NumPy. And it is much more faster than those data types. It is much more convenient and has a lot of functionalities to do a lot of tasks. Okay, and I'll show you numerous examples. So how things are different here, how things are different in NumPy compared to other concepts. Okay, so NumPy, if you can see why NumPy is much more faster than other concepts of Python. NumPy is basically built on C language. Okay, and as you all know, if you have studied about C language, C++ language, so they are much more closer to the memory of the system. Okay, Python is not that closer to the memory of the system. So the execution of Python when compared to C or C++ would be slower. Okay, so that is the difference. So what has happened is NumPy is based on C language. So that is one functionality that makes NumPy so much faster than all of the data types which is present inside of our Python package, right? So NumPy, inside of it, NumPy basically consists of integers, some floating point, and also it consists some of the data types, which is list and dictionary, for faster mathematical calculation. So you have seen that lists are a way more flexible thing. Okay, so if you have studied about the concept of lists, you can see that we could do a lot many things with list also. And but what happens with NumPy is it just makes everything faster, make every calculation, and it also makes it much more memory efficient. So these are the kind of array that we have to understand. This is 1D array. Okay, so array, if you have, you must have some basic understanding of array. So this is an array. This is a 2D array, and this is a 3D array. So this is just a diagrammatic representation of how an array basically looks like. Okay, so to start to do anything with the NumPy package, what you have is you have to import that package. Okay, till this point, I don't think you have imported anything. You have not imported any of the packages till this point. So this thing must be new for you. Am I right? Have you imported anything? Do you know about this thing called import? So this is something new. So let me tell you what a package is. Okay, what a package basically is. I guess that you have understood or have heard about the concept of module, which is there related to function, which is somewhat related to function. In Python, we have modules. So what a module is and what is the task that a module does and what are the things in. So module is basically a Python file. Okay, so basically in most basic terms, module is a Python file that you have made. Okay, and what are the things you are going to put into that Python file? You will be, suppose if you are working in a company and you see that these are the tasks that I am doing it again and again. This kind of thing, this kind of code I'm writing again and again. So what you can do, instead of just again and again writing code in various other projects that you're working in, what you can do is you can make a bigger file. Let me show you with one example that what happens with modules. Okay, so you can think of module as something like this. So this is one big file where what you have is you have made one file, and inside of it, what you have put? You have put some of the functions. Okay, what you have put is some of the functions that you need to use again and again. Okay, you know that whenever I am working on any project, I am using these many things again and again. So what you can do, you can simply make a file of that. You can simply make a file of it. And what you will be able to do, you will be able to import functions from that. Okay, so what is importing means you will not have to write this function in your Python file. If you just call this, if you just import this module into the Python file, what will happen is, if suppose there are 20 functions written into your module, you have written 20 functions and you need to use 10 functions from this module. So what you will have to do, you can simply call these functions directly from this another file. Okay, this is another file that you have written, and suppose this is the current file that you're working on. So here what you have to do is you just have to import that module, and what will you be able to do? You will be able to use all the functions that is there inside of this module, and that is what makes the concept of module so much more powerful. It is very simple to a Python file. It is just a Python file. Yes, module is basically, you can say, it is a collection of functions, and apart from function it will consist of other things also, other variables or something like that. Yeah, it will have the extension with py shiba. Yes. Okay, so if you let me show you some example like py math module in Python.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
This is one module which is used a lot. So what this thing, what is the thing there inside of a module is, let me show you those things. So this is one module, and what are the things which is present inside of this module is, you see, we have the ceil function inside of here, we have factorial function inside of here. So I think that you all know what factorials are, and you must have written about this code at some point. If you have worked on other programming languages, you would have worked with this factorial function. You would have written a program that calculates factorial of any value. You would take one value and it will just give you the factorial. So for that, if you remember, you would have written 7 to 8 lines of code basically. Okay. Or maybe if you make it efficient, you would write 3 to 4 lines of code. Okay, whatever it could be, you would have written some bunch of code, some line of code to perform this operation. So if you are seeing that we are using a lot, see, there is one is square root, okay, and there is mod, and there is a lot of things that you can just simply go onto this website and you can see that what other things we have. Okay, we have to do the exponential, we have to calculate the log of it, we have to simply do the square root of any bigger number. We don't have to write any program for it. This is completely available inside of your math module. So what you have to do, you have to simply import this module, and how you will be using this function, which is present inside of this math module, you will be calling this function using its name. Okay, you just have to write math.sqrt, and whatever number you will be writing here, it will just simply calculate for that. Is there math class name or a file name? Name of the file. Okay, math module. So this is the name of the file, math.py. Basically, it will consist of this name. Okay, and you have to import this module for you to simply work on. Okay, so when you import this, you can start working and you can use all of these functions which has been pre-made for you. You don't need to write the code for factorial. You can just use this factorial function and start working directly. So till this point, you have already seen that why do we use function? It makes our task easier. If we have to repeat some concept again and again, what we can do? We can simply make a function, and inside of that, we will just write that code, and we don't need to write that function again. We just need to use the name of the function. And whenever we call that function, we pass some values. It will just give us the result, whatever we wanted to do. Okay, so that made your task very easier. That made your life very easier. What more you can do? when you use module, you don't need to write that Python also into your file. It will be saved into another file. You just have to import that file and you will be able to work with it. Okay. So there is one concept of module. Then comes the concept of package. What is package? Or you can say library also. What is a package? So as you have seen that, it, so let me make you understand what is the difference between a basic module and what is the difference with this package. Okay, what is a package basically? So here you have one file. Okay, in a package, what you will be having is, instead of having just one file, you will be having more than one files. Okay, so package will basically consist of more than one file. And what they do is they have some code written inside of it. Okay, so whatever task people usually do, whatever task developer usually do, that everything will be written inside of this files, okay, which comes inside of a package. So numpy is similarly a package which consists of some file, which is similar to the concept of module. So what is the advantage of it? Suppose you are working on a task, you are working on a project. What you can do, you don't have to write whatever code has been written in these files. What you can do is simply just start to import this thing. You will simply call this complete library, which is numpy. If you just call this numpy library, what are you going to get? You will get access to all of the files together. Okay, you will get all of the files which is there inside of numpy, and you can start importing whatever function is present inside of this, and your task becomes even more easier. You don't need to write a single line of code. You just have to import this library and use their functions. So the way you have called your functions, similarly you will be calling these functions. But the only thing that has changed is you need to first import this library. That way your Python understands that this is the thing that is happening in the background. Okay, right. Let's see more of it. So understand what will happen if we have imported this package, this numpy package inside of our current Python file. This is what going to happen. Now let me show you one example. Let me show you how much memory efficient and how much faster a numpy array is compared to a data type inside of a Python. So why do we actually need to use Python? Why it is so much popular? Why do we have a complete package which has been used by a lot many people in lot many domains? Okay, so what is the advantage of it? Let's see. First, we will be doing the memory comparison of a list, and we will be doing the memory comparison of an array. Okay, so before moving forward, let me just refresh you some of the concept of list. What basically is a list? So you understand that what is a list? List is basically a data type which is there inside of Python. In this list, you can save some elements. Okay, and what kind of elements you can put? You can put strings also, you can put integers also, you can put float values also. Okay, so list consists of all of the things. It is much more flexible. Okay, and we can do a lot of things. We can store whatever we want to store here. So whatever is there inside of numpy, you will be getting access to that when you just write this thing, when you just simply write import numpy as np. Okay, so what we are doing is, for this is the thing, this is import numpy, and this thing whatever I'm writing is I'm just renaming this package. Okay, so what happens in, there are a lot of libraries like Matplotlib. If you talk about Matplotlib is a bigger name. So wherever I want to use this numpy and I want to call some functions on it, I will have to write numpy again and again. I don't want to write this big name. I don't want to write Matplotlib, a bigger name, again and again. So I can convert it into a smaller thing. Okay, I can rename it. So this is the way, this is the thing, you are importing numpy as np. Okay, so this is just a renaming. This is just an alias of it. Okay. Okay, so you don't need to import numpy. You don't need to download numpy. Okay, if you are using this Anaconda, if you are using Jupyter here, you don't, it comes pre-installed with it. Okay, so that is why it is recommended to use Jupyter. It has a lot of libraries. Whatever thing you want to do, there is a possibility that it is already installed. It is already been given inside of your Jupyter or Anaconda package. So what is the advantage of using Jupyter? You can write C. We have written notes also. We are writing programs also, so that everything you can do in one place. Okay. And if you're using Visual Code, you'll have to comment it out. Whatever statement if you have to write, you'll have to comment it out. So that doesn't look much more beautiful, and that makes it a little more confusing. Okay, so for this purpose only, we have something like this. Okay, now we will see how a list work actually. So if you want to make a multi-dimensional list, what you can do? If you are making a simple list, this is the way you are making a simple list. Okay, let me just show you. If you want to make any list, what you can do is simply make this square brackets inside of this, whatever elements you want to put, or you want to put the strings also, you can put string here. If you want to put another list inside of it, that also is possible if you want to do that. Okay, so you can just simply write. So this is also possible. Inside of it, there is something called tuple if you have studied about it. So tuple also you can put inside of it. Okay, so this is very powerful. This is very flexible. Okay, and this is one dimensional list. If you want to make multi-dimensional list, how you can make it? You just have to do the nesting of it. Okay, so if I just make second list, and I'll show you that how we can make a multi-dimensional list. So this is a way. Okay, you make a list. Inside of it, you will be writing one list and comma another list. Okay, so if you want to make any number of lists, you can do that. This basically makes your list multi-dimensional. So it makes it two-dimensional. Okay, and if you want to make it three-dimensional, you can simply make another list here. So what we are doing is we are just nesting list inside of list, list inside of list. So this is changing the dimension of the list. It is much more capable than using just a simple module. Okay, so this is a way we can make multi-dimensional list. Okay, you just have to intend list inside of list inside of list. So what it has given us, we have made three-dimensional list here. Okay, so this is the thing. If you want to put any values, this is the way you make a list. Okay, so how do you add two lists together? Okay, why I am showing you this, I'll be comparing it with numpy. So when we use numpy to do all of these operations that we are seeing in this, how in comparison, how much faster it is and how much convenient it is. For that comparison, I'm just showing you these examples. Okay, so you have basically two lists here. Okay, and you have just put some values. If you use this extend function, what you will be able to do, extend method does is, when you write the name of this first list and then dot extend, you write the name of your second list. What it will do, it will start to add the elements of this two lists together. So you can see it has made one bigger list, 1 2 3 4 5 and 6. So this one list consists of now both the values. So this is the thing, this is how you add two lists together. Okay, and you can just simply use plus this symbol. If you just simply write lst1 lst2, you will be able to add both of these things. Okay, so this is just about adding all the elements of two lists together. But if I want to suppose sum these values 1 and 5, 2 and 6, 3 and 7, 4 and 8, if I want to sum both of these values, so for that what I'll have to do, I'll have to perform this operation. I'll have to write this kind of code. So what is this code? I have made two lists, very basic two list I have made, and then I have made an empty list. Why I have made an empty list? I'll be adding some values to it. What values? I'll be adding these values and I'll start to put values inside of my empty list. Okay, if you just use plus operator, or there is not any other operator which simply adds both of the elements inside of this two list. It will not simply add 1 and 4, 2 and 5. If you are using plus, it will just add the elements 1 2 3 4 and then 4 5 6 7. It will just put them together. It is just doing a basic concatenation of that. But you don't want that. You want the addition of both of the elements. So in that case, you will have to write a logic. Okay. So what I'm doing is I'm just running my loop 4 times. Why 4 times? Because I have to do this addition operation 4 times. Okay. And what I'm doing is I'm taking list I and then list to I. So what is the value of I? In the first time, it will take the value as 0. it has to run 4 times. You understand? This code is going to run 4 times. After that, what will happen is, in the first instance, it will take value as 0, then 1, then 2, then 3. This is the value it is going to take one after the other. So for first time, what is going to happen? The first index values from both of the list is going to be added. 1 plus 4. Okay, so this operation happened for the first time. So when this operation happened, what I'm saying is that I'm not just doing this operation, I'm also adding. Okay, I'm just adding this element to my empty list. Okay, why I'm doing this? So that I get a new list which consists of the addition of both of the elements together. So this is why I have to write this code. Okay, then it goes to the first place in both of the lists, then it goes to the second place, then it goes to the third index values. Exactly. So this is one way. You can't simply just use plus and add the elements of two lists together. Okay. No, it is not possible without loop, because using plus, it does the concatenation. Okay, and I'll show you that if I want to do the addition inside of numpy, is it possible if I use just simply plus symbol? Is it able to do the addition like what we wanted? Okay, so this is the concept list slicing and list. I'll tell you this concept list slicing also. Let's first go and see more of it. Okay, so now you understand that we have something called list, and we are going to study something called array. Okay, so now what I'm doing is, just don't worry about this code. Just see that what is the thing I'm going to show you. I'm just doing a memory comparison. I'll explain you what these things are. Just see that code. What
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
what comparison I'm doing, and how much difference I'm talking about, how much advantage NumPy basically has over other packages or other data types that we have inside of my Python. Okay, so let me show you first. So this is a list. Okay, I'm making a list that consists of 100 elements. Okay, and I'm making an array, which is my NumPy array, that consists of 100 elements. Okay, I have made two lists that consist. One is a list, and second is my array, which is my NumPy array. Okay, so I made these two elements. Now, if I'm checking the size, how much size one element is taking inside of this list, and how much size one value takes inside of an array. So let me show you that. If this is the thing, this is one module that is there, and it has some functionality. Okay, you can see it later. Don't worry about this code. Just see the things that I'm doing. Okay, so what I have done is I have made one basic variable, okay, which consists of some number. And if I check the size of it, it is showing me that it is taking 28 bytes. Okay, it is taking a huge memory. It is taking a lot of memory. And if I talk about, if I make a list, if I put in other values also, and if I run this thing again, it shows you that it is taking much value or a lot more memory than simply variables. Okay, so this is about list. It is taking lot memory that we have understood. We have just used 3 elements, and it is taking so much of memory. Okay, now if I check the size for similarly for the size of the arrays, how much size it is taking, how much size the arrays are taking. Okay, so if I check the size of it, I'm checking the size for 100 elements inside of array. Okay, it is showing me that it is taking 904 bytes. And if I check for one single item, how many bytes it is taking, it is occupying only 4 bytes. Okay, compared to this 28 bytes, we have made one variable. If I'm checking for one simple item, it is showing me that it only takes 4 bytes. In the cases of list, level of some level of the efficiency is being done, some level of things are happening, which basically does the memory efficiency. Okay, it will not keep taking a lot more space. Okay, just a minute. It will not simply take a lot many space if we have more elements. It will not keep taking 28 memory every single time. It is doing a little bit of efficiency in the background. But what is the thing? if you are checking for an item, it will be 4 bytes every single time. Okay, in the case of arrays, if you check for 100 elements, okay, in here 100 elements we have, and here if you check, it is taking only 400 bytes. Okay, so if I compare it to you, okay, sorry, I told you that this is an numpy array. This is my list array, which consists of this 100 elements. And for this, if I'm checking the size of it, it is showing me 904 bytes it is taking. And similarly, compared to that, my numpy array is taking only 400 bytes. So this was one example how much difference it makes. And if I take more values, so in real world, you will not be interacting with only 100 values or 200 values. You will be interacting with millions, sometimes 10 million, sometimes 100 million values. So in that case, this number, this difference is going to be huge. Okay, you can see that it is more than double if we are talking about 10,000 elements. Okay, so now we can see the real difference. Okay, so this was about memory, how much efficient NumPy arrays are compared to lists. Now, if I show you how faster it is compared to a list. So what I'm doing is I'm just making a list, and what I'm doing is I'm doing the square of every single element, and I'm making a new list of all the square of all the list elements. So it will start from 0, it will go till 999. Okay, it will start from basically 0 till 999. And what it will do, it will do the square of every single element, and it will start to put inside of a new list. Okay, so for this operation, if I check the time it is taking, this is one way you check the time of any operation. So if you are checking the time that my Python is taking to run this operation, it is showing me that 323 microseconds it is taking, plus minus 2.78 it is taking. Okay, so this is the thing, this you have seen the figure of it. Now for the same thing, if I am doing for NumPy arrays, if I am taking 100 elements, 0 to 999, and if I'm doing the square of it, what is the time it is going to take? So you can see that it is taking only 2.505 microseconds. So you can see that it is the difference of more than 200, basically 150. Okay, and this is the huge difference. This is a very huge difference. You can see we are just talking about 100,000 elements here. If this number was much more greater than this, so you can understand the time it would take to execute basic commands, basic functions. It will take a huge lot time. Okay, so this is the advantage. This is the advantage that NumPy arrays have compared to lists. That is why NumPy is used for every single mathematical computation. Whatever computation you have to do inside of a Python, the NumPy library is going to be your preferred choice every single time if you have to do any operation. And there are much more functionalities. We'll see what more things are present inside of NumPy, which makes our life easier. Okay, so if you have to create a NumPy array, what you can do is you can simply take a list. Okay, so I am taking this list one, and whatever way you make a list, you can just simply make any single list. And what you have to do is you have to just write, you have to just make a NumPy array out of it. So in this case, what will you be passing? This is the way you have to use this thing. So you have written this thing. What will happen is if I just print this, see, it has converted this list of ours, this another data type we have had. This is converted into a NumPy array by just simply using np.array. So this is the first way. This is the first way we create NumPy arrays. Okay. What more ways we have to create NumPy array? We can convert a tuple also. So this is our tuple. If you want to convert my tuple into a NumPy array, we just have to create one tuple and I'll be passing that tuple directly. Okay. And this way it has converted tuple also into this. Okay. But what is the thing? You can use other thing inside of list also. So if I write this thing, stu, and if I make a list that consists of string also, okay. So if I'm making this thing and it consists of 1 and then 1.2 and then 3. Okay, so this is one list, and when I convert it into my NumPy array, Will it be able to give us this? Will it be able to convert it into numpy array? Let's see that. Okay. So we are checking this thing, ARR, and then we have this list. Okay. So you can see that it has converted this also into a numpy array. But is it correct? If you have studied about the concept of arrays or whatever I told you, so is it the correct way? Should we do this thing? Okay, it is happening in the background. If we are doing this operation, it is being allowed by the Python. But is it logically correct? We should we do this thing? Okay. So Bhagyarekha, you said no. So would you like to give some reason why should we not do this thing? So when we are talking about this concept of arrays, even if it is allowing us to take different type of elements, we should not do it, because what will happen? It will simply defeat the purpose. It will simply nullify the purpose that the array has. Why do we use array? It consists of same data type, and when we have same data types, we can perform a lot more calculation operations. So suppose what will happen if I have made this array, this one, and another list also consists of some values. If I want to add two lists, it will not be able to do that, because if at this place, suppose Python is there, and at this place another list is there, which is consisting of, like, let me show you, consisting of 1, 2, 3, and 4. Okay, so this string and this integer value cannot be added, or it cannot be multiplied also, it cannot be divided also. So it will simply defeat the whole purpose of using arrays. Okay, so that is why we have to just make sure that whenever we are making a numpy array, it consists of similar type of data. You have to, if you want to make a array of all the strings, that is completely fine, but you need to make sure that you put strings only, no integers, no float values. That is the thing. Okay, now here what we have done is we have made one list, and we simply pass this variable. This variable consists of this list values, and we have passed this variable here. But instead of that, if I want to simply pass my list here, that also we can do. Okay, and if you have lesser element, you can simply do this thing also. But if you have a bigger list that consists of 50 elements, 100 elements, so you will not go on writing that thing together directly here. So in that case, what you can do is you can just simply make a list with whatever logic you are making a list. If you have a list, you can simply pass that variable here, like we have this list variable. You can simply pass it on here inside of here. So you are making np dot array you have here, and if you want to pass simply a list, you can pass that also, and you can pass whatever is the name of the list. If I write the name of the list, that you can directly pass. So that both way is possible, both way are correct. Okay, now there is something, there are some methods that we can use on numpy arrays. Okay, and these methods tell us something, they give us some information. Okay, so inside of it, if we want to check the dimension of the array. Okay, so what we can do, if I want to check the dimension, I have made this array. So by seeing this array, you can tell me that what is the dimension. If you can tell me what, by just seeing this one array that we have made, all the arrays, be it this one, be it this one, be it this one, what is the dimension of this array? 1D. Okay, you can simply see it and just verify that it is one dimensional array. Okay, it consists of only one row and some column elements there. Now, if I want to check the dimension, you have to just write the name of your array, whatever array you have made. We have made here a array. So that with this, if I write dot endim, okay, after endim, you don't need to write any bracket, anything like that. Just write end dimension. So what it will give you, it will give you whatever is the dimension of your array that you have created. If you want to check the shape of your array, okay, if you want to check the shape of it, it will check you the shape of, tell you the shape also. So what shape tells you that how many rows, how many columns are there. So here it is showing me 4 comma. So what this comma means? Okay, what kind of data type it is showing this? If you remember from the previous concept, if you have read about list, tuple, strings, so what kind of data is this? 4 and comma. Okay, yes, I understand that this is row and column. So what kind of data? Yeah, exactly. So this is a kind of tuple. If you have made tuple, you know that if you are putting single values inside of a tuple, if you are making one tuple, and if you are having just one element. So in that case, what you have to do is you have to write that element name. After that, you have to put a comma. Okay, and if you have more elements, if you have suppose more than one element, in the end, in that case, you don't need to put a comma. But if you have just one single element, then you will be putting a comma. So from this, what we can understand is whatever output it is giving us is in the form of a tuple. Okay, so this is the information it is giving it to us. Okay, so whatever we are studying, we will be using the concept that you have studied till this point. Before this session, whatever concept you have studied, we will be using that in some small manner. Okay, so that is why the Python basics you have been taught. That is what the purpose of it. Right. Now we have created our 1D array. Now we have to create our 2D array. How can we make our 2D array? So to make a 2D array, if I'm making 2D ARR, if I have to do this thing, what will I be doing? I can make a 2D list also and simply pass that 2D list directly here. Okay, sorry. This you cannot start the name of a variable with number that you already know. Okay, so if I want to make a 2D array, I can take a two-dimensional list. How a two-dimensional list? I've told you that if you put list inside of a list, then you have two-dimensional array. If you put a list inside of another list, so that way what you have is you have three-dimensional list, and you can simply convert this into a array. Okay, so what we'll be doing here is that you try it out, try that part, make a 2D list and just try to pass it here, the name of it, try to pass it here. But what we'll be doing is we'll be using this raw method. What I'm going to make is I'm going to make this thing. Let's see that how it works. So I'll just put 1 2 here, and I'll make another list that consists of 3 and 4, and I have to just put it inside of another list. Okay, so this is what I told you about two-dimensional list. I pass two-dimensional list directly here, and if I see this D2 ARR.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
D2 ARR. Then it is going to show us that it has made us now two-dimensional array. So you can see that we have 2 rows and 2 columns. It is now two-dimensional. So this way also you can see that we have made this two-dimensional array. This is very simple. You just need to give it two-dimensional values and it will able to convert it into 2 dimension. Okay. Okay, lambda function is a very powerful, very useful function. You can do a lot of things with it. Okay, so I guess I'll move forward. Right. So you've made this two-dimensional array. This is the way you make a two-dimensional array. You can simply pass a two-dimensional list, or you can make a two-dimensional list directly here. When you check the dimension of it, it will show you that it is 2, which means it is two-dimensional. Now, if you check the shape of it, this B we are talking about, we check the shape of it, it is showing you that we have 2 rows and then we have 3 columns that you can simply see. This is the thing it is going to show us. Okay, 2, 3, 2 rows and 3 columns. Now, if we want to create a 3D array, how can we make a 3D array? Like I shown you that if you want to make a 3D list, how can you make a 3D list? You just have to do the nesting. One list you made, and inside of it, you make 2 simple lists. Okay, and inside of it, again, you make 2 lists here, here, and then in this one list. Okay, this is one list. We have then 2 smaller lists, and then inside of it we have comma, and then we have one list here. So you can see that I have put 2 lists inside of one bigger list, and then this complete list is inside of another bigger list. So 3 level of nesting we have done. So this is the way you make a 3-dimensional list or an array. So very similar to that, you can simply just make a 3-dimensional. You can just simply pass a 3-dimensional list, or you can make a 3-dimensional list like how you make a list. Okay, and then you can pass the name of that list. So what it will do the same exact thing. Now, when you see the dimension of it, you can simply understand that it is 3 dimension. Here it will show you something different. Okay, it will not give you just 2 rows, 2 columns, and there is some other thing. This is what this is telling us is we have two, length 2, breadth 2, and depth 2. Okay, so this looks similar to this one. So this is how 3 dimensional array is made. It will have some length, it will have some breadth, and it will have some depth. Okay, so this will give you 3 things in your shape, right? So 1D array is called vector. So whenever you hear this term being used inside of anywhere inside of data science, you can just simply understand vector is 1D array, and 2D array is a matrix. And after 2D, be it 3D, be it 4D, be it 5D array, whatever array is there, whatever dimension of array which is there after 2D array will be called tensor. Okay, so these are the names that you will be hearing. So if you hear these names, don't get confused. So, okay, 2D array is a matrix. This will be used a lot many times. 2D array and this dimension. All of these arrays are being used based on whatever is the requirement of it. Okay, so these are the names, just basically names for these arrays. Now, what we have done till this point, we have done the manual creation of arrays. So we have manually created arrays. How we did it? We use some list, we use some tuples, or we just pass directly some list inside of np.array, and we were able to create our arrays, numpy array. Now there are some functions available. We just can use those functions and we can get along with making our complete array. Okay, we don't need to write the complete thing. So what is the first function? This is the first function. This is called np.arrange. Okay, np.arrange. So when you have studied the concept of for loop, there you have heard about this word called range function. So inside of range, you would have given some values if you wanted to run this for like 10 times. So this is the thing you would have seen. Okay, you remember this range function inside of for loop. Do you remember this range function? Have you used this range function in for loop? This has some functionality, this range function. Yes, okay. So very similar to that, this arrange function is just a basic extension of this range function. It does similar tasks, but when being used in NP, it is called a range. Just apart, instead of calling it range, it is called a range. So inside of it, whatever value you give, it will give you that many elements, starting from 0, going till n minus 1. It will not give you 10, it will stop one place before it. So that is the case that you have seen in almost all of the things. Then indexing will always start from 0 when you are talking in Python. Indexing will always start with 0 and it will stop one place before the whatever is the highest point you have given. Till this point, it will not give you 10. It will stop one place before it. Okay. Now, this range function also consisted of something called what will be the start value, what is the end value that you want to put, and what is the skip value, what is the step value you want to put. Okay, by default, the step value is 1. Okay, if you're talking about range function or arrange function, you can put first value, which will be your start value. The second value will be your end value, wherever you want to end. And then the skip, if you don't write this third thing, if you don't write this third value, what it will do, it will take by default as 1. But if you want to skip more values, if you want to skip by 2, 3, any number of skip you can do. So what it will do, it will just skip those many elements and it will give you whatever thing that is left after it. So this is the thing. It is similar in range function also, and it is similar in arrange function also. Okay, so this is one thing. Now, if you want to create an array of linearly spaced out values, okay, and this linearly spaced out values can be in any range. It can start from 0 to 100. You can start from 0 to 5 also, 0 to 6. So let me show you. If I go from 0 to 5, you can see that from 0 to 100, it gave me 6 values. Okay, so why 6 values it gave us? We gave how many points we want. We said to the Python that using this linspace function, give me linearly spaced out values. So you can see the difference between them is 20, 20 points, 20, 20, 20. What it has done, starting point would be 0, end point was my 100, and the number of points would be whatever number of points I mentioned here. Okay, so what I want to do is from 0 to 5, I want to take 10 points. So if you write this from 0 to 5, what it will give you is, it will give you linearly spaced out values. Okay, and anything you can put 50 also here. You can, this number of points could be anything if you want to take 10 number of points. So what it will give you, it has given you a function with which what you can do, you can make some linearly spaced out array. Okay, you don't need to write these values. If you want to get a value something like this, this is what it is going to give you. Okay, so this is what the concept of lin space. It will give you linearly spaced out values. Okay, so let's see what more is there. Now there is something called np.ones. This ones module is np.zeros and np.ones. Why do we use it? If you want to initialize some array, okay, if you want to initialize with some array with little bit of it, y is not increasing by 5. Here it is not increasing by 5. Okay, so this is doing whatever it is doing in the background. Okay, we can't control it, we can't just do anything about it. So if you see that from going from 0 to 5, it is now giving us 5 points, which is linearly spaced out. Okay, so write out whatever is your confusion, try it out. So as you can see that if you have given from 0 to 5, and if you have told me that, if you told Python that give me 5 points which are linearly spaced out, in some cases it might show you some different value, but it will not be very different. It will be very similar or very close to it. Linearly spaced means the spacing between all of these elements will be same. Okay, so if I just, for simplicity, if I just start with the first example, what we had was, I want 6 elements. Starting from 0, I want to go till 100. I want 6 elements. And these 6 elements should be linearly spaced out. Means here you can see the difference is 20. Here also the difference is 20. Here also the difference is 20. Here also the difference is 20. And simply if I make it 10, what it is going to give us is 0, 11 point. I don't know why it is doing this thing, but it should give you 0 to 10, then 20, then 30. It should give us in that manner itself, 0, 1. This basically does linearly spacing out. There is some problem, I don't know. I'll check it out why it is showing something like that, because in some cases it is working perfectly fine. In some cases it is showing you some different values. Okay, I'll check you and let you know. No worries about that. Means equal part. Yes, Robin, equal parts. Okay, so the difference between the elements should be equal. Okay, so for just simplicity, let it be. Now, till this point, what we have done was we have created some arrays, okay, with some point. Now I don't know from the start when I'm making an array, I don't know what elements or what values I want to put inside of my array. So what I can do, I can initialize with some default value. Okay, I can initialize an array with a default value. For that, we have np.ones and then we have np.zeros. These are two things which is present for us so that we can initialize our array. So what will be the initial value? At every place, this will just put 1 and 1 for whatever dimension if I put. If I put 4 by 4, so it will give us for that dimension 1 and 1. Okay, and these all values are float value. As you can see, it is 1 point. Okay, so this is a float value. All of the points which will be there inside of it, it will be float values. Okay, by default, it is float values. Yes, the output is always in float. When you use np.ones, by default, whatever value it is giving to you, it is float. Okay, 1.0 it does not write, it is just writing 1 point. Okay, 1 point. So that basically means 1.0. Now you simply similar to that np.ones, if you use np.zeros, so what it will give you, whatever dimension you put it here, by default it will give you all zeros. Okay, so what will happen after it? So if you have initialized some array, what you can do at later stage, you can change their values. With whatever value you want to put it, you can change their values. I'll show you how we change the values inside of a array. Okay, let's see what more is there. We have something called np.full. So in this case, what will we do is, first parameter is my 3 and 3. So this is telling me the dimension of it, and second value is my 5. Okay, So before moving forward, you must be getting confused that how do I know that what values I should put inside of it? Somewhere it is just simply dimension, writing the dimension. Somewhere here you can see that I have put dimension and then I have put the numbers, some value I have put. So to clear that confusion, what we can do is we can simply search for what we were studying, np.full or np.full. Let's search for. So always, if you're getting confused about something, because you will not be able to remember every single thing here. These are very small methods, small functions. So you don't need to remember them also. By working, if you have worked on lot many projects, it will become a second nature to you. But if you have missed out, if you are not able to remember it, you can just simply search for this thing. np.full, if you write, you'll go onto this documentation. And inside of it, you can simply see that what are the values it is showing you. Reading the documentation is what makes you a much better programmer compared to other programmers, whoever is out there. They are just following whatever someone has told them. They are not seeing that what is happening in the background. What are the values we can put? What are the things we can do? So for that, just just for a reference, just one go through the documentation of it, and it will tell you everything, whatever you wanted to know. Just search for it. So in this case, you can see that the first parameter that we can write is shape. So shape of the new array, it could be something like that. It could be simple too. So that we have done first thing. Then what is there? Fill value. Okay, so this is the second thing that we have had, fill value. So in this fill value, you can have one single number also. We can have array also. So here what we have done similar thing. We just saw this documentation. You don't need to write every single parameter which is there inside of it. If you want to do this thing, this one or two first parameters will be useful for you, or maybe you will be using them in most of the cases. So this shape I understood, and this fill value I have to put. Okay, so this is the exact thing what I've done here. The shape could be in the manner of 3 by 3, or simply I could write 3. And this number, whatever number I want to fill it with, I have written it here. So if I want to fill it with 10, that also I have written it here. Now we have np.full, we have seen, we have np.I. In this case, what will be there? If you want to see about np.I, just do a simple Google search of it. And where you have to go, you'll see this first website, which will say numpy.org. So this is the official website. There only you have to go. It will show you other results also. But go onto this website. It will give you the documentation in very detailed manner. So there you have to go to refer whatever you have to see. Right. So np.I. So in this, whatever is it is showing you, whatever thing you have to put it here, it will show you in the documentation. Just see the documentation and it will tell you what things you can put here. So what I'm saying it to do is what I'm saying is np.I and 3. So what it will do, it will make a 3 cross 3 dimension. Okay, it will make 3 cross 3 dimension, 3 rows and 3 columns. And in the diagonal, it will pull all the one values. Only one it will pull. Right. So np.I is this. If you want to change the dimension, by default, if you just keep one value, it will make related to that. If I write np.4, so you can see that 4 cross 4 it is making. But if you want to change the column, change the number of columns, so for that you will be writing whatever columns you want. If you want 4 cross 2, simply write 4 cross 2. So in that manner, whatever diagonal it will find at that place, it will simply put 1. Okay, at that place. So you can see that it has only found two diagonal places. So here at only two places, it will put 1. As you can see, this is very similar to that. At only diagonal places, it will put 1. Now, if you want to keep some other values at diagonal place, for that you will not be using np.I, you will be using something called np.diag. Inside of it, whatever list you give, whatever values you give, it will just make a list of that dimension. Okay, an array of that dimension. So you have given 1, 2, 3. So it has C. It has by default, it has changed the dimension to keep these values only at diagonal places. Okay, you can see that what it is doing. Now for this thing, you have made this thing. If you want to extract the diagonal value, suppose from any array you have made, you want to extract the diagonal value. Okay, so if you just use np.diag, give the name of the array. Give the name of the array and it will just extract the diagonal value from it. Okay, so from here, if I run again now, it will show you that it has fetched the diagonal values and kept it into another array. So it has made us another array for us. So if you are not assigning it to any variable, it is not permanent. If I assign it to it, now it is permanent. But if I don't assign it to any other variable, it is just showing you on a temporary basis. Okay, so if you want to keep any value permanent, you have to assign it to any variable, whatever name you want to put it. You can just say that name, you can just write that name, and with using that name, it will save it value for permanent. Okay, very similar to that, we have seen np.diag. Similar to that, we have something called random.rand. So this will give you something in this manner. It will give you random values. Okay, and these are not just any random values. They are statistical values. Okay, based on some statistical values, it is giving you these random numbers. Okay. So there is something called random.rand. If you give only one, it will give you it will give you an array in this manner. So 4 elements we have inside of one dimensional array. If you want to give the dimension, complete dimension you want, or you have something in your mind, if you have another dimension you can in your mind, you can just simply put the dimension here. So what it will do is it will make 4 cross 4 matrix consisting of all the random values. Okay, so you can take it one step further. So what is happening here? It is making now 3-dimensional matrix, 3-dimensional array for us. So this is the thing that you can put here. Now after that we have something called np.random.rand. So this is another thing. So inside of it, what is the thing? It consists of standard normal distribution. Okay, don't worry about this concept. When I explain you the statistics part, there you will be able to understand what is standard normal distribution and what is the value it is keeping. But for now, for simplicity part, you can see that it is taking some random numbers and it is just putting inside of your array. Okay, so you can think of it as array initialization also. Okay, so where these things will be used? These things will be used a lot, and you will understand when you are making project, you will be encountered with something like this. You will be making all of these things. Okay, nothing, whatever you have studied here, it will not go in vain. Every concept, every single concept you will use in whatever conditions. Okay, in some condition this random function will be used, in some condition this diag will be used, in some condition np.zeros, np.1 will be used. So you will do this thing whenever you are doing practical, you will meet with one of these concepts. Okay, so we have seen that how we can do the creation of the arrays. Now let's see that what are the type of data that we have inside of our numpy array. So to be clear, an array can be list, tuple, dictionary. Yes, an array can be anything. If you pass it a list, it will create with that elements only. If you pass it a tuple, it will create with that only, that elements only. For dictionary, you have to do something different. Okay, because with the concept of dictionary, you know that it does not simply consist of only the values. It consists of key value pairs. Okay, so you cannot put both the values together. You have to take the items, means you have to take only the values. You don't have to take the keys. Or if you want to put the keys, and for that you will have to just extract the keys. Okay, and this logic you must have studied in the concept of when you were studying this dictionary, when you were studying this thing. Okay, so the first thing we have is we can see that when we were using np.arrange, whatever values we were getting, this was all integer type. Okay, so this was all integer type, you can see it. Now if I want to convert it into float, I have created this array which is consisting of 10 elements from 0 to 9. If I want to convert all of these into float, I'll have to just write one another parameter. And how do I know that I can use this thing? Just go on to search about np.arrange. If you search on this thing, this np.arrange you will be using a lot. So you need to know basic things about it. What are the things that is there inside of np.arrange? So if you go to this documentation, you just have to read 1-2 basic things. It shows you that start, stop, step, these are things you can put, and D type you can put. By default, it is none. And you what other thing you can do, if you want to convert it into float, if you want to convert it into int, that you have to simply write here. Okay, so this is the thing. Now what is happening, if I give it one extra parameter, what I am telling it to do is convert all these integer values into my float value. Okay, float 64 is just one new name for, because most of the systems are now 64-bit. So something similar to that, you can understand float 64 is mentioned. Okay, and if you want to make it integer again, you will be writing n64. If you have some integer values like np.ones, you saw that in np.ones we have all float values. But if I want to convert that into here, that convert it into integer, I just have to pass it another parameter. So if I just np.zeros also I show you, when I said to my program that convert the data type into integer, so now it is now converting every single data into integer. So this is what is happening. Now, what are some other data types? We are very much familiar with integer and float, but what other data types can exist inside of my numpy array is this complex number. So this complex number already also you are very familiar with. So inside of a numpy array, we can also put complex number. If there is some calculation which requires you to use complex number, so you can always make an array of complex numbers also. So that is completely possible inside of your numpy array. You can make an array of Boolean values also. Boolean values are basically true and false values. So you can make an array consisting of these values only. And what will you do if you have this array? You can pass it somewhere. You can pass it into any loop condition. So whenever it is finding true, it will run that loop. Whenever it is finding that to be false, it will not run that loop. So that experimentation, you can keep doing it. It will increase your programming logic. Okay, right. So after that, what you can do is we can always put string values also. So if you are putting string, all values, we need to make sure that we are putting in string values only. Okay. So these are some of the concepts, what kind of data that we have inside of our. Okay, after that, we have something called indexing and slicing. So what is the concept of indexing and slicing? Okay, indexing and slicing. So what is indexing and slicing? So this concept of indexing and this concept of slicing you have seen in list. Okay, so let me show you that these things you are basically familiar with. So moving forward, if you understand this thing, then you will be able to understand this thing also very easily. So let me show you what is the concept of list slicing. So what does basically slicing do? Can anyone tell me what thing we get when we do the slicing? What is the thing? Why we do slicing? We could just simply use, or we could just simply make another list. Why do we need to do the slicing? So we get a subset of a list. So in the case when we have small list, we can always make many small lists. But when we have bigger number of elements, we have more number of elements. So in that case, we can simply use this small slicing concept, which is very powerful, which is very effective, and it will give us a subset of the complete list. We could need this subset for many reasons. So for that purpose, what we will get is we will get a slice of this complete list. And this slicing does not need to be like 10 to 40 only will get, only 50 to 80 will get, whatever condition you put in. If you put the step value to be 2, so what it will do, it will skip 20, it will give 10, 30, 50, and 70. These are the things you will get. So whatever type of subset you want to get, you can just simply tell. You can just simply write the concept for it. So what is this thing? What is this thing basically? So this tells me that if I have not written anything on the start, okay, if I'm not writing here numbers, so this is the way we do the slicing. If I want to take from 0 to any part, from 0 to 4, what it will do, it will take my 0th value, and then it will take my 0, 1, 2, and 3. At these places, whatever value is there, it will take all of those values. It will not go till 4. Okay, so this is the way. And if I just skip this thing, if I don't write anything for the start value, if I don't write anything for the end value, what it is going to do is it by default supposes that you are saying it to start from very start and go till very end because you have not put any condition. So it will start from very start, it will go till the very end, wherever the end is finishing, the list is finishing. Okay, so this is the thing. Now you can just, if you put some stop condition. So you want to start from zero, you want to go till fifth position. So before five, it is going to stop and it is going to give you this. Okay. And if you want to get this indexing, so this is the thing, numbers. If I run this part, this is the thing you are going to get. And if you want to get something from this location, if you want to get something from two location, what it is going to, this is my 0th index, this is my first index, and this is my second index. So this is the value that it is going to give us. So this is basically the concept of slicing and indexing that we are going to see here in arrays also. And if you I think you must know about this thing, but if you want to do the reverse indexing, what you have to write, if you suppose want to get this 80, okay, so I don't want to count from very start, like 0 1 2 3 4 5 6. I don't want to count it. If I know that from starting it is very close to the start, so in that case what I can write is I will simply write my negative indexing. So it will start from this point, and if I write -1 to -4, so let's sorry, -4 to -1. So if I write this thing, see what is happening. So this is basically a reverse indexing. Okay. So if you see this, if you want to start, then your end value, and then here also you will have your step value. If you want to step it out, if you want to jump for some elements, you can do that thing. It is very similar to what we have seen. Okay, in the range function also it is there. You can see it is present here also. That also you can do. Okay, so whatever thing you want to do, you can just simply write that thing. Right. So reverse indexing, you can do this part. Okay. Now,
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
we will see that how this thing happens and how indexing and slicing works in the context of numpy arrays. So this is a chart. This shows us that where these elements are actually.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so you have a matrix of 3 cross 3. If you have a matrix, or you can say that this is an array of 3 cross 3. So I told you that if it is a 2D array, you can say it a matrix. The name for the 2D array is matrix. Okay, so I have this matrix. It is a 2D array. So what will be the element? What is the address of the elements? What is being stored here? So if whatever element is there at this place, so this is the address I'll be using to take that element or to change that element. So this is the address of that element. Okay, so it is taking the row and column names, column numbers, and it is just telling me at that this is the addresses. If you want to access any element which is there at 2 comma 2, you have to use 2 comma 2. Okay, so how we are going to use this thing, let me show you. So what I'm making is, if I just mute this out, what is the thing I have is ARR. So if I show you that you have made this simple 1 to 5. And if you want to get something which is at the fifth location, if you are writing 5, what it is going to give us is this 5. Okay, 5 was present at fifth location. So this is what you are going to get. Okay, so this is the similar concept of indexing that you have seen here. Now, let's understand that what other things we can do is, now see how we can use these things, how we can use these addresses to get some element which is present at these locations. If something is present at 1 2, if something is present at 2 2, how we can get that value. Okay, so what I have done is I've made a diagonal matrix. So it will make a 2D matrix for us. And inside of it, if I go to this 2 comma 2, so what is the thing it is showing us? So at this place, this is the location which is 2 comma 2. And you can see that at this place, there would be 3. So if I run this again, you can see that at this location, 3 is there. So if you want to access anything, you will be using this concept. This addresses you are going to use and you will get whatever element you want out of it. Okay. Now you have got something from it. If you want to change some values, okay, this matrix is completely mutable. It can be changed. It is like a list. It can be changed. List also could be changed. Whatever element is present inside of a list could be changed. So similarly, whatever value is there inside of my array, numpy array, it could be changed. So what I want to do is at this location, this is my 2, 1. So you can see this is my 2, 1 location. At this location, I want to change the value from what was there from 0 to 5. So I just have to call that location. First, I have to access that location and simply by writing 5. If I write 5, if I want to keep 10 here, I can just simply write 10 here. Whatever value you give to any location, it will just make that change. So this is what you're doing is this. This is called data manipulation. You are manipulating the data. You're making some permanent change to the data, right? Okay, so we have seen the concept of indexing. This is how you do indexing. Very basic, very similar to how you have done indexing in the concept of list. Now let's see how we can do the slicing here. So for slicing also, the concept is very similar to the concept of list. So I made simple array, which consists of 10 elements again. I want to take from starting from 1, I want to go till 7, and I want to skip 2 elements in the between. Okay, so this is the thing that you have seen in list also. If I just skip this thing, it will now give us, it will now give us starting from 1 to 7. So this is the thing it is going to give us. If you want to skip anything from in the between, if you want to skip 3 steps, that is what you are going to write. So if you write here, so this is what you are going to get, right? So this is the concept of slicing, very similar to what you have done in this. Now, we can also combine the assignment and slicing. How we can combine this slicing and the concept of indexing? Let's see. So you have seen that if I want to get something from this location, I have to just mention that location. So here, what I'm saying is I have made one array, which is my this 0 to 9. I want to change all the values starting from 5 till very end. Whatever is the end, go till the very end and change all the values altogether. Okay, I want to change all of the values at once. So for that, what I'll write is I have made one this thing, and when I do this, when I just do this, let's see what happens. So what I have told is this: take the location which starts from 5, goes till the very end, and put 10 at every single place. So what is this doing is it is just replacing all the values in one single command. Okay, you have just given it one simple logic and it has replaced all the values which started from 5 and went till the last location. Okay, so now we have when we have made our arrange function, when we used our arrange function, what it was giving us. So if I just give this thing, so this reshape I'll tell you in more details. So what you can do is when you use this arrange function and you have 10 elements inside of it, starting from 0 going till 9, these many elements I have. Okay, so let's just take. So for this, if I want to reshape it, so how am I reshaping it? This is the way I am reshaping it. Okay, so I have 9 elements. So I know that I can put 9 elements in something like this. So if I change this dimension, let's see if it works. Okay, it is just telling you that not those many elements is not simply present here. Now, if I just put value 12 here, you can see that it is now working because we have 12 elements to put into this dimension. Okay, so this is the thing. You can reshape it by just using the reshape command. Okay, by using reshape function. Inside of it, whatever dimension you give, it will convert that into that dimension. Okay. Now, if you want to get something from these locations, so let me show you that what I want to get. So I made one thing, and what is the thing I made here is, just let me take 9, and then at this location I change it with 1 comma 10 comma 1. So what I'm saying, basically start from 1, go till 10, and just skip steps would be 1 and 1. So what I want to do, I want to take these elements 5, 6, 8, and 9. So I know their locations from where they are starting. I know their locations. So using slicing, I will do this thing. So what I know is, this is my first row. Okay, this is my 0th row. This is my first row. This is my second row. Okay, and this is 258 is my first column. 369 is my second column. So if I want to get this thing, what I'll be writing, first thing is my row, whatever is there before comma. Okay, so till this point, what we have done was, we have just simply used a single. We have just simply used single times. Okay, in this case, what it will do is, it will check, it will do this operation for only rows. But when you have used comma, and after comma, if you have given something, now by default, what it becomes, this, it understands this is your row, whatever thing you are going to give it for. This is for rows, and this is for your columns. Okay, and these are the locations you want to extract from. Now what is going to happen? First, it will see that I want to, here it is written that you have to start from first row, go till the very last row. So my first row starts here and goes till this second row only. Okay, if I had more rows, it will go till 4 rows, 5 rows, 6 rows, it will go till that location. Now, second one is my column. Start from first column and go till very last column. So this 258 is my first column, 369 is my second column. So you can understand that these are my common elements which satisfy this condition. 5, 6, 8, and 9 is my common values which basically satisfy my condition. Okay, so you can basically understand that we have to start from here, and we have to start from 2, 3, 5, and 6. So I cannot take 2, 3 here. I cannot take 1 also. I cannot take 4 and 7 also. Okay, so any confusion? So you have seen that how we can do the slicing. Okay, how, if I want to get some values which is present at some location, how we can do that. So for that, we have this concept of this thing, slicing. Okay, so for this, I am doing this one extra thing. So if I just write one here, let me show you what I am telling you is that if you just write 2 comma, so what it means is, you have given the value for only row, only for row. But if you put comma, and after comma, if you put something similar to that, what will happen is, it is now understanding this has to be my column values. Okay, this is my row values, this is my column location. This is basically locations. So what it is showing, telling me that start from second row. Okay, start from second row, go till the very end row. So here we only have till second row itself. So it will take only these values. Okay, so if I just run this, so it will take only these values, and what I'm saying, telling it to do is, take only this row and take these columns 2 and 3. Okay, you understand, these columns I have to take, and for row I have to take only this row. So this is the common element. What is the common element? Only 8 and 9. So this is what I am taking. This is just one way to slice it out. Okay, so now you have understood this concept also. Okay, so if I don't give any if I don't give for any column, if I don't put anything after comma, what it will do is, it will just understand that I have to select every single column which is there. But for rows, I have this condition. My row will be starting from one place only. It will not start from 0, which is 1, 2, 3. It has to start from 4, 5, 6, 7, 8, 9. These many values I have to take. But for columns, I don't have any value. I will be taking all of the column values. This is the thing. And whatever is the common element in both of those things, that is what we are fetching. Right. So we have done this also. Now let's see what are the numerical operations. The the addition, the subtraction that we have talked about. Let's see how these operations happen, how these numerical operations inside of numpy, and how easy it is basically compared to list, how easy it is to do this numerical operations. Let's see. So I make one simple numpy array, and what I'm doing is +1. I'm just telling you that when I write this +1, what will happen is it will start adding 1 to each and every element one by one. Okay, so I have 1, 2, 3, and 4. If I want to suppose add 5. So this is very simple. So you can see that by just writing this one single thing by plus and 5, we are able to add something into our numpy array. And this is not possible inside of our list. Okay, this is not possible. If you have to add, if you do this thing, it will just simply append this into a list. But directly also it will not append. You have to make it into a list. Okay. So to solve that problem, to make it much more easier, we have something like this inside of my numpy array. Okay, so you see that what it has done, it has just added this scalar value to all of those values one after the other. Let's see. If I want to do this thing, if I want to do the exponentiation, for in the case of list, if I want to do this thing, I will have to write a for loop. Okay, I will have to write a for loop. But in here, I don't need to write any for loop. I just have to mention this thing, whatever is my numpy array, the name of my numpy array, and this exponentiation symbol, which what it is doing, it is just raising it to the power of 2. If I just tell it that raise it to the power of 3, it will do that thing also very simple, very easily. Okay, so this is what I was talking about. If you have to do any mathematical computation, if you have to do anything related to mathematics, you will be using numpy. It makes your life much more easier. Okay. Now we have np.once. If I add 1 to it, that is also possible here. So what I have done is I have made my np.once and I have added 1. So what it has done, it has just simply taken all the values and added 1 to all of these values. Right. Now if I want to subtract two numpy arrays, how can I do that? So that is also very simple. I can simply use this minus symbol. I don't need to run any loop. I don't need to do any complex thing. I have two arrays, which is my first array is this 6, 7, 8, 9, and my second array is this 2, 2, 2. So if I no second array is my A. So what I am making is this is my first array I am making. This is my second array I am making. So when I run both of these things, let me show you that what is going to happen. So it is taking one element from this, and it is just doing the subtraction. Okay, so 2 minus 1, 1 we have 2 minus 2, we have 0, we have 2, and then 3, we have 1, minus 1, and then 2 minus 4 is minus 2. So this is what it is giving it to you. And why we have float values? Because we have used np.once. You can mute this float values by passing it d type is equal to int64. So you can get integer values altogether. Now you can simply do this multiplication also. You just have to write this one symbol a cross b, and it will do the multiplication element wise. Okay, every time any operation you are doing, it will do element wise. Okay, not directly everything will happen, not array wise, element wise operations is going to happen. Okay, so now you see that what it did, 2 cross 1 is 2, 2 cross 2 is 4, here 2 cross 3 is 6. So this is what it is doing. Now if you have to do matrix multiplication, how you can do a matrix multiplication? So what is a matrix? Matrix is a 2D array. So you have made a 2D array using your diag function. You can use whatever function you want to use. You can use once also, you can use arrange function, you can reshape it also, whatever concept I have taught you till this point. Using any of those things, you can simply make a matrix. And what will happen is, if you do this thing, if you just do this C cross C, what will happen is, at those diagonal positions, it is doing this C cross C, okay? It is doing this multiplication, 1 cross 1, 2 cross 2, 4, 3 cross 3, 9, and then 4 cross 4, 16. So it is doing matrix multiplication. So I guess you understand the concept of how matrix multiplication happens. So this basically, this row will be multiplied to this column at first time. So then this row will be multiplied to the second column, then third, then fourth. So this is what is going to happen. And when you do C cross C, when you multiply both of these metrics, you will find out that this is the output that you're going to get. So this is one way. If you have to multiply two metrics, you can simply make use of this multiplication symbol. Or the second thing what you can do is use the dot command, use the dot function. Okay, so when you use this dot function, inside of it, you have to write another matrix name. It could be anything. If you have made a matrix by the name B, that also you can simply put here. What will happen is C cross C or C dot C, both of these matrices will multiply. Okay, so this is what is going to happen. Okay, so this is just one thing I have printed out. These stars, I just simply printed them out to separate this thing. Okay, so this is nothing. I just printed out these stars to separate both of these things. So this is one way we do matrix multiplication, and to just separate it out, I printed these stars. And then we have second way, which is dot C. So this is how we do the matrix multiplication also. Now let's see how we can do comparison of elements inside of an array. Okay, this is just simple matrix multiplication. If you are not able to remember this matrix multiplication, this you can just see on the internet, you will be able to understand. Now let's see how comparisons happen. So we have two array. I just made two array. If I do the comparison, how can I do the comparison? So you know that this is, what is this sign? Is equal to, in every single programming language, this is equal to simply checks whether the value on the left is equal to value on the right. So this is what is equal to means. Let me show you that what I am doing here. You can pick any of the things. So whatever thing we have studied. So let me show you. If I want to take, you are saying that take a matrix like this, which has some values. Okay, so I'm just picking this thing. Okay, so let me show you that what I am trying to tell you. So this is my ARR1. I can say that this is my ARR1. Now I'll make another array, which is very simple to that, which is this. Okay, and I'll change the values here. And this could be starting from here going till 20. And if I just, okay, so now we have some values, right? Let me show you. Here are one, and then what my array 2 looks like. Okay, so this is what my array 2 looks like. So you now understand that what I have done, I have basically made two matrices. What is a matrix? It is called a 2D array. 2D array is called a matrix. Okay, so this is the thing you understand, that this is my first array. Okay, this consists of some value. Then we have second array. This consists of some value. Okay, now what I want to do is, if I have to do the matrix multiplication, if I have to do the multiplication of both of the matrices. Okay, so till this point, what we have done was, we have basically done the, if I have simply 1D array like this, if I have this 1D array like scalar, and I want to do the multiplication, I could do this thing. I could do star and star. If I have two matrices like what I have taken here, you can understand I have taken the first matrix, my 1D scalar. Okay, 1D array is my this B. This is my second array, which is A. Okay, these two things I have taken. And when I multiply this, what will happen is, it will do element-wise multiplication. It will start multiplying these values one after the other. If I print A also, let me show you what is happening. 2 and 1 multiplied, we get 2. Okay, so let me put it here. So 2 and 1, we have 2. 2 and 2, we have 4. 2 and 3, we have 6. And 2 and 4, we have 8. So this we understood, that if we have 1D array, and if you want to do the multiplication, this is how it is happening. And this is the way you can do the subtraction also. This is the way you can do the addition also. So that you have understood this thing. Now what I'm doing is, here I have taken two 1D array. Now here what I'm doing is, I'm just taking 2D arrays, two 2D arrays. One is my ARR1, and don't worry about this thing. This is just what I'm doing is, I'm just making a 2D array. You can make 2D array using np.zeros also, np.ones also, np.diag also. So these are all the ways how you can make a 2D array. That we have already seen. You can use np.array function also. So that will give you some values. So what I want is I want to make a 2D array which consists of these values 3 cross 3. I have done the reshaping. It is doing the 3 cross 3 matrix. This is what I am getting by doing this operation. This is the way we make 10 elements. We make an array, 1D array of 10 elements. But this is just one dimension. And if I want to change the dimension of it, I have something called reshape function. Inside of it, if I write these rows and these columns, so what it will do, it will make this, it will convert this 1D array into my 2D array. So this is what is happening. Now I have got my first ARR1 is my first matrix. Now ARR2 is my second matrix. These two matrices I have got. After that, what I'm doing, what I told you is that here, if you want to multiply these two matrices, okay, so for 1D array you have seen, for 2D array, this is very similar to this. So what you have to do is this thing I told you, that print C cross C. So let's print this thing so that you can understand this concept. Here are 1 and there 2. So this side, when I do this thing, you can see that it is doing matrix multiplication. Okay, in a manner how matrix multiplication happens, the same manner it is doing the multiplication here. Okay, so you get this point now, or are you clear with this point now, or do I have to explain it further? This is just the concept of matrix multiplication. This is there inside of linear algebra. There is nothing new that is happening here. This is just the concept of matrix multiplication. These two matrices are being multiplied. Okay. And if you want to read more about matrix multiplication, how matrix multiplication happens, just watch these concepts and you will be able to understand. Okay. So this is what is happening here. So this is what I was just trying to say. I've just done the multiplication. Previously, I've done for 1D array. Here, I'm doing for 2D array. But that's the only thing I've done here. Okay. So you can see it again if you want to see it. I've just made two arrays, and array 1 and array 2. These are my two arrays, and when you print it out, it will show you something like this, and then something like this. And then when you do the multiplication, it will simply do the multiplication, right? Okay. What is happening is, just see what is happening. So when you're using this this star, what it is doing, it is doing the element wise multiplication. Okay, so this I forgot to mention. When you're doing this thing, what is happening is, now if I print ARR1 dot ARR2, so this is what giving me the matrix multiplication. So this is what is giving me matrix multiplication. And when I do this similar thing, when I do this, when I use this star symbol, what it is going to give me, that it is doing the element wise multiplication. So first place 1 and 10, it is just multiplying this thing. 2 and 11, it is just multiplying this thing. 3 and 12, it is just multiplying this thing. Okay, so this was the thing. Okay, so sorry, I did not mention that. I just slipped off my mind. Okay. So this is what is basically happening. This is why we were having different values. This is the basic concept. If you have to do the matrix multiplication, you will be using this dot. And if you want to do the element wise multiplication for both of these arrays, this is my first array, this is my second array. If I want to do element wise multiplication, this is how am I going to do this. Okay. Now for the comparison thing. If you want to simply do the element wise comparison, this is how you are going to do this. So what I've done is I've just simply made two arrays. Okay, so to make any array, what you can do is just a1 you can write, and what I'm doing is just np dot arrays array, and you can write any value here. You can write 10, 20, and 30. You can write it here, and then we have a2, which is np dot array, and then we have 40, 50, and 60. Okay, so code along with me and you will understand. So now what I'm doing is code along with me and you will understand this. So what it is giving you is, it is comparing for every single position. For 10 and 40 is comparing For 20 and 50, it is comparing 30 and 60 and 8. Okay, sorry. A1 and A2. When I do this comparison, it will show you that not any element is equal here. Now, if I change it to 10 again, and you can see that at this place, it is showing you that these two elements at the index position 0, these two elements are basically similar. Okay, so this is what my comparison is. Now, let's see what second comparison I have. Second comparison, I can check for whether one element in one list is greater than one element in another list. So what we can check here is that if I check for this A1 and A2, let me print it out. So what I'm doing is this. For A2, if I have this, it will show me that it is not greater than. This 10 is not greater than 10. This 20 is not greater than 50. This 30 is not greater than 60. So if I just do this is equal to, now it is showing me that 10 is greater than is equal to 10, which is true. And it is giving me that. So it is doing basically element wise comparison. Okay, so now we have seen element wise comparison. Now, if you have three arrays, if you want to check for element wise comparison, you have another way which is called np.equal. So if I check for this here, now I have made these two arrays. Okay, so now I made two array A1 and A2. If I do this np.equal, if I do this thing, what it will give me is I have to write these two elements, A1 and A2, is going to show me the same thing. Okay, it will just check me whether at which position the elements are equal. This is just going to check the same thing, exact same thing. Okay, so np dot equal, if you want to write, you can write this thing, or equal to equal to. Okay, so this is the same thing. Now, if you want to do the array wise comparison, the complete array will be checked. Okay, and at any place the element is not matching. So what it will show us is, so let me show you. If I change this thing, let me do it for this one only. What I want to do is np dot array equal. So this is what I am doing here is array equal. If I am doing this thing, np dot array equal, whether a1 and a2 is equal or not.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So it will do it will not do element wise comparison. It is not checking for one element, two, and two element. So it is giving me basically this. Now, if I want to make this to, if I change this values to same thing, and when I check this again, it is telling me that now both of the arrays are equal. Now both of the elements are very identical. Whatever element is there inside of it, it is identical. Even if I change one element inside of it, what will happen is it will give me false. Okay, because even if one element falls, the complete comparison does not match. Okay, so this is what is np.array equal. Okay, now we have something called logical comparison. So here what we can do is logical OR and logical AND. So what is basically logical OR and logical AND? Can someone tell me what is there? So when in this logical OR, if we have 1 and 1, what will be at this place? Okay, when we do the logical OR 1 and 1, what we get? Can someone please tell me? 1. Okay, and then we have 1 and 0. What it will print? For 1 and 0, it is going to give us what? So this is what is happening. So here you can see that only in the case of 0 and 0, it will show me false. Okay, why false? Because 0 is considered to be a false value. Okay, so whenever it is written anywhere, if you want to write anywhere, 0 is considered to be basically false. So false and false becomes false. Okay, so this is what it is showing it to us. Now, in case of logical AND, what will happen is, in the case of logical AND, what will happen? If we have 1 and 0, what is the thing it is going to give us? Okay, will it give us 1? Will it give us 0? What is the thing it is going to give us? Okay, false, exactly. So in the case of logical AND is you need to have at both of these places, you need to have value as true. Okay, so 1 is considered to be true and then it is also true. So 1 and 1 both becomes my true. Okay, and apart from that, wherever, even if one value is 0, it is just going to give us false. Okay, so this is what the condition of logical OR and logical AND basically means. Right. So if you are good with this, we can move forward with it. So now we have something called array mathematics. So how some of the operations, we have seen some operations previously also. Now let me show you what more is happening here. So if I make any A1, if I take my A1 also, and if I do np dot sum, and then I put my A1. What was my A1? Let me show you what was my A1. What is the thing that we have made A1? So there is something called sum function. Okay, what does sum function do is it will take whatever array you have and it will simply add all the elements together. Okay, it will simply add all the elements together and give us the result. So 10 plus 20 plus 30, it is just summing it up all the values. Okay, so this is what it does. Okay, what if I remove d type is equal to bool? Okay, let's do that also. See, d type is equal to bool means it just converted these values into boolean. Okay, so that the comparison could be similar. So what will happen is at the place of 1, if I was converting it into boolean, what will happen is at every place wherever it is written 1, it will in the background it will take it as a true value. Okay, so it is just mean that at the place of 1 I have written true. That is what it was showing. When I have written d type is equal to bool, that is what it was doing in the background. Okay, and if I remove it, it is just taking these elements and 1 and 1. Okay, so that is just one thing, so that the operation don't fail. Okay, so for that purpose we have written d type is equal to bool. Okay, because you know that in logical OR and logical AND, what we have is we just check for true or true and then true. So what we do is, just let me show you, we check for this. If there is true and then true, then what will be third value? This will be true. So for that purpose, so this operation to happen very smoothly, we have just converted this into Boolean type. That is what we have done. If you remove this thing, then also it will work. But so that this operation don't fail, for that purpose, we have converted this. Right. Now we have something called, let's see how sum works and how subtraction works. Let's see how these things work here. Now we have one array, which is my this 1, 2, 3, 4. Then we have 5, 6, 7, 8. This is my second array. If I just do the sum of it, if I do the sum of A, it will just take the sum of all of the elements and it will give us that value. Okay, and if I just check for B, and it will give us this value. The sum of all of these elements, 5 plus 6, 11, 7, 18, and then 18 plus 8, 26. So this is what it is going to give us. Now, A plus B, the same thing. Okay, so A plus B, if I do, what it will do is, see what it is going to do. If you do A plus B, then it will take both of these arrays, which is my first array is what? 1, 2, 3, 4. My second array is what? If I just print it out, what is my A for simplicity? And then if I just print out what is B, so this is what it is doing. 1 and 5, 6, 2 and 6, 8, 3 and 7, 10, 4 and 8, 12. So this is what it is giving us. So using this one simple plus simple, what we can do is we can add two arrays. Okay, we can simply add the elements of two arrays. So this is as simple as that. Now, if I do this np dot subtract ab, what will happen is, now see what we were doing is, we have this array A, we have array B. If I do the subtract operation, what will happen? 1 minus 5 minus 4, 2 minus 6 minus 4, 3 minus 7 minus 4 again, 4 minus 8 minus 4 again. If I change it to like, so this is what it is going to do us. Now it is taking B first, this 5 minus 1, 4, this 6 minus 2 is 4, 7 minus 3 is basically 4, and 8 minus 4 is basically 4. This is what we have done. Okay, so this is the thing that is happening here. And similar thing will happen if you write this thing also. If you now write b minus a, this is what you are going to get. So both of these are similar. Now we have something called divide. So you can see that for divide, we have also something like this. If I want to divide two arrays, if I want to divide a by b, that also we can do. We just have to use this division symbol. Okay, just what I'm writing is a division 2 b. Then it is going to divide it by 2. If I want to divide it by one scalar number also, that also I can do. I'm just writing this thing. Now if I do this also, that if I'm taking my first array as a, second is my one scalar number. So in this case also what will happen, all the elements will divide by one after the other. Okay, so in a, if you see what is there inside of a, we have 1 2 3 and 4. So if I divide it by 2, what will happen? 0 0.5, 1.1, and then 1.5, and then 2. So these are the things that is the output that we are getting here. Okay, so this also you understood. Now comes the multiply. Multiply also you understand, we have seen it much more detail. So for this similar thing, we have this np.multiply. Okay, so now the thing is clear that dot c was the dot function that we used was doing matrix multiplication. But if you want to do the simple multiplication is this. Either we can use this star symbol or we can use this multiply. Okay, so both are fine. Now we have done this thing also. If I want to check to do more mathematical operation, what I'm doing is I'm doing the exponentiation. So in this case, what will happen is I'm taking a and I'm doing the exponential. Okay, so e to the power a. So what is there inside of my a? Let me show you. My a consists of 1, 2, 3, and 4. So what will happen? This is what going to happen. E raised to the power of a. Okay, so a means first time it will be 1, second time it will be 2. So this is what is happening here in this case. Okay, so np dot, this is what happening here is e to the power of 1, then 2, then 3, then 4. This is what is happening, and whatever result you'll get, you can simply check on Google also. This is the same result you are going to get when you do this exponentiation. Now, if you want to check the sign also, you want to check the log also, you want to check the cos value. So this similar thing we have seen that it was present in math module also. And this sign is present in this numpy package also. So you can use whatever, if you want to use it from math module, that also is possible. That also you can do. And if you want to do it this way, dot also you can do. This is perfectly fine. This is both of them basically serve the same purpose. Okay, so now this what we have done is it will take all the values. First time it will take 1, then it will take 2, then it will take 3, then it will take 4, and whatever is the sign value for these values, it will just give us sign value. Now for log, you know that log 1 is 0, so that is showing here. Then it will take for 1, 2, 3. So these are the things that is showing. Okay, log 0 is 0. Okay. Sorry, log 1. Yes, 1, 2, 3, and 4. So this is what it is printing us. Now, if you want to calculate the min, mean, and median, so you can do this also. If you want to do this, if you want to find the mean of any array, whatever is the mean of any array, you can do that. So what I have done is, this is my, if I run this thing, now this is my a. I want to check the mean. So you know that mean is the average. So if you calculate this thing, 1, 2, 3 plus 3, 4, and then 4. So we have, this is 10. 10 divided by 4, I'll get 2.5. So this is giving me the mean for this array itself. This could be a very long, very huge array. And when you are going to find the mean of it, you will be getting the mean of it. Very simple. And let me show you with one example so that you can understand it. Let me show you that this is a data set. Okay, just for explanation, I'm telling you this. So how this mean is actually applicable in real world, how you can find the mean of it and how you can use it to real world. So this is a data set. Okay, so this is a data I'm using. What this data consists of is, this is my one row, this is my first column, second column, third column, and fourth column. So this data consists of something. These are some values which consist of something. Okay, and if I show you that what this data consists of, like what was the name, population.txt. So if I go inside of it, if I run this, if I show you that what is the thing. So first column is my 1900, which is my year. Okay, this is my year. Then we have here, then we have links, and then we have carry. So these are the values which is there for these things. So what it means is, first column tells me that in these year, this was the number of rabbits which is present in Canada. This was the number of links which is present in Canada, and these are the number of carrots which was produced in Canada. So these are some hypothetical numbers. This kind of data you will be working with in real world. The data will be looking something like that. Okay, you will have some columns, and then you will have the rows, and rows will consist of values whichever has been collected for these features. Okay, so this, in this one first row, what it is giving us is, right, so this is basically the path of the tribe. Okay, so now let me show you that where this mean is basically used. I'll explain you this concept in a bit more detail in next session. So for this part, let me show you how mean is going to be used. So here what we did was, we took a basic array. So this consists of some values. So we took the mean of this array only. But in the real world, if I want to take the mean, what mean will I be taking? So let me show you that. So this, you understand that these are similar. This is similar to what we have, what I have shown you. This is basically a matrix. Okay, this is 2D array. You can think of it as a 2D array. Here, if I want to check the mean, so what I'm writing is population, or if I write simply, let me run this part just a minute. If I run this, it has just loaded everything which is there into this file. Now what I am saying is, take data, this is my data, is my file, data.mean. If I am doing this thing, data.mean, very similar to what we have done here was.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
np.mean, and then we have put the data here. Okay, so here I'm doing something different, data.mean, and axis is equal to 0. Let me show you what it is giving us. So for each of the column, it is giving me basically the mean of it. For each of the column, it is basically giving me the mean of every column. Okay, so this is what how you will be using the mean, whatever mean I've told you, and this min function, how you are going to use this min function also. So let me show you how can I use this min function. So data.min, what I'm checking is that I just want to know, I have a big data, I don't know that what is the minimum element present in every single column. I don't know what is the minimum value. So here I don't want to see and just check that this is my minimum value. So for this, what I have done is, if I'm checking that data.minimum, from this data file, check the minimum value. Okay, so what it will do is, it will check me for this column. So 1900 is my minimum from here. From here, you can see that 7600 is my minimum. From here also, some value will be minimum, which is 4000, and then 36,700. Now, what is this? Axis is equal to 0. Now, if I do axis is equal to 1, what will happen? So it will just give me for this, for every row. Now it is checking for every single row. When I have given axis is equal to 0, it is checking column wise. If I give axis is equal to 1, it is now checking row wise. Okay, so in every row you can see that this 1900, 1901, these are the minimum values. So this is what it is printing us. If I just simply do it max, if I do this max from every single column, whatever will be the maximum value, it is just going to show us. Okay, axis is equal to 1, it will check row wise, and axis is equal to 0, it is going to show us column wise. That is what we have done. Okay, so now I guess that you are able to understand all the concepts, whatever we have covered here. So you can write it this way also, np.max, and you can write the name of the array, or you can simply write the name of the array, which is a.max. Okay, so if you write this thing also, it is similar to that. So these are the concepts that we have seen. So from here, we will see in the next class. So some more concepts are left in NumPy. And I hope that uh, if you want me to go through some concepts again, I'll just go through them again. So for this point, you can just see that what I've done here. We are going to see that some basic operations. We will try to take a data, okay, which consists of some rows and columns. And with that, what I'll do is I'll basically try to show you that how we can load data with NumPy. Generally, this loading of the data, whatever work we do with data, it does not happen directly with NumPy. It happens directly with pandas. But for your understanding how we can do that thing with NumPy also, for that thing, I'll just show you what we are doing. So first thing first, what I am doing is we are taking this, we are importing our NumPy. Okay. So before working, or if you have started your Python file again, so you have to run every single cell again. Okay. And you have to import this NumPy whenever you want to work. Okay. So I'm just running this file again. So for that purpose, I am importing NumPy here itself. You can import anywhere, wherever you are feeling the need to import any library, you can just directly import that thing here itself. Okay. So we have this. Okay. So I'm just trying to show you that we have, we are making one variable. Inside of it, what I'm doing is I'm using one method, which is np.loadtxt. So inside of NumPy, I told you that NumPy is basically a library. And inside of library that, sir, I joined late. Can you give me an overview? So there was nothing, I was not explaining anything. I was just giving you some information that you have not missed anything, Ashwarya. We will move forward and you will understand everything. Don't worry about it. Okay. So this np.loadtxt, what we have inside of it is, this is a method that is there inside of NumPy. Inside, it takes some parameters. Okay. It takes some values, and what values it takes, you just have to give the name of the file in which you have saved your data. Whatever data it could be in the, it should be basically in the format of rows and columns. The same format you will see in Excel files also, use same format if you are familiar with CSV files. So that same format, if I show you that how that format looks like. So basically we will have some rows, we will have some columns, and they will consist of some values. Okay. And what are these values? You don't need to worry about these values are. I have taken some data, and a similar kind of thing you will see in every single data. Okay. You will have some rows. What are the rows? The whatever value has been collected regarding this. So in this rows, every data will be basically here. Here, I have the number of rabbits, which was there in any state or any country I've taken this. This data was basically there for you to understand. So here lynx is another animal. So it shows that how many animals were there who are lynx. And this is the number of carrots in that city, how much is the number at a current time. This is the data that has been collected, and every single data will look in the format of this basically. So now what we have is, for loading that data, we have to write this. Inside of NumPy, what we are writing, we are using load.txt. What are supported format of txt file, comma, separated, space, spatial? I'll touch on that. Okay, Bharat, I'll touch on that. Just after this, I'll touch on every kind of data. What is the kind of data available to us? Okay. So here you loaded this data inside of it. This is basically your variable inside of it. What you have done after you have run this operation, what will happen is every single data which is there inside of population.txt, what will happen is it will now be loaded inside of your data, this variable. What will happen if you have loaded everything? You can now start working with this data in your Python notebook file. Okay, if you don't import your file, you cannot work it here. So after you have imported your file, after you have got your file to this Python notebook that you're working in, after that only you will be able to do whatever manipulation you have to do. Okay, so I explained you that NumPy is basically a data manipulation tool, a data manipulation package we have. So this does some operations, some calculations. So these are the things which is there inside of NumPy. Okay. So what I've done is, after I've loaded this thing, when I print out this data, this is how it will look like. So what it has done to this data, you can see that this data looks in the format of rows and columns. So after you have loaded your data, what it did was it converted into a format of arrays that we are familiar with. Okay, because that is what the work of NumPy is. It converts whatever data you give it into the format of an array. So if I just check the dimension of it, if I just try to check what is the dimension of it, so, and then if I just see, so you can see that this is a bigger file which consists of so many of values. And what it is basically, it is a two-dimensional array that we are familiar with. So till the point what we were doing, we were manually giving some values. We were giving some small values. We were giving some just random values to understand how 2D array, how matrix looks like. Here, if you have some data in the format of rows and columns, if you convert that with NumPy, what we have done, we have loaded it. And when we see this, NumPy has converted that data into the format of rows and columns. So what will happen now? You are familiar with this kind of thing. Okay, you are now familiar with this two-dimensional data. And what you can do with this, you have understood already that we have so many of the methods. We have min, max, whatever I taught you till this point. You have so many things that you can do on this data basically. So this is now a 2D data that you've got. Okay. So now we have data. We have seen the dimension of it. It is now understood that this is a 2D array that we are now familiar with. What we can do is we can check the mean of it. Okay. So what I'm doing is I'm just taking my data, whatever is your variable in which you have loaded it. On this, you will write your mean. Okay. And if you want to check for this x is equal to 0, you can do that also. So what it is doing basically, so column wise, it is taking the mean. Okay, so 1910, 34,080. So if you see this, it is taking column wise. If you have given x is equal to 0, what it is doing is, for this complete column, for every single value which is present in my first column, it is calculating that mean. Okay, for second column also, for third column also, for fourth column also, this is what is happening. It is calculating the mean. Now, if you change the axis of it, just changing the axis of it, what it is doing is now is it is calculating the mean based on every single row. So now it is doing this way. Okay, so x is equal to 1, this way it will be doing it. So by just checking the axis, you can see that what it is showing, and by just seeing the output, whatever output you are seeing, you will be able to understand this is the thing. Okay. Yes, basically you can understand what zeros and ones are. By just seeing at it, you can understand what type of value it is showing. Okay. Right. So now data.max, here also what I'm doing is I'm just taking my data. On that, I have my max function that I can do. In here also, by default, axis would be something. So if I don't write this axis is equal to 0, then also it is taking some max. But what max it is taking, we are not sure of it. Okay, to this point, we are not sure that what max it is taking. Okay, so if you can understand, basically, it is taking for the whole data. Okay, for the whole data, whatever was the maximum value, it has taken that maximum value from the whole data. Okay, and if I run this also for mean, also let us check. If I remove this, what it is giving, it is basically, I guess, that it is giving us a mean for the complete data. Okay, so we have some small numbers here, we have big numbers. So what it is doing, it is taking all the numbers and it is giving us mean of that. So it is not much logical to us. Okay, we are not able to understand, we are not able to get any single information from it. So either we could do column wise or we could do row wise. Okay, so that is the thing you have to pass in. So that these are the values you have to pass in. If you give it axis 1, these are the values it will just print us. Okay, so now what if I don't want to take this first column? Okay, if I don't want to take this year column, I just want to take these columns, which is my second, third, and fourth column, and I want to do some operation of it. If data contain text file, whether mean in NP will work. No, for text file, how can you convert mean? Okay, because mean is a statistical value. So for any statistical value to work on, you need to have a number which is data which is in numerical format. You can never find a mean or max or minimum for any text data. Okay, so that is what it is. So in NumPy, basically, if you see what we have been doing is we can surely make NumPy of characters. We can take string values inside of NumPy and we can make an array of that. But what is happening over time, you're seeing that with NumPy, you are basically performing some mathematical calculations. So for performing mathematical calculations, you will be always taking numerical data. There is no sense in taking textual data. So that is what we are having. So the concern of textual data will be solved when we study pandas. I'll show you why why panda has been already actually made. Okay. So just hold that thought for a minute. Okay. So now what I'm doing is I'm making another variable, which is my populations. And inside of it, what I'm saying is take the complete uh, data that we have imported here. And here, if you see what I'm doing is we are basically doing the slicing. We are taking a sub part of the complete format, the complete data that we have. So what I'm saying is, let me show you data inside of it. If I give this, what it will do, it will take all the rows, okay, starting from very start, going till the very end. But in the columns, I don't want this 0th column. Okay, here I don't want this 0th column, which is my year column. I want to start from here. So the index for the second column is basically 1. Index start from 0. So the index column for this one is 1. So we will write that thing. So if you start from 1 and go till the very end, you could write 4 also, 3 also, whatever you want to do. You can write this. So what it will do, it will just take first and second column. Okay, the index at first and second. If you write, if you don't write anything, it will go till the very end and pick every single column after 1. Okay, so this is a subsection of the data that we have taken. Okay, now what we are having is we want to calculate the mean on that also. The procedure is basically saying you have to write the name of the variable in which you have imported your data, in which you have taken a subsection of the or slice of the data. You have to write your mean method. Okay, when you write dot mean, and inside of it, you just have to give axis 0 or 1, whatever you give. Based on that, you will be getting some answers. So what is happening? It is calculating the mean for all single columns. Okay. So this is the answer that you could find by just doing this one single operation. You don't have to do anything. You have just imported your data. You have just used one method which is present inside of NumPy. You don't have to write any line of code. You don't have to write any condition. You don't have to write any function. Whatever it is there, you don't need to check which values, or you don't need to write any function for basically calculating the mean. What it is doing, the code is already written in the background. You're just using the method of it, which is present inside of your NumPy library, complete NumPy library. Okay. Okay. Access is basically this. Okay.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So how am I taking this thing? So if I show you like np.math, so if I show you, so here you can see that np.max x1 x2 np. Yes, axis. Yes. So here you see that for whatever thing I'm telling you, for whatever things I'm teaching you here, is that you are working with NumPy and we are working with basically one method. Let's suppose we are working with mean here, okay? And inside of it, it will be taking some values here. So how do you know what values it is taking? You can simply go on and search for it on its documentation. So when you land onto this documentation, we now know that we have what we are working with is numpy.ndarray. Inside of it, there is one function which is max. Okay, and what it takes these values. So we can take one of these values and we can just simply pass on it. So axis is equal to axis basically tells you that in what manner you want to find the mean. Okay, so if I remove this axis, what was happening is this. So if I just remove this axis, it was finding the mean of the complete data. And that I thought that it was not much more meaningful to me. I'm not getting any information by just calculating the mean of complete data. Okay. So what I'm doing is I'm taking this, I think you are familiar with it. What I've taken, I'm taken my variable, which is data. Inside of it, my numpy is now loaded. This data set is now loaded inside of it. And this is a 2D array, basically. 2D array. So we are familiar with what operations we can do on 2D array. So you just think this as a big 2D array. Okay, we have already made 2D arrays. We have already made matrices. So you take this as a big 2D array. Okay, this is why we loaded this data. This numpy has converted into 2D array. So on it, what we can do, we have studied about this operations. We have studied about that we can find mean, we can find median, we can find minimum value, we can find maximum value. So that is what I'm doing. I've taken my data variable. On it, I'm doing my mean. Okay, I'm finding my mean, and inside of it, if I am just doing this data.mean, what it is doing, it is finding the mean for the complete data. But you know that this is not one single data. This consists of so many of the data for year, here, number of rabbits, number of links, number of carrots. So this is not any logical thing to do to just find mean for the complete data. You're not getting any information. So what you can do is you can just give an parameter basically to this, which is axis is equal to 0 or either one. These two axes it will take. Okay. So axis is equal to 0 or 1. Basically, these two things axis always take. Okay, these two values axis will be taking anywhere. Okay, these are the values which has been assigned for this. Now axis is equal to 0. What you are getting is for every column. So now you see that what we have is 4 values separated by comma. 1910, this is a float value. Okay, so after 0, after dot, it has not written it anything. Basically it should be 0. So this is the way it is showing your information. What we have is we have something, we have a mean, we have again mean, we have again mean, and we have again mean. So what are these 4 values? Basically these 4 values are, for first column we have some mean. Okay, it is basically what it is doing. You must be aware how we calculate mean. It is basically taking the average of this complete column. Okay, so what we have is the average of this complete column is 1910. You can calculate it, you will find this same answer. The average of this second column is given here in the format of this 34080. So this is what the average of this second column. For this third column, we have calculated mean. For this fourth column also, we have calculated mean. This is what it is showing. And if you convert it into axis is equal to 1, now instead of giving the mean for column wise, what it is doing is it is calculating mean every single row wise. Okay, for this row, it is giving one mean. For this row, it is giving one mean. What it is giving? The average of it. Average of 4 values calculated, it is just showing that to us. Okay, so you can see when you calculate row wise, you will get something like that only. Okay, so this is what the concept of axis is. Okay, so now what we have done, we have taken this population data. In that, what we did was we got rid of one column. So now why did I write this thing? So in the concept of list also, I told you that if you understand the concept of list, this numpy array is basically very familiar, very similar to that concept. So here what we are doing is we are just doing simple slicing of the complete data that we have. We have 4 columns basically and some number of rows. Okay, so what I want to do is I want to take only second, third, and fourth column. I don't want to take my first column, which is my year. Okay, I don't want to take it. So for that, what I'll be doing is if I just write this one and this. If I just write this, what will happen is it will just give you everything starting from. So if I show you, it is giving starting from first row till the last row. Okay. If you don't give two numbers, if you don't give any comma, so what would it do is basically it will take this value for the rows. Okay, it will do the slicing on the rows. So if you have to take all the rows, and what you want to do is you want to take the column starting from this. You want to get rid of 0th column. This is the index value. So this is the 0th column. This is my first column, second column, and then third column. So what you're writing is start with the first column and go till the very last column. So this is the only way. If you omit this comma, what you will be doing is you will not be getting this thing. So yeah, I'll print the output. So now what we are doing is you can see that we have completely got rid of our year column. Okay, we now don't have year column. We have completely got rid of it. So what this thing is, the first value, whatever value you give, this will be considered your row. For row, you have given some condition. Now, if you're writing here, if I show you, if you're writing starting from 1 to 8, basically, I'm going 1 to 8. This is selection for my row. And what I want to say is just take the selection on the column. This is my selection for the column. This is my selection for the row. This is what is happening with this case. Okay. So that it is what it is doing. It is very similar to what we have seen in the case of list. Okay. So there also this slicing was happening in that similar manner. Okay. So we have two values. The first will be considered for the rows, whatever condition you give for the rows, starting value, end value. It will take those rows, those number of rows. And after separated by comma, if you give any value, if you want to take only starting from 2, so what it will do, it will take these values itself. Okay, it will take now third and fourth column. It has basically removed 0th column and first column. Okay, so this is what it has done. Okay, so now when we are clear with this I have taken. Now when I calculate the mean on it, we are getting mean on it also. If I want to calculate what is the minimum value in any column, so that also we can just print this thing. So now you can see here is that we have only few number of rows. So what we can do is, if we have time, we can basically see on this row and we can see that what is the minimum value. But it will take time, it will take hassle, and this is never a way. If you are doing a programming, this is never a way to do something manually. If you can do something with by writing code, if you can make something much more easier, so that is the thing you have to do. So why to just manually go and see for the minimum value to calculate the mean of it, and why to write a function for it? Okay, we have already seen, if we are familiar with what kind of code we could write for finding the minimum value, what we can write for finding calculating the mean of it. So just saving ourselves from that hassle also, to avoid that also, we have this functionality built inside of NumPy. What we are doing is we are just using one method that is present inside of my NumPy package. I already told you that NumPy is a package. Inside of it, it consists of a lot of functions. It consists of a lot of variables. So you can think of it as a one function which is there inside of NumPy package basically. And in this function, what we are doing is we are giving some parameters. So based on this parameter only, it understands what you're trying to say. So when you have given x is equal to 0, it has basically taken for the column wise. So column wise, it is giving whatever is the minimum value in that column. Okay. So these are some of the basic things so that you understand how NumPy works on a data. And every data that you take will be in the format of this, in the format of rows and columns that you are already familiar with if you have worked on Excel anytime. Okay. Now we have something called array manipulation. So there is something called this array manipulation. Okay, in array manipulation, we have something. These are the things that we have inside of array manipulation. So what I'm doing is we have numpy.concatenate. It does something. Numpy.vstack, hstack, column stack. These are the things. Let's see one example of it, what these mean and how it is useful for us basically. Okay, so what I'm doing is I'm simply making So if I just show it to you. So what I'm doing is I'm simply making two arrays. Okay. So this is one method for making array. I'm doing this. For making our second array, I'm taking another value. Okay. So what it does is it gave me basically two arrays, which is one dimensional arrays, and both have four values inside of it. So now what I want to do is I just want to do this thing. Okay. So if I write np dot concatenate, and inside of it, what are the values it will be taking? So here, this is the basic syntax of it, np.concatenate. If you write, this is the syntax of it. In here, if you have to give only one value, it is okay. But if you have to give more than one value, which will be required, at least two values if you have to give, if you have to concatenate them. What is concatenation? Basically adding the two values together, putting them side by side. Okay. So what we are doing is we are taking two simple arrays, two one-dimensional arrays, and what we are doing is we are taking these two arrays we have, and what I'm saying is do the concatenation of it. Okay. So what will happen is if I run this thing, and if I just do this np.concatenation, so by default axis is equal to 0 is already there. Okay. And if you want to, let's see axis is equal to 1 is working or not here. Axis is equal to work, one is not basically working here. Okay, so concatenation, what concatenation does is it adds two values side by side. So what we have first array, which is A. So if I print out what is A and what is B, so A is basically this and B is basically this. Okay, so A and B are these values. So what is happening? 0, 1, 2, 3, 4, 5, 6, 7. These are concatenated together and has made one bigger array by adding these things. What we are doing is we are taking np.addStack, and what we have done is we have taken some values which is A and B. These are the two arrays we have. And if I run this thing, what it is doing the horizontal stacking. Stacking means it is uh, taking both the arrays and it is putting them side by side. Stacking means basically adding them on the top of each other or basically in the sidewise. Okay. So what we have done is we have these two arrays and we have put them side by side, but we have made them into one bigger array. Okay. So what we have done, we have basically added these two and we have put them side by side. So this is how it looks like. So two simple arrays, two small arrays now have become into one bigger array. Now, what is the other thing we can do? np.vstack, if I write, and inside of it, if I give both of my arrays, what it will do? Now you can see that it has done the stacking. It has put both the values in column wise. So what it has done? So first array it took and second array it took, it put below it. Okay, so this is what it has done. Both in this done in horizontal style. This stacking has been done in vertical format. Okay, so this thing what you have done, you were able to convert two basic one-dimensional arrays into two-dimensional array. So this is how stacking has been done. So this was the concept of concatenate, what it is doing. This was the concept of horizontal stacking. This is the concept of vertical stacking. So in this case, you can see that in the case of vertical stacking, it has not added them together into one single bigger array. It has taken both of these arrays and it has put them one after the other. So this is what it is doing. It is doing the vertical stacking of the both of the arrays. Okay. So now, what is the column stacking? What happens with the column stacking? When we take two values, what we can do is we can do the column stacking. So here, what I'm doing is I'm taking two one-dimensional arrays. So if I write this out, np.column stack, and inside of it, it will again take two parameters, which is A and B. What will happen with this case is you will be able to make them column wise. So what it has done is 0, 1, 2, 3 was my first. If I show you my array A is 0, 1, 2, 3, my array B is 4, 5, 6, and 7. So what is taking? It is making them column wise. Okay. So 0, 1, 2, 3 now has become column. 4, 5, 6, 7 has now become in the format of column. So this is the thing that it has done in the background. Okay. Now we have something called at split. So what this basically means is we are doing the splitting of whatever array we have made. Okay. So if I just mute it out, so what we have done is, you understand, first I have taken numpy array which has value from 0 to 15. Okay, this is one dimensional array from 0 to 15. What we are doing is we are doing the reshaping of it. Okay, so when I reshape it, this is what it converts into. Okay, so this will basically convert these values into the format of 4 cross 4. So if I print it out, let me show you. So what it has done, 0 to 15, the one dimensional array, it has now converted it into two dimensional array in the format of 4 cross 4. Okay, so this is what it has done. Now what I want to do is I want to do the horizontal split of it. Okay, so what I'm doing is I'm saying take it and make it something like this. So what is happening? It is doing the splitting based on, so you can see that 0, 1, 4, 5, 8, 9, 12, and 13, it has made it into one matrix. And a second, 2, 3, and these values, it has made another matrix. Okay, so what we have done is, this X is the value of my array, whatever array I have made. This 2 is basically the how many splits you want to do. If I write 4 here, so it will make me 4 splits of whatever way it thought possible. So what it is doing, basically horizontally, it is making 4 splits, and whatever value you give it to, it will make that number of splits. Okay. Right. So it has taken these values and it has given you 4 different splits. Okay. Right. So I hope you were able to understand this. What we have done, just let me go through it again. We have some things to manipulate the arrays. First thing, we have concatenate. Inside of it, we give two values, which is A, B. A, B, what is A and B? We have taken two matrices. Okay. We have n numpy.v stack, at stack, column stack. So these are the things that we have taken. Okay. So you have understood that how and what are the values it is taking and what it is doing to our arrays. Okay. We have taken two arrays. What it is doing to our arrays, we have understood that also. Okay. So I guess it must be clear by now what these things are doing. Okay. So we have some more array shape manipulations that we have. So what I'm doing is just let me. So what I'm doing, I have taken this A, and if I run this, and if I just show you how this A looks like. So what I'm doing is I'm taking two-dimensional array, which is my A. I have made this array to flatten this array. Okay, now this is in the format of two dimension. If I check the dimension of it, it will show me that A dot, and then if I just check the dimension, it is showing me that it is a two-dimensional array. Now, if I want to flatten it, if I want to convert this two-dimensional array to one-dimensional array, this is how we can do it. So what we can do, we can basically use A, which is the name of my array that we have taken, and what I'm doing is A dot travel. So if I use A dot travel, this is one method that is used to flatten out your two-dimensional array into one-dimensional array. So that is the work of. So what we have done is, using Ravel method, what we have done, we have converted a two-dimensional array, which is in this format, to one-dimensional array. So this is the work of Ravel. It basically flattens any array into one-dimensional array. Okay, and try out various values for it. What kind of thing it is doing, you will understand it. Okay, so now if you want to do the transpose of any matrix, what transpose basically means, these row values will be converted into column values and column values will be converted into row values. So this is what happens with if you do the transpose of any 2D array. 2D array is what? 2D array is basically a matrix. I've told you that another name for 2D array is matrix. So if you understand, if you know about the concept of transpose in matrix, this is very similar to that. So what we are doing is, this was my first array. This was my original array, which is 1, 2, 3, 4, 5, 6. So this is two-dimensional in the format of two rows. What we can do is, if I transpose it, what will happen is, this will be converted into something like this. So now rows have become columns, and rows are the columns are basically showing the format of rows. 1, 2, 3, 4, 5, 6. Now, if you have converted this into, if you again use Ravel on this transpose also, So this will convert it into 1D format again. So what we have done with the transpose, we were able to convert it into 2 dimension. Okay, now this is 2 dimension. Okay, so now here also we have 2 dimension. If I do the transpose of it, it is also 2 dimension. If I want to flatten the transposed value also, so this stacking we can do. So what I've done, first I have taken the transpose. When I've got the transpose value, after that I am using Ravel. So even after that, it is able to manipulate this data. This is able to convert my 2D array into basically 1D array. So this is what it is doing. Okay, so this was about one simple concept which is called Ravel. Inside, just use dot Ravel, and you will be able to convert the higher dimension values, higher dimension arrays into one-dimensional array. Okay, basically you will be using all the data which is there for you. You will see that data into 2D format itself, so it will convert them into 1D format. Okay, so now the reshaping of the array. Okay, so how we can reshape the array? We have seen that we can convert the shape of the array. How we can convert it? So if I just check the shape of A, so what it is doing is, I'm just checking the shape of it, A. So it is showing me that it consists of 2 rows and 3 columns. So this is what it does. A, so if I just 2 rows and 3 columns. So it is this A. Okay, 2 rows and 3 columns. You can see it here. So this is showing me the shape of it. Okay. Now if I take one another array, which I have basically flattened it. Okay, so now I've taken B, where I am just flattening A. Okay, so this is one-dimensional array. You can make this a one-dimensional array directly also. So I have one A. I am just converting this into one-dimensional array, and it has now become my B. Okay, so what I can do is, you can see that this one-dimensional array could be converted into two-dimensional array. I can basically reshape it. Okay, so what I'm doing is I'm just writing this B dot reshape. Okay, and inside of it I'm giving some values. Okay, so what I'm saying is convert it into 2 by 3. Okay, just a minute. So what I'm saying is convert this 1D array, which is into the format of this 1D array, it is convert it into 2D array in the format of this, in the shape of this. So can I do 3 comma 2? Let's see. So you can do 3 comma 2 also. Okay. So what these values are basically, so we have 6 elements. So related to 6 element, you can take any shape. I can, if I write 1 comma 6, that also is perfectly possible. Okay, so what I'm doing is, it must be some way calculating to 6. Okay, because we have 6 elements only. Other values, if you take into 8, if I make it something into 8, it will not be able to do it. So if I take 2 comma 4, it will not be able to reshape it, because it is saying to us basically is, I don't have that many elements to reshape it. I have only 6 elements, but what you are doing is you are asking for 8 elements. Okay, so that I cannot do. If you give me that similar number of elements, so that I can do, that I am very fine with. Okay, so this is what you can do. You can convert any matrix you have into any shape. So you just have to use dot reshape. Inside of it, whatever is the dimension, if you give it number of rows, number of columns, you will be able to convert it into it. Okay. So here, if you can see that what I've done, I have just simply taken 6 values and I have just reshaped it. Okay, and if I take from 1 to 10, if I give 2, 3, it is not taking. So what we have is, we have 9 elements here. So 9 elements, for 9 elements, what I can do is 3 cross 3 would be perfectly fine. So that is what I have done. Okay, so these are the something. Okay, so if you are clear with this, if you have any confusion, what we have used is, we have just studied about this dot reshape. What we can do with this dot reshape, we will give some dimension related to how many elements we have. So related to that, it will just convert our complete array, whatever array we have. So it will try to convert it into format of this. Okay, it will convert 2D array also into format of this. So I'll show you that. Okay, so what we have is dimension reshuffling. We can, so in Ravel, what was happening is, it just convert your higher dimension arrays into one dimension array. Okay, this is what it is doing. It is doing the flattening of the array. Okay, it is basically doing the flattening of the array. And what we are getting is, what we had is, when I made this np.array, you can see that we have two-dimensional array basically. So here what I did was, when I run this, you can see that this is how my A looks like. When I check the dimension of A, it is showing me that it is 2. It is basically two-dimensional array. Okay. So I have two-dimensional array, but I wanted to convert it into one-dimensional array. So I just want to convert it. I don't want to make another 1D array. For whatever reason, I have just use of 1D array, and I have a 2D array which consists of similar elements. So what I can do using one simple function is dot ravel function. Whatever we have is, we can convert this 2D array into 1D array. This is what basically ravel does, nothing else. Okay. And what we can do, we can use ravel on the top of this transpose also. So what we have done, we have 2D array here, we have 2D array here also. After doing the transpose, we have 2D array basically. So 3 rows and 2 columns, 2D array we have. When we use ravel on it, it will just flatten it out. It will convert them into 1D array. Okay. Reshaping also we understood. What reshaping does, if we have any shape of data and I want to convert it into another shape, so that you can do. Okay. And this is one quick way. If you have basically, if you are making this np.arrange, if you are making 1D array, what you can do, you can just simply use this dot reshape and you can quickly make any 2D array using whatever dimension you have in mind. Okay, you don't need to make a bigger matrix for that, all the elements. You can just quickly make this 1D array, and by using dot reshape, you can convert it into whatever values you have, whatever dimension you want it to. So this was about dot reshape. Now we can do the reshuffling of the dimension. Let me show you how. This is very similar to this concept. So reshape we have understood about. This reshuffling we could do. So what I'm doing is I'm taking numpy dot this numpy array we have. It consists of values from 0 to 23. As you can see, starting from 0, we have values to 23. What I can do is, if this is my, if I check A here, so if I just mute this out and
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
so here you can see that it is just one dimensional array containing values from 0 to 23. Okay, so now on this, what I can do is I can use my reshape, and inside of it, I'll be giving some dimensions 4, 3, and 2. So what it will do is it will just start to make this A. It will start to make that A into something like this in this format. Okay.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So what I can do is, so this you can understand, this is basically in some multiple of 24. Okay. So what you can see is, what we are doing, you can think of it as this also. 4 cross 3 cross 2, it becomes 24. So in this manner only we are doing this thing. And or for the simplicity, let it be 24 only. What else we can do? So I can just write 3 also here. Sorry, 3 here, 4 here, and 2. What it will do, this also now calculates to 24. So it will be able to do this in here also. So if I just print this out, you can see that now what we have is the first one, whatever is the first value, here we are using 3 values. Till this point, what we have done was we were using 2 values inside of reshape. So what it will do, it will take these values for the number of rows and number of columns. Okay. Now when we are using 3 values in reshape, so the first value now becomes something else. So what is the first value? How many metrics you want to take. So out of it, how many matrix you want to take basically that you are writing. So I want three matrices, basically 2D arrays, which has dimension of this 4 cross 2. Okay, 4 rows and 2 columns I have. This is what I'm writing. And if I change it to 4, 3, and 2, this is what I'm saying. Give me 4 matrices whose dimension should be 3 cross 2. 3 number of rows, 2 number of columns it should have. This is what it is doing in the background. So this is what the dimension reshuffling means. You can change the dimension, whatever you have in mind. It should be in the multiple of how many elements you have, and you will be perfectly able to change the dimension of your arrays, right? So this is what it is. You can simply take some values from it also. If you just go on to this, my 0th first value, what I'm writing, 0 is my this metric I'm talking about. This is my 0th, first, second, and third. So this 0th, inside of 0th, what I'm saying is go to the second row and first column, and whatever is the value at the second row and first column, this 5, you can see that this 5 is my value at this place. So you can take this also, you can do the indexing also. Okay, now resizing, if you want to resize something, this resize also works in similar manner, just little bit of differences, little bit of places it will be taking. In some scenarios reshape will be used, in some scenarios resizing will be used. Okay, so there is just some differences of what parameters it is taking. Okay, so what we have basically made one numpy array. Inside of it, what I'm doing is first value, what I'm giving is the name of my array in which all the elements are there. And in this, what I'm saying is the second value is my 4 comma 3 I can give, or if I give 3 comma 4 also, this will be able to resize it into that manner. So this is how these resize works basically. Okay. So in some scenarios, I will explain that also. Don't worry about it. But if you are able to understand it here, then forward also you will be able to understand. What we are taking some values and we are just resizing it into here in this manner. And this is how it is taking the parameters basically. This is in the manner of that. Okay. Now this is about resizing. Can we do the sorting of values in numpy array? How we can do the sorting of values? If we have made any array, we want to do the sorting of it. How resize is different on it just depends upon the scenario. Okay. So scenario I'll explain later on. If I explain it to you now, you will not understand basically. That will be quite complex for you. Okay, but I am saying that I will explain it to you. Don't worry about that. It just depends upon what scenario is there, what kind of data is there. Based on that only, you will be using this resize or reshape. You understood that what it is doing, it is just doing something very similar, but there are some differences. You can read the documentation of it, but in that much detail, you don't have to go at this point. Okay. Yes. Okay. So now how you can do the sorting of the values in a numpy array. So in numpy array, if we want to do the sorting of it, what we can do is what I'm doing this first. So let me take this out. What I'm doing is first I have made my numpy array. This is already we are familiar with. So just a minute. So here, okay, np.sort. np.sort. If this is the name of the method that is there, first thing it will take whatever you have given, and then it will taking. So okay. And if you can use print also, if you are familiar with this. So this is what it is doing. It is doing basically the sorting of it. Axis is equal to 1. So let me show you what axis is equal to 1 basically means is. So first row is this. First row is this my 1 value. This is my second row. So row wise, it will be doing the sorting of the values. So you can see that 1, 4, 3, and 2 here. So this has done the sorting of this first one, which is this row here. And after that, it has gone to the second row, which is my this one, and it has done the sorting in that manner itself. Now, if I just give it axis is equal to 0, this is what it does. It does basically column wise. Okay. So in column wise, you can see that first we have 1 and 2. Second, we have 4 and 1. Okay. So here you can see that in first row, we have had 4 here. It should be 4 here. But what it has done after sorting, it has changed the values. It has basically swapped the values in that manner that first the minimum element should be showing, and this the higher element, whatever is there, it must be showing after that. So this, you see that what we have done is, if I write 8 here, basically, and okay, so I should keep here 6, and here let me keep it okay, yeah, 6 will do. So you can see that on the first row, on the first of the matrix, first row that we have, first array that we have 1 1 4 and 4, 1 4 3 and 6. Now what it has done, after the sorting, it has made the change. Okay, it has basically made the change in both of these arrays. So axis is equal to 1, it will be making change column wise. It is just basically doing sorting column wise, and whichever column, for every single value it is checking in that column. So from 6 and 4, whichever number is there, which is minimum, which is short, it is taking and putting it into the first array. So this is what happening with the sorting. Okay, so now what we have done, we have basically assigned this sorting into our new variable itself. So this is now new matrix we have got, which has all the sorted values. Okay, so this, all the sorted values we have now. Okay, so this was about sorting. There is nothing complex about it. np.sort, you have to write, it will, first parameter, it will take the name of the array. Second parameter, you have to give either axis is equal to 0 or axis is equal to 1. These two values only it has to give. Can you put axis is equal to 1 now? Yes, if I just do this once again. So it has taken 1 3 4 and 6. Yeah, axis 1 it has done, yeah, 1 4 3 and 6. So when you do that, it is not like permanent. What we have done is, when it was happening, you can see that it is doing this sorting here, but when you change it to axis is equal to 1, the values which was there inside of numpy array, that remains intact. Okay, so if you need to sort that for permanent, you run this 2 times. Okay, so you can make another basically variable inside of it. What you can do is, you can do that, and here again you can make axis is equal to 0. So this way you will get 2 different arrays if you want in that manner, but permanent change is not happening. Whenever you use axis is equal to 1, it will again take this array and it will start to show you that value. Okay, so that you have understood. This is what is happening. So this was the concept of sorting. What we do is, we just use np.sort. Sort is the method inside of numpy. What is the parameter is taking? First value is the name of my array. Second value is the axis. What, it could be 0, it could be 1. Okay, this is what I am taking. Okay, so the sorting of values also we have done. Let's see, there is some concept of shape mismatch. Okay, so we have seen that if we have two arrays, we can basically add them together very simply by just using plus symbol. We can add two arrays, that we have seen. But what will happen if we don't have similar number of elements in both of the arrays? So to add anything, to add both the arrays, whatever array we have, we can have 1D array, 2D array. If you take any array, and if you want to do the addition of them, the number of elements should be always same. Okay, if you are taking two arrays in them, if one has 4 elements, the second one also should have 4 elements only. Okay, it could not have 3 elements, 5 elements, it cannot have that. So this is what it is showing me, that when I ran this thing, it showed me that this operands could not be broadcast together with shape 4 and 2. So there is mismatching in the shape of it. So this could not happen. This operation is basically not possible to happen. Okay, because what is happening, this computer memory does not know what values is there after this. It does not know that it cannot put 0 0 also after this 1 and 2. It cannot just simply go and put 0 and 0, and it can do the multiplication of it, because you know that memory is empty. If you don't give any value, it does not have any value at that place. Whatever value you give, that will be written at that time itself. So this is what the array is showing. Now, what is the concept related to that? What is the concept behind that? In many cases, you will see that you are not giving perfect dimensions. Okay, and what perfect dimension I am talking about, then only then also what is happening is, if you don't give perfect dimension of matrices, also that in that case also some operation will happen. So how that dimension basically looks like, so let me show you that. So you have understood that this shape mismatch happens if you don't have similar number of elements in both the array. After that, there is something called broadcasting, which is very, very crucial concept. This will tell you that what is happening in the background. So basically, what this happen is, it is taking two arrays. Okay, what you're giving is, this is my one 2D array, this is my second 2D array. Okay, so when you have given complete full matrices, full arrays, what it will do, it will just do the addition of it element wise. Okay, element wise, it is doing 0, 0, 0, 10 plus 0, 1, 10 plus 1, 11, 10 plus 2. So element wise, the addition has happened. So this is the normal case. If we have given the complete dimension, if we have given all the elements, so you can now understand that what is happening. It is what obviously what you would see, what you would think of. But there is something magical happens, something very powerful happens. For the efficiency of all the calculation, there is some concept which is called broadcasting. This is what happens in the case of broadcasting. Okay, so now suppose the first matrix that you have made, this is in the format of 4 cross 3. This is a 2D array. You have given these values. Okay, so this is basically a 2D array which consists of 3 rows and 4 rows and 3 columns. Now the second array that you have given, it is in the format of this. Okay, this only consists of these 3 values, and what you are doing is, you are doing you are doing the calculation of all of these values. So now you can see that it should give an array mismatch. Okay, because you don't know whatever value is there below it. It does not know for all other values what value it should take. By default, it is not going to take 0, it is not going to take 1. It does not know anything. It is just a memory. Whatever you tell it to do, it will do that. But in NumPy, something very important has been written. It is there working in the background. What happens in this case? So 4 cross 3, this dimension is there, and we have these values. Okay, this is one dimension where array. If we add these two basically arrays, what will happen is, this will take all the values 0, 1, 2. Here you can see that in this transparent manner, this is what it is doing. It is basically now repeating or just copying paste this how many times? This should match the dimension of it. Okay, so this many times it will be repeated 0, 1, 2, 0, 1, 2, 0, 1, 2. This is happening in the background. You will not get to see it. This is how the memory is working with NumPy. In this case, now what will happen? Now if you do the addition of it, basically, this will work very similar to that. Okay, so what is happening? These elements have been added in a ghost manner. And what elements it has taken? It has just replicated these values 3 more times. Okay, so now it has become into one big original dimension it should have been. Okay, so this is what happening in the background. Now, if you take two arrays in this condition, this is one 2D array, this is one 1D array. Now, what you're doing is, you are basically doing something. You are doing calculation of it. In this case, what will happen? So in this case, it will try to make both of these arrays into some format that both could be just coming onto one single type. Okay, so in this, what it could do, so we have 4 rows. So what it could do is, it could convert it into 4 cross 3. So here also what it can do, it can convert it into 4 cross 3. Okay, so this is what it can do. This is what it does in the background. So now both of these arrays are now complete. Even after having partial values, it has now added some values in the ghost manner. And after this, the calculation when happened, this looks something like this. Okay. So to show you that is it really working in the background, to show you this concept, let's just see some code, and don't focus much on this. I'm just showing you that something like this is happening. Okay. So what I'm doing is, I'm just taking one array. Don't worry about it. I'm just taking one array, which is in the manner of this. Okay. which is basically in the manner of this. And I want to convert them into this manner. This is what I want to convert it into. So what I'm just doing is I'm using one np.tile function. Okay, you don't need to worry about it now because it is not much used. It is just used. I'm just using it for this functionality. So basically, what I'm doing is I'm taking one numpy array, which will be one dimensional array, which is this. And in np.tile, there is one functionality. I can just replicate it in the same manner that whatever is happening in the background, this replication, I can just simply do that replication. So what I'm doing is I have taken one dimensional array. When I replicate it, what it will give me is, what I'm saying, this is the second value it is taking. So what is the second value? I want to say that replicate 3 times in the row. In the rows, it should give me 3 times. And in the column, it should give me 1 times. Okay. So let me show you what if I just write it 2 here. So you can see that our 1D array, which was consisting of 0, 10, 20, 30. If I'm writing 2, it is now repeating 2 times. If I write 3 here, it is repeating 3 times. Okay, so this I have done. So what is the second value? How many times it should repeat column wise? So if I show you, this complete array is my one array. So if I give you here 2, what it is doing is it is now taking this complete and make it into another. So this is what it is doing column wise. Okay. So this is one functionality that is there on np.tile method. Okay. You don't need to confuse it with other methods. This is just for your explanation that what I'm doing, what are the things happening, to just show you that if this thing is working in the background or not. Okay, so what I've done, I've taken this np.tile, I have made something like this using these operations. So using this operation, I have made something like this. Now I can simply transpose it. If I transpose it, what will happen is it will convert it into this manner. So when it is converted into this manner, we have got what we wanted. So this you can see that it is perfectly in this dimension 0, 10, 10, 20, 30. This is now in that dimension 0, 10, 20, and 30. Okay. Now we have to take our second element, second value, whatever we have to take. Okay. So this we are not talking about because this was already perfect. This second example we are talking about. So what we have done is we have made our first array. This second array I'm taking. Okay, this is now my 1D array, and this is how I'm making this 0, 1, 2. You can see that it is 0, 1, 2. Now let's see how we can make it. So you now know that you can simply make this 1D array 0, 1, 2. These elements are here, and this is how it looks like. Now when we do the addition of it, you can see that this is the value we are going to get, and it looks very similar to what we have already seen. 0, 1, 2, 10, 11, 12, 20, 21, 22, 30, 31, 32. And let me show you. If you see that 0, 1, 2, 10, 11, 12, 20, 21. So this is actually happening in the background. Okay, and this we have proved. Now let's see for the second case, if it is working for the second case also. Let me show you. So for the second example also, what I'm doing, I'm making 1D array. So here, my dimension is basically one dimension. Okay, this array, is my array A. This at this point is my 1D array. So if I check this dimension, so this is my n dot, sorry, A dot, A dot. Okay, so this is showing me that it is one dimension. But you can see in this diagram is that it is two dimension basically. It consists of 4 rows, and it is not actually taking it into one dimension. One dimension, if we talk about, this should look like this. This is the second case, 0, 1, 2. One dimension always looks like this. Okay, so we have something, if we have an array in this manner, this is basically at least 2D. Okay, so it consists of 4 rows and 1 column. Okay, so 4 rows, 1 column we have. Here, if you see that it is showing me that only 4 values are there, it is not showing any 1 column and something like that. So we have to do something about it because our data is not in that format. Our array is not in the format that we wanted to be it into. Okay, so for that purpose, we have something, we have one way we can convert, or in whatever array we have, we can just add one dimension to it. Okay, so this is my 1D array. You can see that this is my 1D array. We have checked its dimension. So using something like this, so what I'm doing is basically, what I'm telling it to do is basically this. So A is equal to A. Take my complete array. Inside of that, take all the rows. Okay, basically take all the rows. And in the column, make one new column which should not have any values. I don't want any values. I just want to convert it into a manner where it shows me that it is 2D array. Okay, it must show me that it is basically 2D array. So after this, what will happen is if I just run this thing, it has now become into the format of 4 comma 1, and this is what we wanted to do. Now I'm using this style method on this. So this is one way. So using t, it will not make it into a manner. Okay, so this manner I want to show you. In this manner it will not make it into this manner. Okay, so for this purpose only, and that transpose thing is different. I am just explaining you whether this thing is happening. Okay, so for now, don't worry, don't stress on it much, because this will not be used not many times. For this, just one single concept, I'm explaining it to you. Okay, so what is happening? We are taking one array, we have added one dimension to it. Now, when I check the shape of it, let me show you. If I check the shape of it, and then, so here what we have is, we have 2. Okay, so the shape of my array has become 2 without adding any element. And if I check how my A looks like, so this is how my A looks like here. And here, if I check my A, after printing this A, let me show you. So here it looks like this. This is my 1D array. Now what I have done, I have changed its dimension. I have made it into 4 cross 1. That is what we wanted. That is the dimension that we wanted to do. Okay. So when I have changed its axis, this has become something like this. Now we can perform whatever operation we wanted to perform. So this A, my new A, is something like this that we have seen. And what is my B? What B we have taken? We have taken B, which is 0, 1, 2. So now you can see that B is 0, 1, 2. A is my 0, 10, 20, and 30. So this is my 2 values, which looks similar to this. This is my A, this is my B. What will happen in the background? This will happen in the background, and we will perform this calculation, and this will be the result that we are going to get after this. Okay, so what we have done. So if I just run A plus B, okay, so we have B, A we have here. Yes. So you can see that we have taken our A and B. What has happened? It has done the calculation. It has basically added some ghost values at those places. Okay. So this np.new access, you don't need to worry about it now. It is not going to be used much. This is just one concept that I wanted to explain you regarding this. That this is what happens if you don't have same kind of dimensions in 2 arrays. If you're taking 2 arrays, if the dimensions are not same, this is what it does, yeah, to convert them basically into this real 2 matrices. Okay, so this is the concept of broadcasting. Okay, so I hope that you are able to understand this. Just leave this part. I'll explain them later if I need to, but for now you don't need to know. You don't need to focus on this basic. This is one additional concept you will not use very frequently. Apart from that, if you've not understood the concept, tell me about that. So what we have done, we have taken one array, okay, which is my 2D array. To convert it into my desired format, I have just made it a transpose of it. The second value, what I have done, I have taken my 1D array. I have done the addition of it, and we can confirm that this addition, this ghost values addition is this happening in the background. And this is the concept of broadcasting. The second value was this. This we have taken our 4 values we have taken, and we have added that 4 values here also. Then we have got something like this. This was my first array, this was B was my second array, and this is what it has done in the background. Okay, so this was all the concept which was related to numpy, and these are the basic computations. These are the basic methods that we have inside of numpy if we want to do the calculation. So I hope you have understood what operations are happening with NumPy. If you have any confusion regarding that, I'll just show you from the start that what we have done. We have taken some data. We have understood this concept also. If you have any confusion regarding this, also you can tell me. Then we understood the concept of concatenate, vstack, hstack, column stack, and split. These are the concepts that we have seen. Inside of it, we ran through these queries and what parameters, what values it is taking, we understood that. After that, what we have, flattening of the arrays, we have seen. If we have two-dimensional array, if you want to convert it into 1D, this is how we do it. We have understood the Ravel also. After that, we saw the concept of reshaping and what we can do with reshaping. That also we have seen. We just have to give some dimension that must be related to the number of elements we have inside of our 1D array or whatever array we are taking. The dimension should be shaped if you are doing the reshaping. This also we had understood. We understood how we can do the reshuffling of the dimension. This dimension you can change whatever dimension you want to pick, that you can change. We saw that also. We saw the concept of resizing, what resizing, what parameters it is. We have seen that if you want to sort the values in any numpy array, how we can do that also. We saw the concept of shape mismatch. This is what happens if you don't have two arrays of same elements, same dimension. If you don't have that things, this is the concept of shape mismatch. And related to that, we have something called broadcasting. This is what it does in the background. If you have given some other dimensions, this is what it does. So I just basically proved this thing using these concepts.
Now we have Python variables. So this is the first thing that we're going to learn about when it comes to Python. So what are variables? Let's take a look at them. A variable is simply a container. It contains some value in memory. A variable points to a memory location where the value that you want to store is stored. So in Python, the data types will be identified according to the data we provide. And I'll show you what that means in a moment. A variable should start with a letter or an underscore and cannot start with numbers. So there are two ways of assigning a variable. You can assign a single value and you can assign a multiple value. So before we begin, let me just show you what you can do and how you can execute some Python. Now, since I'm showing you some really common tasks, I'll be doing it in the shell. Now, shell is not the way to write code when you're writing code for large applications, but when you're trying out small things and you're trying to understand how these things work, what will be the output of one command or the other command, shell is a great environment to work in. So I'll show you how I do it. So I go to the start button, I type Python, and it opens Python 3.7. So I open this and it's here. So now let me just show you what I mean. So the first bit of code that I would like you to write is you should, let me just make a change to this so that you could see it properly. So the font size, I'm going to increase it to 28 so that you could see it properly. And click OK. Hopefully it's visible. So what I'm going to do now is, now I can type any code that I want to write. So I will type print. Print is a function that will take in something that I want to print on the console. A function always gets called with these parentheses, opening and closing, and two quotes. Inside it, we're going to write hello world. Hopefully you're writing it with me, and once you're done with this, press enter, and as you can see, it got printed on the screen. Now, why did we have to put quotations here? Why did we have to put the parentheses there? We'll discuss all of that in a future video, but note that you've written your first line of Python code, and it was really easy. You only needed to write one line of code and it did something. So many languages require you to line like 15 or 16 lines of code for it to just print something on the console, but here we were able to do it with just one line. This is one of the major advantages of using Python. Now we come to data types. So as we have already discussed in Python variables, the data type will be identified according to the data that we provide. So what exactly is a data type? Well, data type is basically something that allows us to understand what kind of data are we storing in a variable. Let's say that I want to create a variable named name, and I want to store some name. Let's say the name is John. Now I want to check what data type it is. Press type name. So it's a class of type string. So it's a string. A string is nothing but just some characters strung along. So it could be a sentence, paragraph, basically any text that you need to store, you store it in a string. If you want to store it in one continuous long line of text, you do it using string. Now that is done, there are many other kinds of data types as well. Let's say that you want to store a whole number, a number which has no fractional point. You use integer for that. To give an example, let's say num is equals to 1. As you can see, 1 has no fractional part to it, it's a whole number. And I press enter. And if I look at the type of num, I get integer. So integers store numbers with no fractional part. On the other hand, if I want to store some fractional part, let's say 1.5, and I check the type of num now, it will be changed from integer to float. Float is something that stores fractional part. So if you wanted to store the value of pi, you would store it in the type float. Now you don't have to define what kind of type you will be using because Python takes care of it for you. This is what is known as duck typing. Duck typing basically means that Python takes a look at the class and performs the functions accordingly. So it will take a look at the value that you are pointing to, and it will take a look at it and understand that, okay, it's a number which is floating point, so we can just use it. So we can just assign a float class to it. Now, the main question is, why do we need to use different kinds of data types? Well, there are many reasons. The first and the most important reason would be that types are important for us to distinguish between different kinds of data. So we can, for instance, add two numbers. So 1 plus 1 will give us 2. If the computer does not know what kind of data it is and it tries to add it, it will have no idea how to perform it. So let's say that I gave it, instead of 1 plus 1, I gave it B plus C. So what do you think will happen in this scenario? If you want to take a guess, pause the video for a moment, think what's going to happen and then resume it. So what's going to happen is it's going to concatenate this string. As you can see, it just took B and added the next string to it. I could even make it a little bigger. B, let me just do it this way. BSDA and CSS. And as you can see that it added it to the it added those two strings together. Now if this was not string and if I were to use a number, again, what do you think will happen? We get an error. So this is where we use it, because adding a string and a number, let's say that you were giving an exam and they say add a plus 15, that would make no sense, and the computer will have no idea how to process it. It won't have any understanding of whether it should add two numbers, whether it should convert it to string, whether it should do something else. So for computer to be able to comprehend the kind of data that you're giving it, data types are used. And there are many other reasons behind it as well. Another reason being determining the size of the variable. So if you have a string, the size of the string is determined by the number of characters it holds. If I have a string called A, B, C, D, it will have 4 bytes. It will be occupying 4 bytes. On the other hand, if I have a number, it will be occupying 2 bytes and 4 bytes depending on the kind of interpreter you have in the language and the environment you have. So this also allows for computer to understand how much memory to allocate for a specific variable. This is why we use variables like this. So hopefully it's clear to you. So let's move on. So now we'll take a look at how to assign values to a variable. I've already given you a little taste of how that happens, but let's take a look at this. So we can assign a single value or we could assign multiple values. So let's take a look at how that works. Let's say that I want to assign, as I've already showed you how I do that, but let's just do it again. Let's say that I want the age. I want to store someone's age. Let's say they are of age 25. I press enter. This is assigning a single value to a variable. So I'm assigning 25 to age. If I were to type name, comma, age and equals 25, this is going to show me an error because it does not know how to unpack this value. This is just one value and I'm expecting two values. Now if I were to move ahead, instead of doing this, as we've already seen, the naming conventions are also there, so you can't name a variable with that begins with a number. So if I wanted to name something underscore name, that would work just fine. As you can see, this is fine. But if I were to start with anything other than underscore, let's say $name or even if I were to start it with an integer number, this is also going to cause an error. So anything other than a character, which is anything from A to Z, whether it's small or big, and anything that is not underscore is going to cause an error. So always make sure that you're assigning the variable names correctly. Another thing that you can do is naming a variable. The variable cannot start with a number, but it can end with a number. So if I were to say name 1, this will work just fine. And if I were to say name dollar, this is going to cause an error because dollar already holds a value in Python language. So it's a token, which we'll discuss in a later video. So make sure that you are naming it correctly. And always make sure that you're naming your variables in a way that helps you understand what exactly is it that you're trying to write. You can start it with 2 underscores as well. That will work as fine. No matter how many underscores you are passing it, it's going to work just fine. So these are the variables that we have declared so far, and we have assigned a single value to it. Now let's take a look at how to assign multiple values. So assigning multiple values is also quite simple. As you can see here, if you want to assign one value to a multiple variables, we can do what being done in the first line, which is A equals to B equals to C equals to 10. That means set all the variables on the left hand side, which is A, B and C, to 10. On the other hand, if you want to do it, you could do it other ways as well. So we could assign multiple values using the comma operator. So I'll show you how that works in a moment. Let's just see how that works. If I were to go A equals B equals C equals 15, and if I were to print A, it's 15, B is 15, C is 15. Now if I were to change it, I want to assign 10, 15 and 20 to all of them. Instead of doing the equal sign, what I do is I use commas and I tell it, okay, A comma B comma C. Now I want 10 assigned to A, comma 15 assigned to B and 20 assigned to C. I press enter. A, B, C. So I have to make sure that I'm using the correct ordering. Order matters here. If I were to use A, B and C, if I were to use B, C and A, then B will be assigned 10, C will be assigned 15 and A will be assigned 20. So make sure that the order matches with the values that you're providing it. Now let's take a look at Python tokens. Alright, so now let's take a look at operators. So operators are just special symbols that are used to carry out arithmetic and logical operations. In Python, there are several kinds of operators. So we have all of them listed down here. So the first kind is arithmetic, then there's assignment operator, there's comparison operator, logical operator, bitwise operator, identity operators, and membership operators. And we'll take a look at them one by one. So let's move on and see what are arithmetic operators. Well, as the name suggests, we use arithmetic operators to perform arithmetic operations or mathematical operations. Things like addition, subtraction, multiplication, division, modulus, and exponentiation. So addition basically adds two numbers. So we can add 6 plus 5, in which plus is the operator and 6 and 5 are the operands. Similarly, we can subtract, we can multiply two numbers, we can divide two numbers. Modulus operators is used to give us the remainder. So if I were to go 7 modulo 2, it will give me 1, because when we divide 7 by 2, we get a remainder of 1. And similarly, exponentiation is used to raise a number to a specific power. So for instance, if I were to type 7, then 2 times the multiplication symbol, which is the asterisk, and then I type 2, that means that we are multiplying 7 by itself 2 times. So that's what these operators are for. These are very easy to understand. These are just basic mathematical operators, and they are very commonly used in Python. Then comes assignment operators. So assignment operators, as the name suggests, assigns a value to variable. So let's say I have a variable x and I want to assign the value 10 to it. I want it to hold the value 10. So I could just type x is equals to 10, which is what is shown here. Now there are some extensions to the simple assignment operator, which is the equals operator. You can add a plus right in front of it, and what it will do is it will add more. It will add the number that is on the left hand side of the operator to the right hand side of the operator. To give you an example, as you can see, we have plus equals is the operator, and we type x equals to x plus 2. Let's suppose that before we execute this was already executed. the x is equals to 10 statement was executed and x contained the value 10. After I run this code, what will happen is will take a look at the number that x holds, which is 10, and it will add 2 to it, so it will become 12. Now following the same logic, we have minus equals. So the minus equals operator is going to do the same thing, but instead of adding 2, it's going to remove the number that's on the right hand side. So x equals x minus 29 will subtract 29 from the already existing number in x and assign that new value to x. Similarly, there's multiply equals, there's divide equals, and there's or equals. So this is basically a binary operator or and bitwise operator, and we'll take a look at that in a moment. And then there's comparison operators. So comparison operators, as the name suggests, are used to compare two values. Let's say that I have two values that have been entered by the user, and I want to compare the values in them. So this is where this comes into play. Now let's say that you have a login form and the user enters the registration name, the registration number, then they enter their password, and just to make sure that they have entered the correct password, you have a confirm password field as well. So when you're validating the form, you need to check whether or not password in the password field and the confirm password field are equal to each other. So this is where the double equals come into play. Now the reason why we have two equals and not one is because one equals is used as assignment operator. The operand on the left hand side gets assigned the value on the right hand side. Here we are comparing the two values, so operands on both the sides will be compared to each other. Then just the opposite of it would be the not equal operator. The not equal operator is used to check whether or not an operator or an operand is not equal to something. So if I were to go and check whether 1 is not equal to 2, since 1 is not equal to 2, it will return true. Similarly, we have less than, we have greater than, we have less than equal to, and we have greater than equal to. And their names are quite easy to understand as well. They check whether or not one value is less than the other value or not, or whether it's greater than or not. Then there's logical operators. So logical operators are used to combine conditional statements. So if I want to check whether or not some condition is true and the other condition is true as well, then I use AND. It will return true if both the statements are true. Similarly, there's an OR statement. OR statements are used to check whether or not something is true or not. Let me just show you by an example. So if I were to use Python, I'm going to show you some Python code here. So let's say x is equal to 15 and y is equal to 16. Now if I want to check whether x is equal to 15 and y is not equal to 16, so what I can do is I can just check s is equal to 15, it returns true, y is not equal to 16 and it returns false. Now if I want to check if both of these conditions are true, so then I can just type and y is not equal to 16 and I press enter, and it returns false because one of those conditions is false. So that is the problem, because y is equal to 16. Now if I hit this, then it will return true. So I'm checking whether x is equal to 15 and y is equal to 16. If I were to change the value of x to, let's say, 14 and check this condition again, I'll return false. Now the OR operator is actually a little different. If I were to use, instead of AND, I use OR, what will happen is it will check whether x is equals to 15, which is clearly false here, and it will check y is equals to 16. If either one of those statements evaluate to true, it will return true. So since y is equal to 16, we are getting true. But if I were to check if y is not equal to 16, since both the statements are false, it will return false. So basically what we're taking a look at is, if we want to check whether all the statements are true, then we use the AND operator. If we want to check just one statement is true out of all the statements that we have provided, then we use the OR operator. And the NOT operator is used to simply revert the statement. So if I were to check 10 is not 10, 10 is not 10, it's going to return false because 10 is 10. But if I were to check 10 is not 11, then it returns true. So I'm just checking for the opposite operator, and that's going to work. Now let's move ahead. And then comes bitwise operator. So bitwise operators are a bit difficult to understand, so let me just explain using Notepad. So underneath the hood, inside any computer programming language, numbers are represented, or any value is represented using binary. So binary is basically just some combination of zeros and one. So when you hear something like integers can hold 32 bits, basically what it means that it has 32 zeros, 32 positions that can be filled with either 0 or 1. And any value that we see on the screen is due to some combination of 0 and 1 in those 32 positions.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
To give you an example, let's say that I have a 4-bit number. 4-bit number means 4 binary digits, number formed by 4 binary digits. So I will have this will be 0, since all the 4 numbers are 0. Now what we're doing is, I want to check, if in case you don't know anything about binary numbers, I can give you a really quick refresher here. Each position is represented by 1, 2, 4, and also so there. So 4, 8, 4, 2, 1. So what happens is, if each position, let's say, so these are the positions that we have. We have 4, 3, 2, 1. So if any of these numbers is turned to be 1, then that number is raised to the power of 2. Let me give an example. If let's say this was 1 and this was 1. If this was the binary number that we had, which was 0, 1, 0, 1. So the way we do this is, we take a look at it and we go 2 raised to the power of 4, and you multiply it by the binary digit that's there, which is 0. And we do the same thing for all of them. So if I was to do the same thing to all of them, let's just do this. Now we will go 2 raised to the power 3, and the number at the 3rd digit position is 1. Then 2 raised to the power of 2, and the number should be 0, and 2 raised to the power 1. 2 raised to the power 0, sorry. This would be that. This would be 0th position and 1st position. So all we have to do is just go 1, 3, 2, 1, and 0. That will work. So this should be 3. This should be 2. Should be 1. This should be 0. And we multiply it by 1. So as you can see, the number at the 0th digit is 1. So we multiply it here by 1. Then at the 1st position is 0, 2nd position is 1, and the 3rd position is 0. So what ends up happening is, we end up creating the sequence in which we go 2 to the power of 3 is 8 multiplied by 0, plus 2 to the power of 2, which is 4 multiplied by 1 is 1. Then we go 2 to the power of 1, which is 2 multiplied by 0, and we go 2 to the power of 0, which is 1 multiplied by 1. And this ends up giving us 0 plus 4 plus 0 plus 1. And we get 5. So this might seem a bit complicated, but that's how the numbers are calculated underneath the hood. You can take a look at some binary refresher that will take you a look at what it means. Now, because we only have 4 places to put zeros and 1, since we have 4 digits, we could go from a number that has all zeros to all 1 and everything in between. This could end up in numbers ranging from 0 to 16. So if we have 4 binary digits, then we can make numbers, we can represent numbers in binary format ranging from 0 to 16. Anything above that, we have run out of space, we can't do anything about that. 0 to 15. So that's how we will do it. And anything in between, any configuration like 1, 0, 0, 0 could also represent some number between 0 and 16. Now we come to bitwise operators. So what they do is, they, instead of operating on the numbers that we see, they operate on their binary forms. So let me give an example. We have an AND operator. So what AND does is, if I were to give you 0 and 0, it will return 0. Similarly, yeah, 0 and 1 will return 0, 1 and 0 will return 0, and 1 and 1 will return 1. So what it does is very much like the AND operator that we had taken a look at previously in the logical operators section. It takes a look at all the operands. In this case, we have two operands because it's a binary operator. And we take a look at the left operand and the right operand. And if both of them are 1, then we get 1. If either one of them or both of them are 0, then we get 0. So this is what it looks like. Similarly, for OR, what we end up doing is, just as we did in the logical operator, just one of them need to be true. So 0 could be considered false and 1 could be considered true, and then we'll get the value. So since both of them are false, both of them are 0, we get 0. 1, we get 1. For the second and the third one and all of them, we get 1. So as you can see, this is what the operators do, the binary and binary OR operators. XOR is a bit special. So XOR is used for exclusive ORs. That means both of them should not be same. Either one of them has to be 1, but if both of them are 1 or both of them are 0, then the value that is returned should be. These are exclusively used in the building of logical gates and all that, but they are also used very much in programming. And there are some very nifty tricks that you can do with binary operators that could allow you to create more efficient programs. So do take a look at them. So these are all the operators that we have studied so far. Let's take a look at left shift and right shift. So what left shift does is, let's say that I have a number like this and I want to shift it by 2. So this number represents 1. Now what I do is I want to shift, I go left shift 2. This basically means that whatever number we have, shift it to the left by 1. So what happens is it will shift all of these zeros by 1 and pad the left part with 0. Basically move it to the left hand side by the positions that I have. So since I've given 2, it will do it twice. So as you can see, first one was at the 0th position, then it was shifted 2 times. So now it's 1 and 2 in the second position. And from 1, we have come to 4. Right? So that's how this works. So this is what the operator, left shift operator, does. It takes the binary format and shifts it by 2. Now on the other hand, we also have right shift operators, and it does exactly the same thing, but it does it in reverse. So if I were to give it this and just change the left shift operator to the right shift operator, it will give me back the original result. It will give me back 0, 0, 0, 1 because it will shift these two to the left. There are nothing there, so it's removed, and add 2 zeros at the beginning, and we get this. We remove this and we get this. So this is what the binary operators do. Binary operators work on the binary format. They shift it to the left, they shift it to the right. And at the very end, let me show you what the NOT operator does, because this is very something that's not shown very accurately. NOT operators turn the number from, turn all the bits from 1 to 0 and 0 to 1. So if I were to give it 0, 0, 0, 1, and if I were to use the NOT operator right in front of it, what will happen is it will take a look at all the binary digits and it will flip them. So if it's 0, it's converted to 1. Again, it's 0, convert to 1, 0, convert to 1, and 1, then convert it to 0. So essentially, we are just converting the numbers. Now, when you do use it, make sure that you understand how the signs work. So in binary format, all the numbers that are stored in the negative numbers, there is a few nifty things that go on in the background. So make sure that you understand how the signs work, and when you shift the numbers, their binary representation will flip. So all the numbers that are 0 will convert to 1, and all the numbers that are 1 will be converted to 0. So that's how the binary operators work. They are very easy to understand once you understand the basics of how binary works underneath the hood. And you can do some pretty powerful and pretty efficient things underneath the hood when you understand the binary digits work. So let's move on. And then we have identity operator. So what identity operator does is it's used to check whether the object that we have is the same or not. Let me give an example. So if I were to open Python and I were to use the ID method and I were to pass it a number 1, You see this long number, This is what's called the ID of the object. Since Python is an object-oriented language, numbers are represented as a object of integer class. So if I were to type, try to figure out what the type is of 1, I'll get class of integer. So if I were, and similarly, if I were to check type of 2, I get this. And if I were to get the ID of 2, it's this. As you can see, these two numbers, the ID of 2 and ID of 1, are not similar. Similarly, when you create your own classes, you create your own objects, they have their own IDs as well. This is used to differentiate between two objects that have almost the same structure, but still there are two separate objects. So if I have two different kinds of strings or two different kinds of numbers, let's say I have 11, and I check the ID of this, it's this, and this is this. So as you can see, both of them have 11, and they don't have the same ID because strings are immutable. So as you can see, these have the same numbers, 1818752 and same. So these are used to check whether the ID of two objects is same or not. So if I were to check with the is and is not operator, if I were to check 1 is 1, since both of them have the same ID, it will return true. But if I were to check 1 is 1, it will return false. So this is what happens with this. If I were to check 1 is not string 1, then it's true. So that's how it works, and this could also be applied to objects. When you're learning object-oriented programming, you can create your own objects, and then you can take a look at that. And then comes the membership operator. Now this is also very quite useful, and I think Python has it and many other languages don't. So it's an operator that allows us to check whether or not a number is in a sequence or an object. So to give you an example, let's say that I have a list of numbers. So I have 1, 2, 3, 4. Okay, I have 1, 2, 3, and 4, and then nums. So I have 4 numbers in a list. Now, if I want to check whether a number, let's say entered by the user, is present in this list or not, then I can simply, instead of just going through each, running a loop and then going through looking at each number, going is 1 equal to the number that the user entered, is 2 equal to, is 3 equal to, is 4 equal to that number, I could just make Python do it easily by typing 4 in nums. Let's say the user entered the number 4, and it returns true because 4 is present. If I were to check 8 in nums, it will return false because 8 is not present in the string. But if I were to add it and then take a look at nums, and now if I check if 8 is in the nums, it is. So that's what the membership operator does. If you want to check whether something is not present in nums, I can just do this and it will return false. And if I were to go and remove dot pop, so 8 is removed. If I take a look at nums now, and if I check whether 8 is not in nums, it will return true. So that's how that works. So membership operators are just used to check whether or not something is present inside a container or inside a group of sequence that we have. And with that, we have come to the end of operator section, and we'll move on to data types in Python. So a Python token. In Python, every logical line of code is broken down into components. These components are called tokens. So there are many types of tokens. The normal types of tokens that we discuss are keywords, identifiers, literals, and operators. So everything that you write in Python is a token of one kind or the other. Let's take a look at them one by one. So keywords, what are keywords? Well, in Python, keywords are special reserved words. They hold special meaning. So these words are something that you cannot use to define a variable. So they convey a special meaning to the compiler or the interpreter. When the compiler or the interpreter takes a look at this word, they'll understand that it has to perform certain action. It has to allocate memory, it has to create something on the call stack, it has to do something in the background instead of just treating it as a normal variable. Now, each keyword has a special meaning and a specific operation. So we'll take a look at them one by one. We'll come across many keywords. We'll take a look at them, what they mean one by one. We should never use keyword as a variable, because that's going to cause a lot of problems when we run into later code, and we'll understand what that means in a moment as well. So these are some of the keywords that Python uses. So as, and, continue, break, except, del, len, from, import, pass, lambda. There are many others.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
And these all hold special meaning. And as you get deeper and deeper understanding of what Python has to offer and how you can use Python to create your own applications, you'll understand where these keywords are used. The main point that you should understand is you should never use them as a variable name. So again, let me show you an example. Let's say I open the Python console. Now, if I want to type RET is equals to 7, this works just fine. But if I were to type return RETURN, that's a special keyword, and we'll take a look at what that means in a moment. But if I were to assign it to 7, I will get an invalid syntax error, mainly because return is already a keyword. If I were to type return 1, again that would work just fine. But if you try to use some keyword for this is going to cause a problem. Now that is done, let's take a look at something else. So these are the keywords, but there are other tokens as well called identifiers. So an identifier is mainly a name that is given to something in Python that we can give that allows us to identify it later on. So these could be names given to a variable, names given to a function, a class, or an object. In case you're not familiar with function or class or object, you are familiar with variables because this is what we just discussed. But functions, classes, objects, everything else will be discussed later on. So don't worry about if you don't understand it as of now. You'll get to understand it throughout the runtime of this presentation. So there are certain rules that we need to follow when we're naming an identifier. The first thing is no special character except underscore can be used as an identifier. So we can't use a special character to be an identifier, a variable name or anything. Similarly, keywords are not something that you can use in place of an identifier. So as we already saw, we can't use return, we can't use for. There are many other keywords that you cannot use as variable names, as something that you can use as an identifier. Then Python is case sensitive. So there a variable which is named var with V capitalized and a variable named var with every characters in lowercase. These are two different identifiers. So if I were to type var with V capitalized equals to 7 and type small v small a and small r equals to 7 and if I equals to 8, and if I were to print the values of both, we will get different values. So these are two different things. When Python interpreter takes a look at it, it will assign two different buckets for them. Then the first character of an identifier can be an alphabet or an underscore, but not a digit. So as we have already seen that we can use any alphabet as the starting character of our identifier or variable name. On the other hand, we can use underscore as well, but we cannot use a number. A digit is not something that we can use. So that's you can use it afterwards. It could be the second or the last character or anything in between, but can't be the first one. So let's take a look at them. If I were to open the Python console, we have several ways of doing it. In Python, a variable is also an identifier. So let me just show you the casing problem. So variable is 7. And if I were to name it with a capitalized V, it's a 7. And if I were to name all of them capitalized, it's 7. So let me just change it. Now it's 7, it's 71, and it's 72. So if I were to print var with everything in lowercase, it's 7. If I were to print it with V capitalized, it's 71. If I were to print it all capitalized, it's 72. So all of them hold different values. And the last thing is we cannot start it with a number. So let's say 1 var equals to 7. we'll get a syntax error. But if I were to do it v1ar, this is just fine, it will work. v1ar, and it works just fine. Now we come to literals. So literals are just raw data that is given to a variable. So literals can be of many types: string literals, numerical literals, boolean literals, special literals, and we'll take a look at them one by one. So as you can see, we can have several kinds of literals. This is some code that's been written for you, and we'll take a look at string literals first. So found by enclosing a text with quotes. Both single quotes or double quotes can be used. So this is some code that you can take a look at, and you can type it in your own console. You can type it in any other kind of environment in which you can run Python code. I will expect you to run it in console because that's where you get the most immediate feedback, but it's your choice to run it in any other environment if you're comfortable with it. So let me just show you what we can do here. So I open this, and as I've already discussed, we need to enclose our text within quotes to tell the Python interpreter that it's a string. Let's try it. So if I were to give path is a variable and I want to assign a string literal to it, I can type sample path, press enter, and it works. This is sample path. If I were to type single quotes, this wouldn't make much difference. It's going to be just the same. It's going to work just fine. Now, the reason why we have single and double quotes for this, it's mainly because in C and C++ and many other languages like Java, single quotes were used for handling a single character, not a string, but a single character. So a single character would be something like A. That's a single character. A string with length of 1 is something that's called a single character. Now, the way it worked in Java and C was that if you were to attach multiple characters one after the other, so let's say A, B, C, D, and then you were to do it that way, then that would be a string. And for that, you can't use single quotes, you have to use double quotes. I'm simplifying things a lot because there's a lot undergoing like the null pointer and all, but you don't need to worry about that. You just need to understand why there's two quotes and why there's one quote. And that's the thing I'm trying to get across. So if a person shifts from C++ or Java to Python, they will be expected to use, or they will think they'll be using a single quotation mark for a single character, and that would work. And for that to work, they have created they have allowed for us to use both single quotations and double quotations. There's also one thing that you could do. You could use three single quotes as well. So if I were to write a really long line of code instead, or a really long line of string, I could just start it with three quotes. I press enter. As you can see, the prompt, instead of it being three arrows pointing left, it's now become three dots. Now I can type anything. Let's say that I'm typing this. I press enter. It's still allowing me to type. I type this. Let's say that you're typing a paragraph or a note or an email or something like this. I can do it this way. Now let's say that this is everything that I wanted to type, including the enter character. Now if I want to end it, again I type three single quotations, press enter. I get back the prompt with three arrows pointing left. I type in the word line, press enter, and as you can see, I get everything. This \n characters is something that is used to determine a new line. So if I were to print it using the print function that we have already discussed, press line. As you can see, it starts here, enters or creates a new line, prints everything wherever the \n character comes in. Then at the end, it again starts a new line and then ends it there. So the \n character is a special character that tells you that there is a new line here. So you don't have to worry about that as of now, but just understand that that's how we do it. It's not just strings though. There are many other different kinds of literals as well. There are numeric literals as well. And numeric literals allow us to use variables that can store numbers. Now we can have positive and negative whole numbers with no fractional part as integers, as we have already discussed. We could have real numbers. real numbers are numbers with fractional part using the float variable, and we could have long. Long is also something that could be used to store values, but the important thing is that it could store a much larger value than integer. So as you can see in the description, it says an unlimited string of integers followed by uppercase L or lowercase l, and I'll show you what that means in a moment. And then it's also something that you could do. You could store some complex numbers, so numbers with real and imaginary parts. Now, if you've worked with mathematics, if you worked with real and complex numbers, that you will understand what I'm talking about. If you've not worked with it, that's totally fine. It's not something that's used very often. It's only used in special cases where you need to display complex numbers. So in our case, let's just take a look at this. We have a positive and negative numbers. So we can store that in integer as well. Let's say that I want to store negative 77. I can store it in number, or positive 77. I can store it in number, and the type of number will still be a class of integer, right? But if I were to attach capitalized L here, that would cause an error. Oh, because it's a newer version. So never mind. So if that was the case, then I could do that, but it's not. Yeah. So as you can see, it's working fine. Now, if I were to do a lot of other things like floating point numbers 1.56, and if I were to get the type of it and press enter, this would give me a class of float. So float, as we have already discussed, is something that is used to store floating point numbers or fractional numbers or real numbers, however you want to call it. So that's how we store that number. Now, there are many differences between how these are stored in underneath the hood. They are stored using binary format, and we don't need to get into that. But the thing that we need to understand is that when we're using binary format underneath the hood, Python takes a look at the data type and then decides how it wants to set the binary format of that number. So that's why we do it that way. Now there are many other ways you could do it, and you could use many other tricks as well to store other kinds of numbers, convert float to integer, divide two numbers and make it convert to float or anything else. That's also doable, but it's mostly that you're supposed to do it easily. That's there. Make sure that you're using the easiest option. Make sure you're choosing an option that works for you. In Python, the value of an integer is not restricted by the number of bits, so it can expand to the limit of available memory, and no special arrangement is required for storing large numbers. Now, that is mainly because in Python, you don't need to, as I've already told you, it's a high level language. It's not a low level language, so you don't have to worry about changing the types or the available bit size of a number when the number becomes large. Python will do it for you automatically. It will take a look at the number, it will take a look at whether or not it's exceeding the current memory bounds, and it will assign a larger memory bound for it so that you could add more numbers to it, unless and until it reaches to a point where it's overriding the available memory. That then there's no memory to store the number and it will cause an error. And no special arrangement is required for storing large numbers. Python again does it for you, so you can just follow on working on your application instead of working with the nitty-gritty details of how things work underneath the hood. This is why I told you that you don't need to worry about the binary arrangement underneath the hood. Python will do it for you. Then comes Boolean. So Booleans evaluate to true or false. True and false are basically a human construct. So let me just show you what that means. If I want to check something, let's say that there's a user and I'm building an application and I ask him to enter a password. He says the password is ABCD. He's creating his account. He says ABCD. Then it comes to confirm password and he writes ABCD again. Now I want to check whether or not password and confirm password contain the same number. So I press password equals to confirm password. I press enter and I get a Boolean value of true. So this is what allows me to understand how to move forward. If it returns true, then I can basically move ahead and tell the user, okay, everything worked perfectly. I'm going to store it in the database and do whatever I want with it. On the other hand, if it had returned false, let's say the confirmed password was abcd1, the user mistyped it, and now I check whether or not they are equal, I get false. So this is what Boolean values are. You can assign them yourself. So let's say bol equals to true. Make sure that you understand that the first letter is capitalized. So smaller letter true will not work since Python is case sensitive. So if I were to type bol, that's true. And I can also assign false to it. Press enter, and this works as well. So this is how that works. Now that Boolean is understood, let's move ahead and see what other things that we have for us.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So we have special literals. These special literals are something that we can use for ourselves. So these special literals in Python are called none, which means that the variable is yet to be initialized. So if you're coming from other languages, there's a concept called null, N-U-L-L. So that's basically what Python uses, but instead of null, we use none. So let me give you an example. Again, let's say that the user is entering something, the confirm password, and the confirm password field has been left blank. So instead of writing something inside it, he chose to write nothing and they submitted. I will get a none value here. That means absence of a value, that the user has not provided a value. So that basically means that if I print confirm password now, I will get nothing because nothing is there. It contains no value. It's empty. Think of it as a box that contains nothing as of now. And when the user does enter something, that box will contain that value. So that's what none is used for. It's used to define absence of value, not an empty string, not any other kind of string, not zero, not anything else, but an absence of value. And the type of none is none type, in case you were wondering. And now we have operators. So let's take a look at some data types in Python. So data types in Python could be divided into two parts, immutable and mutable. So immutable data types are data types that cannot change. On the other hand, mutable are data types that could have their values changed. So for instance, string, numbers, and tuples will have some value assigned to them. And then when we want to change them, instead of adding something to it, it will create a new data type for that. It will create a new value for that variable to hold. On the other hand, in mutable, we have lists, dictionaries, sets, and in lists, we have several types as generic list or tuples and all. We'll take a look at them one by one. So let's take a look at them. So we have numbers. So a number is basically, as we've already discussed, data types such as integer, float, and complex data types. They come in numbers. So as you can see, a whole number with no decimal point is integer. A fractional number, a number that has one or more numbers after the decimal point, is floating point number. And a complex number is a number with real and imaginary parts. So again, complex numbers are not that prevalent. Mostly we use integers and floats. Complex number have some use case, but not a lot. Then comes strings. So a string is basically a lot of characters that are enclosed within either a single or double quotes, and they are used to store text. So a string literal could look like this, as we've already seen. So there are some operations that are being performed on string, and we'll take a look at them now. So if I were to open my Python prompt, let me just define a string. So string equals to, hopefully you can see this. And if I type A, B, C, D, E, F, G, H, press enter, this is a string. Now if I want to take a look at the length of the string, how many characters are there in this enclosed within the double quotes, I will type length string, and I have 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. Now let's say that I want only the first 4 characters. This is what is known as slicing. This could be done with a string or with any other character as well. Firstly, let me show you what happens if I do this. I get A. This is what is known as indexing into a string. Basically, what I'm doing is I'm saying in the string variable, whatever data it holds, I want the data that is stored within the first position. And in string, everything starts with the position starts from 0. So 0 is the first position, 1 is the second position, and by that logic, since there are 8 variables, 7 will be the last position. I press 7 and I get H. If I try to go outside these bounds, let's say I press 9, I get index out of range. Basically, there is nothing after the position 7. Everything outside that is not accessible by Python. We have not assigned any memory to it. So that's illegal for us to do, and that's why we get an index error, as you can see here. Index error mainly because we are using this, and this is what is known as an index, something that is enclosed after a variable named enclosed within 2 brackets. So now that we know how to access a single variable, a single character in a string, let's say that I want the first 4 characters. First 4 as in A, B, C, D. So I start from 0 and I want everything before the fourth character. Why? Well, because 0, 1, 2, and 3 are the first 4 characters because it starts from 0. So we have 0, 1, 2, 3, which are first 4 characters. So how do I get all of them at once? Let's say there are 15 and I want 0 to 14. So what I can do is I can type 0. After that I type a colon and I type 4. This means get me everything from the beginning of the string and right before the fourth character. So the fourth character is E and before that is D. I want everything from A till D. Press enter and I get a substring of it, which is A, B, C, D. So this is what slicing a string looks like. This is what's known as a slice operator. Now you can do it every other way as well. It's not necessarily that you start with 0. You can start with 3 to 4, which will give you, I think, just one character, which is D. Now, another thing, if I were to leave this off, what do you think will happen? Pause the video and try to think about it. But if I were to do it now, it starts from 0. So it defaults to 0. If I were to start it with a number that's this, it will give me an empty string because it makes no sense. So that's how you do that. And finally, if I were to leave 4 off, since we know what happens here, I think we can probably guess what's going to happen here. I'm going to press enter and you can see what happens. What happens is we take everything from 5 till the end. So we have the 5th character or this the 6th character in this, which is on the 5th index, is let me just print the string again because it's gone out of character. So it's this. So this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. I want everything from the 5th character till the last character. So this is what that means. And finally, I can use negative indexing here as well. So I want everything from the beginning till the removing the last one character. If I were to remove the last 2 characters, I can do this. And this works just fine as well. So that's how slicing works. Another operation we can perform is replace something in this. So let's say string dot replace. If I were to show you the example here, as you can see, it says replace ed with e, and it will do that here. But let me just show you. Replace f g. I press enter, it returns another string to me, which is a b c d e g g h. Now if I were to take a look at the string variable that contained our value, it has the same data. So when we perform this replace operation, what we're actually doing is we're saying give me another string in which you have replaced all the f's with g's. This is especially useful if you're trying to remove some content out of a long line of text. So let's say that you have 17 lines of text in which you want to remove all the, let's say you want to remove all the vowels for some reason. You could just run this and see if there is any A E, I, O, or U and just remove that. That will work just fine as well. So now that we're done with string, now we're done with data type in string, let's move ahead. Now comes tuples. Tuples are a sequence of immutable Python objects. So what does that mean? Well, let's say that you want to store the number of or the name of weeks or in string format in a variable. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, 7 days in a week, and all of them need to be stored in a single variable. Now there are many ways to do it. One important thing that you need to notice here is that this data is not going to change ever. There is no time in future are you going to go that we need to add another day to the week. That doesn't seem very feasible. So because it's not going to change, we are going to use an immutable data structure or an immutable type, which means adding something to it is going to be it's not going to be something that's allowed. So let's say that I want weeks. Now I want to store everything in one. I could certainly create variables that say sun, which will contain Sunday, and similarly Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's certainly doable, but again, it runs into the same problem. Let's say that we had 14 things that we needed to store. Let's say that we had 100 things that we needed to store, and we needed to access them using one variable. That would be very difficult to remember the variable names of 100 different kind of variables. It would be better if you could store them just in one variable and then access them using the position syntax that we had discussed earlier in string, like this one. So this is where tuples come into play. So let's say weeks, and I enclose it in brackets, but that's not really necessary. But I would do that here. Now let me just type in Sunday, and you could type it with me. Monday, Tuesday, Wednesday, Thursday. Make sure that you're separating them with commas. I'm typing a space after commas to make it more readable. That's not really necessary. Friday, and finally Saturday. Press enter. I press weeks, and this is what we get. If I were to take a look at the type of this, type, it's tuple. So now I said I used commas here, and that's not really necessary. If I were to use this would also work. The way Python identifies that this is a tuple that we want to into the data is by taking a look at this comma. So it takes a look at this line. It says, okay, weeks need to be assigned somewhere, some value. It takes a look at Sunday. It says, okay, one string, and this comma. That means other values are also going to be assigned, and this is a tuple. Even if I had not put the parentheses before and after, opening parentheses and closing parentheses to enclose this list, it would work just fine. Now, one thing that I would like to show you is if I were to go weeks 0, I get Sunday. Weeks 6 should give me Saturday, right? But if I were to assign some other value to it, let's say any gibberish value, I press enter and it gives me another. Tuple object does not support item assignment. Now this is one of the major advantages of using immutable object. It does not let anything in the data that you have already entered to be manipulated. So if you have entered a list of something that you know is not going to ever change, then tuples are the best option for you. So this is why we use tuples. So now let's take a look at something else. We have lists, dictionaries, and sets. So lists are very much same to tuples. One major difference is that you can make changes in a list. So if you have dynamic data that changes rapidly, then you can use a list for that instead of creating new tuples for every change that has occurred. Let me show you an example. Let's say that instead of weeks, I wanted to store, let's say that I wanted to store salaries of people, right? I can store salaries of 3 people. Let's say that it's stored in thousand. So 10 means 10,000, 15,000, 20,000. Press enter. And now if I were to take a look at salaries, press enter, I have 3 salaries. If I were to take a look at the type of salaries, I would get list. It's not a tuple, it's a list. That means that if I want to change the salary of a person, because it does happen that a person gets promoted, they get an increment or whatever happens. They say that the person at the index 0 is now going to get a salary of 18,000. And now it does not throw any error because I am using a list and I can store any kind of data. It's still a list. And if I were to print it, now it's 18. Another cool trick that I can show you is that instead of this doing it like this, let me just assign 10 to it. And let's say that the thing that I want to do is I want to, instead of assigning a new salary, I want to add 8,000 to the guy's to the person's current salary. Now there are many ways to do it. First way to do it would be salaries of 0 equals to salaries of 0 plus 10. So what happens here is I take a look at this. I want to assign the value at index 0 to be the current salary of the person and add 10 more to it. Let's add 8 more to it to add consistency. So as you can see, this is what it looks like. And now if I were to look at it, it works just like that. But as you can see, the typing this is quite long. It's a bit repetitive. So you get, if you've already taken a look at the operators slide that we have taken, that we have gone through, one operator there was plus 8. Now what will happen is it will add 8 to the already existing salary of the person at index 0, which is 18. So 18 plus 8 would give you 26, and that's what we've got. So you can do it this way. You can add, remove, you can add data to it as well. So I could go salaries dot append. Append will allow me to add a new salary for a person. So let's say that it's 28. I press enter. Now instead of 3, it contains 4 salaries. Append is not something that you could do on a tuple. So that's how you do it. And another thing is that instead of storing all everything as an integer value, you can store data of any type. Let's say that I want to store 1 a and I want to store a floating point value as well. This is also doable. So I can type mixed equals to this. This is one of the advantages of using Python. Many languages don't allow for this kind of intermixing of data when just trying to store it in an array or in a list. So you can take a look at that. Now if I were to type mixed, I get this. I can store any other kind of data. I can even store another list inside a list. So if I wanted to store another list, 155, comma b, I'm just adding some gibberish value just to show you. This is doable. I can add another tuple to it. This time I need to put this parenthesis. So to describe, I'm adding a tuple 88, 77, and it's done. Now if I take a look at mixed, I have this. If I want to take a look at mixed of 4, right? It's tuple, and I can take a look at the type of the tuple to see if it's a tuple or not. And it's a tuple. And if I were to take a look at the type of something at index 3, it would be a list. So you can nest any kind of thing, but just don't go too crazy with it. That could cause a problem. You will not be able to comprehend the data that you have if you go extremely benign on it. Then we have dictionaries. In other languages, they are called hash maps or hash tables. So a major advantage of using a dictionary over a list is, firstly, it allows you to create a key value pair. So again, let me just show you. So if I want to associate a person's name to the person's salary, instead of doing a list which could only be accessed using a numeric index like 0, 1, 2, 3, what I can do is I can create again salaries equal to, and I can create a dictionary like this. Add 2 curly braces. Inside it, add the key, which would be the person's name. Let's say John, and end the quotation. And now the person whose name is John gets 15,000. Let's say that there's another woman who's named Jane. She gets 14,000. Let's say that there's another man that's named Johnny. and he gets 5,000. Press enter. And now if I were to print salaries, it will display the key value pairs. If I were to take a look at the type, it will give me a class of dictionary. So that's all good. But one thing that it allows me to do now is I can access it using the person's name. So let's say that I have salaries. I want to get the salary of Jane. I press enter, I get 14. That means Jane earns 14,000. Let's say that instead of Jane, I want John. As you can see, John gets 15,000. And if I were to use a name that doesn't exist, I'm going to get an error. This is called a key error. This key does not exist. Now, a way to come across this or come over this is instead of indexing directly, you can use get. So I want salary of John, but if it's not available, give me 15. So I'm getting 15 because that's the salary of John. And if let's say that I were to use some other key that is non-existent, the person named John ASD is not available in our dictionary. So if I press enter, I'll get 18, which is the default value. I could set it to anything. I could even set it to 0. So now if I try to access a person whose name is not available in our dictionary, I'm going to get 0. So that's one of the major advantages. Another is really fast. So even if you have like 10,000 records, the way hash table works or the dictionaries work underneath the hood is instead of it going through all the 10,000 names and finding the name that you want it to find, it does some clever tricks and makes it really, really fast. This is why if you are doing something that requires really fast access to some data and you can give some unique key for that data to be accessed, then definitely use dictionaries instead of using lists, because in lists you could in lists do something like this. Store a list of list in which the first thing is the person's name, second thing is the person's salary. I could do it here as well. The first thing is the person's name, Jane, and the salary of Jane is, let's say, 80. Okay. Now, if I wanted to, I could define a function that could find this or do a lot of things. But the important thing to understand is if it was, let's say, 10,000 records, and I wanted to find a person's name let's say that a person's name was not John or Jane. I wanted to find a person whose name is at the end of the list. Let's say I don't know where the name is. Let's say that the person's name is Andy. So we go through the entire list searching for the first element and checking if that first element is Andy. And if it is Andy, then we print the salary. If not, then we print 0. Now, for that, we have to take a look at all the 10,000 elements. In dictionary, what we do is we can just give the name, and dictionaries will do some clever tricks behind the scene that you don't need to worry about, and it will instantly find it for you. So always use a dictionary when you have large sets of data and you want to constantly find things in it. If you want to just store some data and you know you can access it using numerical indexes, and the data keeps changing, then use lists, because in tuples you can't change the data. So if I have some, let's say I have 0 and I want the person with the employee ID of 0 to have salary or something, then I could press 0. Here it's not going to work because I've reassigned it to a dictionary, so I'm getting a key error. But you can understand my point. On the other hand, let's say that I have a data set which does not change and I want to access it using numerical indexes. Then tuples come into play and you used to use tuples. And finally, we get to sets. Sets are by far one of the most underused data sets, and you need to understand why we use sets. So sets are again unordered collection of immutable data which has no duplicate elements. So what does that mean? Let me show you. I can create a set. By the way I'm showing you how to create dictionaries and all, that's not really necessary. Let's say that I want to create my sample dictionary. I can just use the keyword dict function and it will work just fine. Now it's an empty dictionary and I can add data to it. Another thing, you can add data using dictionary and typing in the name and then assigning a value. This will work just fine. Now the thing you need to understand is similarly you could use instead of this you could use tuple. This will create a tuple, and L list. We'll create a list. Now I want to create a set. So let's say that I name it S. Now I can do it this way, but I won't be able to add anything because this will be taken a look at as a dictionary. So the best way to do it is use the keyword set or the function set. And now if I take a look at S, it's a set. So what is a set? A set, if you have worked with mathematics and you have worked with Venn diagrams and everything like that, you are quite understandable of what set is already. A set is basically something that contains a lot of values, but it does not contain any duplicate values, and it allows you to check whether or not something it contains a value or not in constant time. So let me give an example. I think s dot add 1 would work. Now if I take a look at s, it has 1. If I were to add 2, it contains 2. Now if I were to add 2 again, it instead of containing 2 elements named 2, it contains 1 element which is 2 with the value of 2. Now if I want to check whether or not something exists in a set, let's say 1 in s, and it will show you true. This is the in operator or the membership operator that we have already taken a look at. And if I were to take a look at whether let's say I want to check whether 5 exists or 3 exists, it's going to be false. So why are we doing this? Well, one thing that you can take a look at here is that it again, since we are using set, it is extremely fast for us to perform this operation. Let's say that there were a million records in this, and I wanted to check whether something exists in it or not. The first intuition that comes into our mind is to take a look at everything that is inside the set, all the 1 million things, and compare it with the data that we want to find. If it's not there, then we return false. If it is there, if it's found in while we're taking a look at all the 1 million data points, then we return true. Now again, that is fine, but if it's 1 million records, then it takes a lot of time. And let's say that you had to do it constantly. Let's say that you had to check whether or not something exists in those 1 million records 10,000 times, 20,000 times. That's a lot of computation. So again, sets do some really complicated mathematical things underneath the hood to basically just check whether or not something exists inside it in real time. That's why it doesn't contain any duplicate values in this as well. And so I can do 1 in s as well. If I were to assign a list of 1 comma 2 to it, and then instead of 1 in s I can type 1 in l, and that will return true as well. The difference here is that it takes a look at all the elements 1, 2 and whatever, and finds if something exists in it or not. Whereas in set it's extremely fast. So if you have some data that you want to keep track of and want to check whether or not another value exists, or you want to deduplicate the data, you can do that as well. So use set when you want to check memberships really fast. You can perform the union, intersection and all that, and that's very easy to do with sets as well. So now let's take a look at how to deal with sets and how to deal with different data types. I'll show you some hands-ons to further strengthen your knowledge of data types. So let's take a look at the setup that we're working with. So we'll be taking a look at data types. We'll be taking a look at lists, sets, dictionaries, and tuples, the things that we have already discussed. But instead of typing into the Python console that we had done earlier, let me show you how. This was the console that we had typed code into. Now for typing out single lines and executing them, this console is actually very good. But let me just exit out of it. When you want to type in a lot of code and you want to open a code file and do execute it and run all that, I would recommend that you use Visual Studio Code. So let me show you what it is. Let me just open a new window. And here type in VS Code. Press enter and open this. Once you've done that, you can download it for Windows or for any other operating system that you have. After you've downloaded it, you can install it like any other software that you install. But after doing that, just right click on a folder that you want to open it into, type and press the open with code function. It will open VS Code folder. So it's done. And as you can see, there are no files as of now in this folder. The folder's name is hands-on, in which we'll be performing the hands-on. Let me create a file called app.py. py is the extension, the Python extension presenter. Now, just to make it clear, you don't have to use VS Code if you don't want to. You can use Notepad for this as well. Just go to the folder, create a file named app.py and right and click on edit. It will open it in Notepad and you can make the changes there as well. There's virtually no difference. Now what we need to do is I open this and let me just make some changes. I'll increase the font size so that you can see a little better. So it's loading some extensions, and while it's doing that, open the command prompt. To do that, just go onto the address bar, delete everything, type cmd, press enter. The reason why we do it this way is because we want to open this command window in this folder so that the files that we create, the app.py file, I want to run it using the Python command. If you've installed Python, then it's already available for you. Here you can do it this way. Now if I open this, as you can see, I can type in a lot of things.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now I'm going to type some Python code. Hopefully it's visible to you all. So in Visual Studio Code, you can write code, and the reason why I'm choosing this is because it shows you some syntax highlighting. It shows you if you've written something wrong. It auto formats the code for you. It does a lot of things for you right out of the gate. So to perform this, what I'll do is the first thing we'll have to do is we have to use lists. So let's say that I create a list named nums equal to, and the numbers that I want to insert in it are 1, 2, 3, 4. So the first task I want to do is I want to print it. So I print nums, save the file. When you save it, this icon changes from a filled circle to closing to an X. Now that that is done, open the command prompt and type python Python and the name of the file, which is app.py. Again I press enter and it's there. Let me just increase the font size here as well so that it's easier for you to see. Let's say it's 28. That's easier to see, right? Yeah. So again, Python space and the name of the file, which is app.py in our case. And one thing that you should notice is that app.py is in the folder in which the command prompt is open. So it's C user, my username, desktop, and in the desktop we have a hands-on folder inside which we have created the app.py file. This is why this is working. Another thing you can do is you can press this command, but it would work sometimes and sometimes it won't work. So I don't like doing it that way, and it gives you this line of code as well, which is fine. But we're doing the same thing. We're typing Python and the name of the file. So you can do it either way that you want. Now that is done, let me just add a comment. So a comment is basically something that you add in a code so that you can explain your code better. Now if I type anything here, this code will not be executed by interpreter. It's just for the reader of the code. So any person who's reading the code can take a look at the comment and understand. So I'll type declare array and print. Declare list and print. Right? If I run this again, it's not going to make any difference because it's a comment. Now that that is done, let me show you how you can add something to the list. So you get the append method. In the append method, I can type in a number. It could be of anything. It doesn't need to be a number. It could be a string. It could be an object as well. I'll type in a number though. Let's say that I want to add 5 to it. I save it. I print it again. Run it. And I think I've run into an error. Yeah, I want to print nums. Sorry. And as you can see, now nums has 5 in it. I can do a lot of things in it as well. Instead of that, I could use the pop method. Pop method removes the last element if I don't pass in an index. So if I were to store the value, what it does is that it removes the value and returns it so that I can also take a look at what was removed. And now if I print nums, run this. This is the number. I added 5 to it. It's this. Remove the element at the end, which was 5, and now I printed it's 4 again. But a cool thing that we can do is instead of not specifying the index, we can actually specify what is the index of the element that you want to return. So if I want to remove something at the beginning of the list, I type in 0. This would remove 1 from it. So if I run this again, instead of 5, we'll see 1 removed. So 1 is removed, and now it's 2, 3, 4, 5. So again, you can do a lot of things with it. One of the things was this. Now let me show you something that's really interesting. So if I want to print all of them, what I do is I use the for loop, and we'll discuss this in a later slide, but just to give you an example of where looping is useful. If I have 10,000 elements, instead of accessing them one by one and writing things like print num0, and then I keep going on like print num1, num2, num3, so print all the 4 numbers. What I can do is I can just print a loop and tell it that I want to print everything inside the list. So everything in this list, I want to do something with it, and what I want to do will be indented here. Do you notice that I put a tab after this, or Visual Studio Code does it for me? This is what's called indentation. This is what tells Python what is the code that I want to execute in a particular block. So if I type print x, and if I do this, as you can see, it's printed 2, 3, 4, all of them in a new line for me. So this is what the loop looks like. Now, if I had not done it this way, if I had done it this way, then Python would have no idea whether or not I want to include this line in the loop, whether this should be executed in the loop or not. Or to give you another example, now I want to print done. Done will be printed at the end of the file. So if I run this, it's printing done after each execution. But if I unindent it, if I push it to the left side, I run it again, and now it's printing done afterwards. So Python looks at it, goes, okay, everything that's underneath this for loop that's indented 1 point to the right is going to be something that needs to be executed within this loop. And this is how Python reads your file and understand what is the code that I need to perform and how. So make sure that you understand the indentation. Now that we have looped over this as well, let me show you something about tuples. So instead of 1, 2, 3, 4, 5, if I remove the parenthesis, what do you think will happen? Press enter. So it prints everything, but it immediately gives me an error that there's no way to add something to a tuple. If you remember, we have already discussed that tuples are not something that you can add something to, they're immutable. So that's why we do this. So instead of appending, I don't think we can remove things as well. I press enter, and pop is also not available. But you can print them, you can loop over them, just as we did earlier. As you can see, 1, 2, 3, 4, 1, 2, 3, 4 done. It's completely doable. Now let's move on to dictionaries. Let me type this. DICTIONARO dictionary, or let's say I'll call it cell. I'll define a dictionary the way I did previously. Jane 15, John 20. I need to add it as a string. Now that that is done, if I print it, let me just remove this. It's this. I want to add something to the list or to the dictionary, I can just do it this way. I want to add Andy to the list, and he earns 25k. Now if I were to print this, let me just, yeah, now we're getting Andy here as well. As you can see, Jane, John, Andy. So this is working. If I want to delete something from the list, let's say that Andy, I don't want to print, I don't want Andy in this list anymore. I use the del keyword. Inside, I just type in sal of Andy. I run this again, and Andy is removed. So that is fine. That's how you remove an element from a list or a dictionary. Other operations we have already performed. One thing that we haven't performed is looping over this. So let me just show you. For item in, and here things get a bit complicated. So instead of just sal, I have to type items. If I just want to loop over the keys, I can type sal.keys. And if I print item, what do you think will be printed? So pause the video if you want to think about it and then answer. But what will be printed are the keys. So the keys are Jane and John. Remember, a dictionary is a key value pair. These are the keys. These are the values. So Jane earns 15. John earns 20. So we type it. We print in the keys. Now, if you don't want to print the keys, let's say we want to print the values. I do that. Now I can only print the values. But let's say that I want both of them, items, and I want key as well as val. Now I can print key, comma, val. And as you can see, I'm printing Jane space 15, which is the key, comma, value. So we're getting the data that we want. Now, another thing that we can do is we can print Jane in cell. Print it and we get true. It's the same operation, it's a membership operation, but if I were to type in DSF, I'm going to get false. So again, this is what it means. And now let's take a look at a set. So let's say S, create a set. Another thing you can do is you can use this symbol, but instead of typing a key value pair, you just type in the keys. So if I print the type of S and I run this, it's a set now. So if I were to keep it empty, then it would become a dictionary, because this is what the default Python behavior is. So this is what it looks like. We have a set for us. Now, if I want to add something to the set, I just use the add method. I want to add 1, and I want to add 2, I want to add 3. And now if I were to print S, it's 1, 2, 3. So this works fine. But if I were to loop over it for X in S, let me just print X. As you can see, we get all the numbers in it. And if I were to print the same thing that we did earlier, 1 in S, I'll get true. And if I were to print 4 in S, I get false. So this is what this looks like. This is what our code looks like. This is how it works. So hopefully that was informative. Now let's move ahead and see what else can we learn about Python. So now let's take a look at comprehensions. Comprehensions are quite an interesting feature in Python. They're very easy to use. They're very informative, and they are quite fun to work with. So let's see what they mean. As of now, we know how to create a list. I asked you to create a list, and let's say that I tell you that, hey, I want you to create a list, and in that list, I want you to enter number from 1 to 5. What are you going to do then? And let's say not 1 from 5. Let's say that I say, I want you to enter in a list. I want you to create a list and add a number from, let's say, 1 to 10. Or it could be anything. It doesn't even have to be 1 to 10. It could be any arbitrary number. So how do you go about doing that? Well, we know we can do it using loops, and that's how many languages ask you to do it. So I'll create a list which is empty, and for let me show you how to loop to a certain extent. I want to loop for X in range, which is a function that allows us to loop over a particular range. I want to loop from 0 to 10. So it will loop from 0, 1, 2, 3, 4, 5, 6, 7, 8 till 9. Not 10, because the end is exclusive. So always remember that. And now if I do L dot append X, and finally we can print X, not XL. So if I were to clear the screen and type in this, as you can see, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is fine, but a major problem that you can see with this is the fact that we have to write a lot of code. Wouldn't it be nice if we could just compress this all into a single, compress all of this into a single line of code, because we are just instructing the computer to add something to a list, right? So this is possible using comprehensions. I define an empty list. I tell it add X to the list. Now Python is waiting for me to define what X is. So I'll go for X in range 0 to 9, and that's it. Now this is something that many other languages don't provide you to do. Python is quite easy to use, so you can do that. Here we only get 0 to 8, mainly because it has to be 10, like we did earlier. And this works. Now this is just list comprehension, but I can perform many other kinds of comprehensions. So list is this. Let's say that I want to perform a tuple comprehension. So for this I have to use parentheses. And let's say that I want to perform a set comprehension and a dictionary comprehension. All the data types that we have discussed so far could be, all the containers that we have discussed so far for the data types could be used to perform comprehensions, as we are about to do now. Comprehensions are quite easy to understand once you get through the basics. So let's see. Let me just print all of them one by one. So we will print the tuples, then we will print the set, and then we will print the dictionary. So let me just show you. This is what tuple comprehension looks like. What will it be for set? Just changing it to parentheses will work. Now for dictionary, we need a key value pair. So let's say that we want to store key as the current number, which is the number from 0 to 9, and the value as the square of the number, which is number divided by itself. So this is what it looks like. Now for a number to be key value pair, I want to define the key, press colon, and then define the value, which is x multiplied by x. Now if I were to print it, as you can see, we get this, we get a generator object, and we get this, and we get this. So this is what it looks like. Now generator objects are quite easy to understand. You can just, let me type in comma, press enter, and you will get run into error. So don't do it this way, but you could use tuple, and now you press enter and you get a tuple out of it. So this is one of the problems when it comes to tuple comprehensions, that you can't just use it this way, right? But this is what comprehensions look like. They're quite easy for you to create once you understand how to create them, and it's very easy for you to understand how to write code like this, and it just allows you to write succinct code, or code that's easy to understand. Now that that is done, let's see what else we have to do. So now let's take a look at conditional statements. So a conditional statement is basically a statement that allows you to change the flow of execution, or the path of execution, when a provided condition evaluates to either a boolean value of true or false. So suppose that we had some way of figuring out whether or not you're sick or you're healthy. So what happens is, let's say that you want to make a decision. First thing is, we ask you, are you sick? So let's say that you are sick, then we would advise you to go to the doctor. But let's say that you are not sick. That means the condition whether you are sick or not evaluates to false. And then you can go out and play football, do whatever you want. This is where conditional statements come into play. And we encounter conditional statements every day during our lifetime. We have encountered conditional statements. I think you probably encountered conditional statements today as well. Waking up, when you're waking up, you decide whether or not to sleep for an extra 5 minutes, whether or not you are late for a meeting, whether or not to take a cab or a taxi or walk to the place that you work, whether or not to eat at one place. These are the kind of situations that allow us to think of conditional statements in a more rational way. So this is what it looks like. We have many ways of doing this. One is the if-else statements. So the statement looks like this. We have the if keyword. Inside that keyword, that's a condition. If that condition evaluates to true, then statements 1 and everything before the else statement gets executed. But if, say, the condition is false, then everything underneath the else statement will get executed, We'll look into it in more details when we are performing the hands-on, but right now just understand if the condition is true, then statements 1 is going to execute, and if condition is false, we'll execute the else statement, which is the statements 2. Now, there are many ways you can construct an if statement depending on the logic that you're trying to build. You can construct a nested if else statement, you can construct if else and else if statements, you can construct a lot of different kinds of if else statements. So you're not limited to just use if and then else and then your conditional statement ends. You can use if this not true, then if this is true, then if this is true, then if this is true. Then you can take a look at a lot of conditions that way, or you can nest them one inside the other. That would work just fine as well. So now let's take a look at some conditional statements. Again, we have the same setup. We have an app.py file. Py is the extension for the Python executables or the Python scripts that we write. So to write it, let's first take a look at conditional statements. So there are a few keywords that we use in conditional statements. Keywords like if, else, and elif, which is short for else if. So let's take a look at this. So let me define a number named x and it's equal to 20. Now if I check if x is less than 20, then I will print x is less than 20. Else, and now else print x is not less, or you could say x is greater than. So now this is a statement, but it's a little incorrect. I mean, it's not incorrect in the way the syntax is structured. So if I write this, it says x is greater than 20. And we know that's not true because x is not greater than 20, it's actually equal to 20. This is where the else if statement comes in. So we can add multiple conditions and attach code to it that will execute when one of the conditions satisfied. So if I type elif x is equal to 20, and remember to put two equals, mainly because we're not assigning a value, we're trying to check whether or not a condition is correct. Print x is equal to 20. Where on this again is correct. So this is where if, elif, and else come into play. If for condition, and a conditional statement will always start with if, not with elif, and neither will it start with an else. Then we'll check, okay, if this is not true, else, if this is true, then do this, and if this is true, then do this. Make sure that you understand that only one of these statements will get executed. So in no condition will it happen that this will also get executed and this will also get executed. So if I were to do x is less than, and if I run this, it's still going to execute the first statement, which is x is less than 20, even though the second statement is also true. So make sure that you understand that. And now let's take a look at nested else if. So this is what it looks like. Again, I could have made the same mistake. I could have just put equal and that would have caused an issue. Now, nested else if basically means an if statement, and I want to check if x, let's say x is less than 20 and is less than 15 as well. And I put it 10. So I will print something out there as well. X is less than 15, and I can type in else. Again, write some code. X is greater than 15, and finally else. X is greater than 20. So if I run this, x is less than 10, 20, and x is less than 15, which is true. Now if I were to give it a value something between 15 and 20, x is less than 20 but is greater than 15. What's going on here? Let's take a look at the path of execution. We assign a value of 17 to x. We check this condition. We check if x is less than 20. It is less than 20. We go down. We print x is less than 20. We go down. We check x is if it's less than 15. It's also true. So we go down and we print this. We skip over these statements because one of the conditions has evaluated to true. We go down here, and since that condition has also evaluated to true, it's fine. But now if I type x is equal to 21, what do you think will happen? Just one statement gets printed because it comes here, sees if x is less than 20. Well, x is not less than 20, so it just skips over everything inside if and moves to else and prints that, and it's done. So this is where nested if statements and else if statements come into play. You can nest it really deeply, but your code becomes really difficult to read if you can you can do it like this as well. If x is greater than 15 or something like this, and then again underneath that you can type another if, but it makes your code really difficult to read. So make sure that you understand the trade-offs when you're using if and else if statements. Now let's take a look at looping statements. So a loop is a process in which we have a list of statements that execute repeatedly until it satisfies a condition. So let's say that I want to print something 50 times. Instead of me having to write it one time and then copy and paste it 50 times, what I can do is I can instruct my Python program to repeat something or repeat printing something 50 times, and that way when the condition that is satisfied is that it has this statement been printed 50 times. If it has, then we print that. If not, if it hasn't been satisfied, then we keep on looping and keep performing the task that is inside the loop. And if we have satisfied the condition, then we exit out of the loop and move on to the next statements. So there are many kinds of looping constructs. The first thing is we have a for loop. So a for loop basically allows us to write code in which we can basically iterate over a lot of things. So this is what the flowchart looks like. We take a look at the variable and we check is there a variable in the list, and if it does not have any variable that are remained to be performed the task on, then we perform the rest of the code. Else we perform the statements, we move on. We perform the statements, we move on, and we keep doing that over and over and over again. This is where the looping statement comes into play. So then we'll have an example of this when we're performing the hands-on. So don't worry if you don't understand it as of now. Then comes the while statement. So the while condition is something that is also used in loops, but the fundamental difference is while loop is used to loop over a bunch of statements in which what we're trying to see if a particular condition is true or not. Instead of looping over a particular list of things, we can just use a while loop and loop over some things until a specific condition is true. So here what we're doing is we're setting a variable a to 1, then we're checking whether a is less than 5. So 1 is less than 5, we print 1. We add 2 to a, so a is 1 and 1 plus 2 equals 3. So now a is equals to 3. Is 3 less than 5? No, it's not. So the condition evaluates to false and we print it. So we print 3, we add 2 to it, 3 plus 5, 3 plus 2 is equals to 5. So a is now containing the value 5. We check whether 5 is less than 5. That's obviously not true. A is equals to 5. So we end the loop, and since there are no other statements left to be executed, we exit the program. Now when we're looping, there are certain keywords that help us in the loop. These are break and continue. So what do they mean? Well, the break keyword allows us to end the loop prematurely. So let's say that I have a list of names. Let's say that I have a list of names from a list that contains alphabets from A to Z. What I want to do is I want to print everything in the list, but if anything, if the character in the list is D, then I want to stop the loop. I want it to not continue any further. I want to just exit out of the loop. Anything after that is not going to be printed. So this is where the break statement comes in, and it's coupled with an if statement. And we'll take a look at this in an example when we're performing the hands-on. But now just understand that if you have a condition in which you want to exit a loop abruptly or prematurely before the loop has actually ended, then you can use the break statement. The continue statement, on the other hand, does something quite similar. So you can take a look at the break flow chart as well if you are unfamiliar with what it's doing. Basically, we check a condition and we check the break condition. If the break condition is true, then we break it and loop exit the loop. If the break condition is not true, then we continue with the loop as long as possible. Again, this is a bit esoteric, so I'll explain it in the hands-on when we're performing it with the code. Then comes what we'll try to do, which is looping and using continue. So continue does something similar to break, but instead of breaking the entire loop, what we do is we skip over that loop. So let's say that I'm again doing the same thing, a list containing all the alphabets from A to Z. I want to print it. They are ordered in any way that you like. What we're doing is we're taking a look at the alphabets and we're printing it on the screen. But if the alphabet is D, then we don't want to print it. We don't want to perform anything that's being done to other alphabets. So what we do is we take a look at it. We see, okay, if the current character is D, then we use the continue keyword and we skip over the rest of the statements that are used to execute the loop, and we just move over to the next character. So that's what continue does.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And now we'll take a look at a hands-on in which we'll be performing tasks using all the keywords that we have discussed as of now. Let's take a look at some loops. So again, we are in our app.py file, and I'll write some code for you to run to understand loops. So we'll take a look at for loop and while loop. The first thing I'd like you to see is we're going to be printing a number from 1 to 10. So let me just show you. So this is a classic example of loop for x in range. Range is a pretty common function used in Python. If you've never used it, I would suggest getting comfortable with it. It basically means, I'll explain the code in a moment. So what we're doing here is we're instructing Python that, hey, I want to loop over something. Every time the loop iterates, I want the value to be stored in x. And what I want is the range to be going from 0 to 10 minus 1, which is 9. Always remember, range is exclusive of the end. So if I were to type 11, that will go from 0 to 10. So that is done. Now what happens is when I print x, what it will do is it will start ranging from 0. So it takes a look at 0, prints 0, goes 1, increments it by 1, goes to 1, prints 1, 2, 3, 4, 5, 6, 7, 8, and it goes to 9, prints 9, and then it is out of range, so it stops abruptly. So let's see. If I were to run this, as you can see, it's printing, but let me show you a trick. When you're printing something, type the end equals comma, right? So end space. So now if I print this, instead of each thing being printed on its own line, what's happening is it's going to print it with a comma and a space between the next element. As you can see, that's the reason why there's a comma and a space here as well. So that is done. And so this is how you loop over a range. But let's say I don't want to loop over a range. Let's say that I want to loop over a list of numbers. So again, nums equals 1, 2, 3, 4, 5, right? Or if you remember with comprehensions, x for x in range 0 to 10. Now we have all the numbers that we had earlier, and this is what it looks like. I run this again. Okay, for x in range, and now it's doing the same thing. So we have numbers here, and for each number we are looping over that. Now that that is done, one thing I can show you is after looping, we can take a look at some of the statements that we had learned earlier. So break and continue. So let's say that I only want to print till 4. Let's say that this is a shuffled list, and I want to break the loop and not print 4. So if x is equals to 4, then break, else will print x. So I do this 0, 1, 2, 3, it encounters 4, and since the condition is satisfied, executes the break statement, gets out of it, and the program is not ended yet. If I want to type something below it, I can type like this, done, and it prints it there. What's happening here is I have just, as soon as I encounter the number 4, I just quit the loop. So everything that's after 4, it's not being executed in the loop. If I change break to continue, notice what happens. So we have 0, 1, 2, 3, 4 is skipped, then we have 5, 6, 7, 8, 9. So what happens, it takes a look at the number, it's 4, and we continue. We say we don't want to print 4, we move ahead. So this is something that can be helpful. Let's say that you're trying to print something out of a list, and you don't want to print the name of people whose salary is less than, let's say, 40K. So what you can do, if person, let's say that for each x0 index is x dot salary is less than 40, then continue. So this would have the same effect as it did earlier. This is what it means. So this is where we move on to the while loop. So let me just define a number, a is equals to 10, and instead of 4 we'll use a while loop. While a is not equal to 0, print a, and then a minus equals 1. So if I run this, it prints numbers from 10 to 1 in reverse order. So what do you think is happening here? So basically I have defined a variable named a, and I'm checking whether or not it's equal to 0. If it's not equal to 0, then perform this task. One thing that you need to make sure is if you're trying to check whether something is equal to something, and if it's not, then you need to manipulate it inside the loop. If I don't do this, then this will run forever. As you can see, it's going to keep printing on 10. I've interrupted it using Control C. I don't want it to run forever. So if I do this, then it understands how to do this. But it'll take a look at the number. It's 10, print 10, and in decrement 1, it becomes 9. 9 is not equal to 0, print 9, go ahead, remove 1. 8, not equal to 0, print 8. 7, and this is how we go till 0. We print 1, then we in decrement 1, which becomes 0, and we take a look at this. So we go, okay, is 1 equal to, is 0 equals to 0? That is true. So this statement evaluates to false, which is not equal to 0. So what happening is we are printing the things until this statement becomes true, and when a becomes 0, this statement becomes false, and we move out. So as long as this evaluates to true, our loop is going to continue. While, or another way of reading is, while this is true, keep executing whatever we are executing. So that's a while loop. Now, why use while loop over for loop? There can be many scenarios where you want to use for loops. I like using for loops mainly when, as you can see, if I can travel back in time. Yeah. So mainly I like using for loops when I have a list of values, something that I can easily access in a loop like this. Doing this with while loop would be a little difficult. Let me show you how. So I would need to have an index, start it with 0, and check while index is not equal to the length of nums minus 1. That is one way to do it. Or you can check if while index is less than nums value minus 1, I will print nums, the value is at index, and I will index plus equals 1. If I run this again, it will do the same thing, but I had to write a lot more code, and I have to keep track of this index variable. Similarly, Python's for loop does all of this behind the scenes for us, so we don't have to manage these external variables and all that for us. There's advantages to this, but if you want to if you want to have access to the index variable, then you can use a while loop, or you can use a clever for loop as well. But for most scenarios, when you have a list of values that you can iterate over, using for loop is better. And when you are working with a specific condition, then using a while loop is better. So it's completely up to you. It's your choice. Whatever feels the right tool for you, you can use that. But I would certainly recommend using for loops for iterable statements. Right? Now let's take a look at functions in Python. So functions are one of the most fundamental things that you need to understand when you're learning any programming language. They allow you to encapsulate code and then reuse it in many other parts. We'll take a look at what that means and how you can accomplish things with functions. But the first thing that you need to understand is that it's a very, very, very important topic, and you need to get a really good grasp of how functions work before you can move ahead and discuss other things and learn other things in Python. So make sure that you pay attention and understand it thoroughly. So a function is a block of code that is organized in such a way that it's reusable set of instructions and can be used to perform some related set of actions. So it's used to organize a reusable set of instructions that are used to perform some related actions. So we'll take a look at what that means. Basically, it means that we wrap up some piece of code that is entirely used to perform one thing, and that is then used, that wrapped up piece of code is then given a name, which is the name of the function, and then we use that name instead of copying and pasting the entire code. Again, we'll take a look at what that means and how to accomplish this. If you don't understand it as of now, don't worry. So there are two kinds of functions in Python. The first is a user-defined function, which is something that we create as developers, as programmers. And then there are some functions that are built into Python. So you don't have to create their implementation yourself. Python will have already done it for you. So the user-defined functions, as I've already told you, are created by users. This is what the syntax looks like. We use the def keyword. Def is a shorthand for define. We give the function name. We accept some arguments. These arguments are basically values or things that our function will perform some actions on. And then we do some calculations or any other kind of task that we wish to perform. And finally, and this is not a necessary statement, but if you want to return something, you can do that. Returning something basically means this would be the result of the function. Now sometimes your function may not have any result to perform, and if that's the case, then you don't return anything, you just omit the return statement completely. To give you an example, there's a function right beneath it that says def add is the name of the function. We pass in two parameters, a and b. We create a sum which is equals to a plus b. So anything that we have a plus b, and we return the sum. Now, to be quite honest, this is a very trivial example, but to understand how functions work, we need to move our way up from really simple to complicated examples. Now there are many built-in functions as well. These functions have already been written by the developer of the Python language, and they have created these functions for us to use. So some of them are these. We have an abs function, which is used to store the absolute value of a number. So if you have a number that is in negative, that is negative 17.4, then if you use the abs function on that, you will get 17.4. Absolute basically means it converts negative to positive. Or in other terms, you can get an absolute value where you perform some mathematical operations on it. Then you get all, and returns true if all items in an iterable object are true. So if I have a list of a list, and everything inside that list is true, then it will return true. If any one of them is false, then it returns false. Then we have any, then we have ASCII, then we have bin, which is used to take a look at the binary version. We have bool, we have many other functions, min, max, whatsoever. So you can use them if you wish to. If you are trying to perform some task, make sure that there is a instead of writing your own function, make sure that there is a function available for you. Then there's lambda functions. Now this is a concept that gets overlooked quite often, but lambda functions are very powerful. So lambda functions are basically anonymous functions that have no name, and it contains a single expression. A single line of code is there in a lambda function. So these are used to pass some task that we want to perform in a function. Let me give you an example. So this is how Lambda functions can drastically improve the readability of a code. So let's say that I want to create a function in the way that I have done as of now. So I want to create a function called multiply. So I can do it using multiply, def multiply x comma y, and then I return x multiplied by y. But if since you can see it's a very simple line of code, I can simply just do r will be the variable that will be pointing to the lambda. Lambda will accept x and y as parameters and will return x multiplied by y. Now to call the lambda, all I have to do is use the r, which is the name of the lambda, and I put parentheses in outside, and inside the parentheses I pass in the two statements. If I don't put a parenthesis, then it would simply be a variable that holds something. I'm not calling the function, I'm not executing the code that's inside it. So I pass into N3 and I get 36.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now, another thing that Lambda does really well is that it allows you to remember some things. So let's say that I have created a function called def my function. I pass in a number named n. This number now will be remembered by the lambda that I have created inside that function forever. So if I return a lambda in which I will accept another parameter called a, and what it will do is it will take that number and add n to it. This way I can create multiple functions that do the same task but where the value of n is different. And this is very trivial example, by the way, very mundane, but you can think how far you can take it. There are many great Python programmers who use lambdas in very clever way to write code that's very readable, quite simple, quite easy to understand once you understand what lambdas are, and it's quite comprehensive. Take a look at a function that's so simple to understand. So take a look at that as well. Now let's take a look at some functions, and we'll implement some functions in Python. Again, we have the same setup. Here we'll define a function. So let's say that I have some task that I want to perform. Okay, and it has several steps, and all of these steps will need to be performed regardless of where I execute the task. This example will also show you the importance of functions. So let's say that I want to download file, okay, and URL. Now I'm not going to actually download the file, but I'll just print the steps. So establish connection. Then these are the typical connection steps you need to perform when you're trying to download a file from the internet. Open the connection, download data, close connection. So now if I want to download anything, any file, let me just print the URL. Or another thing I'd like to show you is that you can add strings or concatenate strings. So this way. So if I do this, then it will print establish space connection space and then add whatever URL is right at the end of it. Open connection, and let me print the URL, download data, and close connection. All right. So if I were to call this function, download file, and let's say that the URL is ftp : www.abc.org. Now if I were to run this, let me just run this here, it's going to perform these tasks. But the major advantage of using a function is, now if I want to perform the same task over some other place, I can copy and paste it into different files and it will do the same thing over and over again. So if I were to print this, as you can see, it's done everything for me. Let's say that I want to change the URL, df ijk, and if I run this, it's downloaded it for all different purposes. But now let's say that I want to change something in this step. After downloading it, I want to log it to some place. Let's say I want to make sure that this is recorded in a database that I had downloaded this file. So log to db, and this is the URL I downloaded it from. Now if I run this, as you can see, this change, let me just so I've added 2 lines. So this is what it looks like. Now it looks a bit clear. Let me clear the screen and run this again so that you can see. And it's downloaded it, but as you can see that this step is now added to all 3 of the files. This is the advantage of using a function. So whenever you want to make a change to some particular step, some particular well-defined process, you can just make a change in one place, and everywhere that process is being performed, those changes will be reflected there. So if I had to add something else to the download file procedure, this will be executed by all the functions or all the files that are calling the download file function that I have just described. So that's one advantage. And now let's take a look at returning some data, right? So let's say x comma y. I get in 2 data and I perform some task. Now I want to return x multiplied by y. Let me call it, again this is a very trivial example, multiply, right? And if I want to multiply two numbers, multiply x and y. Now x and y are going to be numbers, so let's say 15 and 10 comma 15. Now if I were to run this, 150 would be the expected answer. If I were to run 25, 250 would be expected answer. So we have gotten both of them. But one thing to notice is that it's a really simple function. So defining it like this is going to take a lot of time and it's really unnecessary. So one way you can change it is you can write it like this. Let me just show you the code that was earlier there. And I am just going to change it. So multiply equals to a lambda that will take in x and y and return x multiplied by y. Run this again, and this is performing the same tasks that we had performed earlier, and it's printing the same thing that we had printed earlier. So there's no change in functionality, but we have changed the implementation. So what is the advantage? Now this function I can send as an argument to any other function. This is where it gets a little difficult to understand. So let's say that I want to print. Let's say that I want to, one thing I can do is def create multiplier, and it will give me x and y will be given to me on the time of execution. So now what I can do, I can return a lambda that will take y as a function and it will return x multiplied by y. So let me just delete this. Now this works, and now I will create multiply, create multiply 10, and now I will just pass in 15 and 25. I run this and I get the same answer. Now as I've already told you that this is a function that you can pass into another function. Let's say I create another function named execute, takes in a function and takes in an argument, and all it does is that return calling that function with that argument. So execute 15 would be the other argument, and multiply, and we want to execute. If I run this again, it's doing the same thing, but it's doing it for me. Now I can make changes to it. I can basically log the calls to a console called f with and okay, I've gotten an error. Yeah, I need to convert it to a string. Now it works. So it called f with 15 and it called f with 25. So I can log this to a database to make sure that it's being executed correctly and so on. Taking a look at what are data structures. So a data structure is a particular way of organizing and storing data in a system's memory so that it can be used efficiently for some purpose. A good example of this would be and arranging data is a very important aspect of any programming language. Some kind of arrangement of data might be better suited for one purpose than other purposes. To give you a more concrete example, if I were to give you a few numbers, let's say from 1 to 10, let's say I were to give you 10 numbers of any, I were to give you 10 numbers and those 10 numbers were given on a card. All of those cards were placed face down in front of you and you had the option of arranging them in any way possible by looking at their value. Then I would ask you to check for a particular number to be existing in one of the cards. So if I were to say, okay, check whether 10 exists in one of those cards, what you could do is, if you had arranged them all in a linear fashion in a random order, you can just take a look at each card and see whether or not it contains the number 10. So that's easier for you to do for 10 numbers, but let's say that the scale increases and now you need to do that for 100 numbers, for 1000 numbers, for million numbers, and for even billion numbers. That is going to be really time consuming. On the other hand, if you had stored it in a different way, let's say that you had stored it in a way in which when you get the data, what you do is you first take one card, see if it is what the number of the card is, place it someplace, then take the other card and see whether or not it's smaller or larger than the card you had previously taken. If it's smaller, you put it on its left hand side a little below, and if the card is larger, then you put it on the right hand side, and you keep doing it again and again and again. This forms kind of a tree like structure in which a card is at the top, all the numbers smaller than the card is on the left hand side, all the numbers larger than the number on the top is on this right hand side, and this rule is followed for all the cards. So if you have many cards, this will be followed for all of them. Then I can come along and say, for the 10 million numbers that I have given you, tell me if the number 15 is in those. What you can do is take a look at the card right at the top. If the card at the top is larger than 15, which means 15 is smaller than the card at the top, you look at the left portion of the structure that we have created. On the other hand, if it's larger, then you look at the right portion, and you keep repeating the step. Each step is going to cut down half of the tree for you, so you don't have to worry about that. So this is what's called a tree data structure in essence, and this is specifically called a binary search tree. And the technique we're using inside it is called a binary search algorithm. Basically, if you have data that is sorted in a particular order, you have the ability to look at the data that's right in the middle of the deck, figure out what the number is. If the number you are looking for is smaller than the number, then you have to discard everything that comes after that card, the middle card that you have chosen. If it's larger than the number, then discard this and everything that comes before it. And you keep doing it again and again and again, and you will eventually get to the card that you choose in a very few number of steps. In fact, the number of steps is different from linear to logarithmic scale. So it's quite different. So this is one of the ways that storing data in a particular way can help you. Similarly, you can, if you wish to grade a few papers, you can store them in a stack. That's easier for you to deal with. And if you're trying to manage a few people getting through and doing things in an orderly fashion, you can store them in a queue. Similar concepts are carried over to data structures as well.
Let's start with creating the threads. Now you guys know what is thread and what is the purpose of it, why do we need it, and all you guys got an idea. Thread is nothing but a task. Now let's create a task. So in computer programming, a thread refers to a small lightweight processes performing a certain task. And the life cycle of the thread includes the major states: start, execute, and stop. I have not created any PPT or something like that. I have added the descriptions here itself as activity 1, and here will be doing the code. So you can just refer here itself. So threads in Python can be created using the construction of a thread class in the threading module. So this is a syntax for creating a thread. So threading dot thread. So this is a syntax. Inside the target will be the function name. So we will be creating many functions. For which function you are creating a thread, so that name needs to be given here. And then the argument. So this is optional. If your function takes any input, you can pass this input to the arguments here. If it doesn't take any input, no need of giving the arguments. It is optional. Okay, so this is the syntax for creating a thread. So that is what it's given here. Function name is the name of function executed by the thread, and parameter tuple is the collection of input parameters required by the target function, that is function name. So the parameter tuple collection is passed in the form of a tuple. Let's import the module first and create a new thread. Okay, first let's import threading. It's imported. Now, just look into the syntax for the thread class. The constructor given here in this activity. Yeah. So it requires a target function and the arguments. The target function is the task that is performed by the thread. So the function can be anything, like an addition function or recursive function like a factorial, any functions. You guys have already worked on functions concept. So in real time, these functions are a different application and their subparts, like opening multiple tabs in a browser, or writing in a document, or an antivirus program executing in the backend. So these things and all can be the parts. So now let us create a square function to observe the thread behavior.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
See, square of 32 is 1024. 10 tens are 100. So this is how now I have created one function here. Now let's create a new thread using the function square as a target. Okay, the same syntax we saw there already. So let me name my thread as thread underscore 1. I'm naming my thread as thread underscore 1. Threading dot thread. So it should be the target. Target is my function name. So square. Square is my function name. So here I'm not giving the parenthesis, you need to observe. So probably you would have learned when you're learning the Python basics. When you're using the apply function, you would have learned the apply function. In apply function also, it takes function name as an input. So there you don't give the brackets. Usually if it is a function, you just give the brackets, parenthesis, right? So when it is taking input as function name itself directly, no need to give the brackets. So here we have one more parameter called arguments. Args equals. So you can give any number. And not anything. So as I told you already, we are passing tuple as an input. It's taking tuple as an input over here. So you know already the tuple concept. If you give comma, it considers you are inserting only one value here. It considered that it is a tuple value. So if I run the code, so now my thread 1 is assigned to function square. So if you call thread 1, if you just check, you will understand how to check. It is as I have assigned my square function to my thread 1. This thread will not execute unless we start the thread. We need to start it, execute it, and end it. So let's start this thread. The syntax is thread underscore object dot start. So once the thread starts running, it will run independently till the target function will complete. So thread underscore 1 dot start. Yeah, see, if I just give thread 1 dot start, I get an output square of 10 is because I have assigned the square function to my thread 1. So if you call the thread 1 in the backend, it is executing. So there is an output given by the target function. Like sometimes when starting the thread, there is no output. This is because there is already another thread executing in the program and the program is not free. So let's use the print current threads function of the threading module to check the name of current thread that is getting executed. Let's print the name of the current thread using. So this is a syntax threading dot current thread. Current thread is nothing but currently what it is executing. So this will be the current thread executing. So my current thread name is main thread. What is this main thread? It is currently executing. The main thread is executed. The main thread class allows applications to run code on the main thread of execution. So it's nothing but the current thread is nothing but the main thread only. And to determine if a particular block of code is currently running on the main thread. So now I just check my current thread which is executing, that is main thread. So now let's understand what is this main and how do we start and how do we stop it and all. Now let's understand multitasking. So now till now we just created only one thread and we worked with the one single thread. So now let's understand multi-threading, multitasking. So it is the ability to perform multiple threads simultaneously. So this means if a function sum of numbers is executing, then simultaneously another function, let's say decimal to binary, can also execute at the same time concurrently. So this is the ability of the processor which saves time and thus increases the performance. Now let's create two iterative functions and two threads to observe whether they are executing simultaneously or not. To observe multi-threading, we need to follow a few steps here. First, we need to create a function which takes a number num as an input to calculate the sum of number from 1 to the output using the loop. And then we need to create a function called decimal to binary. So which takes number as input and it will convert it to its binary notation and stores the digit in a list. And then we create thread 1 with the target as sum of numbers and give name equals thread 1. And then we create thread 2 with target as decimal to binary and give name as thread 2. And finally, we will execute both the threads using start and check the current thread that is executing. Now let's create two functions and understand. Okay, create two target function and threads to observe the multi-threading. So first let me create a sum of numbers, def sum of numbers takes num as an input. We set initial value to 0. Then for I in range 1 comma sum equals I plus I plus. So let me explain again what I'm doing it here quickly. So first we are creating a function sum of numbers. It takes a number as an input. You can give any number. So here in my case, I have passed a number as 5. Initially, my sum will be 0 here. For I in range of 1 comma 5. Initially, my I will be 1 and sum is 0. So sum equals 1 plus 0. It is 1. So the sum of num, it will be printed. I mean, after this complete iteration, it will just print here. So the sum of 5 numbers is 10. So it keeps incrementing in the for loop until we complete this range, whatever you have given. So sum of 5, the sum of 5 numbers is 10. So the sum will be 10. So format string is one concept, and it is getting advanced than format also. We can use the f string also, f string. So you need to use f at the starting. So the sum of num, usually how we used to print if you're not using this f string, it would be like sum of comma num comma numbers. This is how you do, right? Numbers is comma sum. So instead of doing that, this is called as placeholders. The brackets what I'm giving, the dictionary concept is called as placeholders. So this is how we usually print it. If I want the sum of 5, the num value it will take, numbers is, and then the sum value. Even this gives me the same output. There is no change. See, the sum of, oh, it didn't print. Num is my variable. Oh, no, see, sum is the range, num is the input, what we are passing it to my function. So here, while passing the values, I'm giving like threading one target sum of numbers, arguments. Okay, I'm passing my arguments as a tuple over here. So it should be in the same format only. So that's the reason we have used the dictionary format. Yeah. So we are using the f string in order to fetch it. This is called as placeholders. So this value will automatically fetch it from here. I'm just passing as an argument as 5 to my function. So that value will automatically fetches, and it will here in this placeholder also the value will be fetched. And is sum. Some value will also be fetched and will be printed in the sum. See, current, the sum of 5 numbers is 10. Current thread name is this. Binary equivalent of 5 is this. Current thread name is this. I'm formatting my string. So if in general, if you just use the print statement, it won't be in this format. Current thread, see, there is no new line after the current thread name. So this is called as f string, and it supports like in whichever you might use the PyCharm or the Jupyter Notebook, whichever it is. I haven't tried with Jupyter Notebook. Yeah, I think so. It will work. It is almost the same, right? Google Colab and Jupyter, it will work. So printf, the sum of num, this is called as placeholder. The value is fetched and printed here, and the numbers is sum. So I got it as 10. If I pass the sum of numbers of 10, 5 is 10. So then decimal to binary. We are converting whatever the decimal value, whatever the value we give, we are converting it to a binary numbers. So initially I'm setting n equals the num, whatever the num we are passing it as 5, it would be n as 5, and I'm creating an empty list over here. Later I'll be appending the values into my empty list. While number is not equal to 0, the number whatever we have passed there 5, if that 5 is not equal to 0, I'm taking the quotient. So this is called as floor division. Hope you guys, few might come across or few might not know about this. Floor division, this is called as floor division. Floor division is nothing but like round off. I can tell as round off. If you have like 49.999, it's nothing but 50. So that 50 would be assigned to the quotient. That's just an example I have told, but in our case, num is 5, right? 5/2. It's nothing but floor division. Whatever you get the number equivalent, it will round off, and that value is assigned to my quotient. Because we want the binary numbers, right? You can't take the decimal value. So we use floor division in that case. Then my remainder. Remainder equals num modulus 2. This is called as a modulus symbol. So it would just be a revision. Even if it is simple, I'm explaining it to you guys so that it would be a revision for you how it works exactly. So num is 5. 5 modulus 2. Modulus is nothing but it gives me the remainder. So 2 divided by 2. So remainder is 0. Right? Remainder, whatever you get in the remainder, that will be the modulus here. And then the binary digits dot append. Binary digits is nothing but my empty list which I have created here. I'm appending the values to my empty list because I have a list, right? It's not only a single number. As in sum of numbers, I got only 10 as an output. But in my binary digits case, it's not like that. I have few binary digits like 0, 1, 1, 1, 0, 0. You know the binary digits concept. So I'm appending my remainder to my binary digits in empty list. And then num equals quotient. So num would be nothing but my quotient will be become the new dividend now. Quotient is 0. If I take an example, if it is 0, 0 would be my new dividend. And then I'm reversing. The binary digits needs to get reversed after that. So the binary equivalent of n would be 5. 5 is, I'll be getting the values as 101. In the thread 1, threading dot thread is a syntax, as I told. Sum of numbers we are passing here, and the input as 5, I'm passing it over here, and the name will be thread 1. For thread 2, name would be thread 2. One extra parameter I've given here is name. Then I'm starting my thread 1 as well as thread 2. Thread 1 dot start, print current thread name is threading current thread dot name. Threading dot current thread dot name. I'm printing both the threads. So the output is, if you observe, both are main thread only. If you observe, it is not even thread 1 and it is not even thread 2. Why it is the current thread name is main thread? So you need to observe that always the current thread that is running will be the main thread by default. Current thread, whatever it is executing, main thread. Main thread in the sense it is an application. Okay, so it is which executes always in the backend application. So this is because the target functions are not complex and is executed within few milliseconds. It might be the sum of numbers or this binary. It is executing within a milliseconds. Thus, the program is executing the thread 1 and thread 2 very quickly, and immediately it will switch back to the main thread. And so it is showing here as main thread. Okay, when we print, so when we are printing here threading dot current thread, so it is displaying as the main thread. It is executed after executing thread 1, and current thread will become the main thread. So first thread 1 is executed, thread 2 executed, and then the current thread will become the main thread. So it is very quickly it is getting executed. So that's the reason it is showing as main thread. So yeah, to observe multi-threading, we need to introduce a delay in the target function. So I want to understand where is how my threading thread 1 and thread 2 are getting executed. I want it to get delayed. I want it to display my output. At what time is it getting executed? And after how many seconds it is getting executed, and quickly at when it is shifting back to the main thread. I need to understand all those things in detail. If I want to understand these concepts, we need to introduce a delay in the target function using the sleep function. We have a function called sleep. I'll make my function to sleep for a few seconds, and then my next function should execute. And then again, it should come back to the same function after the sleep time, and then it should print the output. So it takes, and from the time module we are doing it, you guys would have learned the daytime modules and all in the basics. So it takes the number of seconds function that needs to be displayed as an input. So this will make the current thread associated with the function to wait for a few seconds and allows the program to be free to start another thread. So we also need to join the threads here with the main thread using the join function of the thread class. In layman terms, the join function will let the main thread or program know about the sequence of threads that are either ready to start or already executing. So time dot sleep number of seconds. You can give the number of seconds. How many seconds it should be in the sleep state. And after that, in this way, when the current thread executing is waiting, the program can start the execution of another thread which is sequenced after the current thread. So syntax to join, I'll be joining with my main thread. So we have, as of now, we have thread 1 and thread 2. I'm joining those threads to my main thread. So now let's modify the functions by delaying them in the loop for 3 seconds. And then let's print the current thread inside the functions. Okay, for this, first we need to import time, because as we are using the sleep function, import time. We copy the same sum of numbers. So by default, it takes seconds as an input. So whatever the number you give, it will be within the seconds. So while passing the number, be careful. Before it, let me print the current thread also. So at each iteration, we'll understand which thread is it executing. Yes. So now let's try to understand this. As you can observe from this output, when we introduce sleep, after starting the thread, it will attach to another thread that is available because of the join function. Here we are joining it. That joins both the threads to the main thread. So here in the first iteration, as we have passed already, I have given my number as 6. So initially I will be 1. 1 plus 0, it would be 1. So the current thread name it is executing here is thread 1 because it is in the sum of numbers. So current thread name is main thread, because why it is even showing as main thread? I'm joining it. I'm joining my thread 1 and thread 2, and these threads will get joined to the main thread. Okay, so the sum of by default it is showing a sum of 6 numbers. I have gone wrong somewhere. It should be sum of one number initially. So let me explain this. So initially my sum of 1 it will be there because I'm giving the range as 1, 6. Number 6, I'm passing input as a 6 for that. So initially my I will be 1. 1 plus 0, it would be 1. My sum is 1 now. Current thread name will be thread 1. It should be thread 1 because already I have assigned thread 1 to the sum of numbers function. So it should be thread 1. Then the sum of I numbers is sum. So sum of 1 numbers is 1. And then it will go to sleep. See in the output, if you observe in the first output, current thread name is 1. Sum of 1 numbers is 1. It will go to sleep. Now it is going to sleep, and then I'm printing my thread name. See, it is the main thread. So that thread is stopped working. The for loop with the first iteration, it is stopped for 10 seconds. And automatically it will go back to the main thread because I'm joining here. Once it goes to sleep, it will come back to the decimal binary function. So for 10 seconds, this is idle. So it will come to the next function, that is decimal to binary. So here it will work with the first loop. So with the first number, it will work. It will print the thread name, and again this will go to the sleep for 10 seconds. So the current thread, once it goes to sleep, it would be main thread because I'm using the join condition here because I'm attaching my thread 1 to join and thread 2 to join. Next, it will go for the next thread iteration. So that is for binary. It will go for the binary. So binary digit so far it would be 0 initially. Current thread name is 2 and it would be 0. And when it goes back, again now the 10 seconds is elapsed, right? It will go back to the thread 1 again. Once it is going back to the thread 1, again it will iterate for the next iteration. That is sum of 2 numbers is 3. Then the current number thread will again go to the sleep for 10 seconds. Again it will go for the decimal to binary digits. So see, again current thread name is thread 2. So the next iteration is executed in thread 2, that is 0 and 1. Again it will go to sleep, it will go back to the thread 1. So current thread name thread 2, you have binary sum of binary digits so far as 0, 1, 1 here. So why we are getting the output for sum of 2 numbers is fine. Then you are getting the current thread name as thread 2 and binary digits as 0 and 1. Then it will again go to the after 0 and 1. Again it is printing as current thread name as thread 1. Why it is printing like this? Current thread name is thread 2 here. It is 0 and binary digits so far. It is 0 and 1. And then again it should go to the thread 2 only, but not the thread 1. Thread 2 only, then it should be 0, 1, 1. And then current thread name should be 1. Okay, somewhere we are missing the statements. Let me make it clear again. If you observe, every time I run the code, the output will change. Because it depends on the time it gets executed. Because as of now, we are setting the time as 10 seconds. So when that thread is executed in the 10 seconds, and again automatically it will be assigned to the main thread, and then we'll go back to the thread 2. It will get executed and again it will come back. See, if you observe here, now my output is different. I didn't make any changes to my code. Now my output is different. As how I got previously, now I don't. I didn't get it. So see the thread 1, it's not like sequentially thread 1, thread 2, main thread. It's not that sequence. It should get executed. It depends. So my current thread would be thread 1 initially. See, then the current thread name, it is going to the main thread here. See, that is what we are doing here. Current thread name is thread 1. So by the time it comes to the sum of I numbers as sum, so automatically after this thread, in the span of seconds, it is just occupying the main thread is getting occupied here. This gets executed so quickly, and automatically main thread is executed, and then the sum of one numbers is 1, and then it is going to sleep. See, after sum of one numbers is 1, it is going to sleep for 10 seconds. By default, it will go to the thread 2. So in my thread 2 binary digit, so far it is 0. Then current thread name would be thread 1. Again, it is going back to thread 1. Sum of two numbers is 3. Then again, next it will go to the thread 2 again. And then again thread 1. And again thread 2. And again thread 1. See, the sum of four numbers is 10. Simultaneously, after this, it is just automatically going. The wait time matters. So it will be waiting for 10 seconds. But the time it gets executed the next thread, right? Automatically, if it finish early, automatically it will go back to the thread 1, it will get executed and it will print the output over here. So if you see here, current thread name is thread 1. Sum of four numbers is 10. So I got the binary equivalent already. Binary equivalent of 6 is 110. And then the current thread name is thread 1. So the sum of 5 numbers is 15. Sum of 6 numbers is 50. So I have passed here as 6 for my range, 1,6. And the binary, decimal to binary also 6. I have passed as a tuple for both the things as an input. So the sum of 5 numbers is 15, sum of 6 numbers is 15. In the thread 1 only, it simultaneously just got executed with both the numbers. And then the last current thread name would be main thread. So if you observe in the output, when we introduce the sleep after starting the thread, it attaches to another thread that is available because of the join function, because we are joining it, right? So simultaneously in between, if it finds few seconds as free, it will occupy that space and it will get executed. So that is nothing but the main application. I can tell the main thread. See, I'll give you the general example of phone. In the main application, you're in the call and even you want to browse something. You want to get some information regarding the Python. So when you're in the call, you'll just turn on the speaker. So the main application, as you call it, is just executing the main application in the backend. Again, you're going to the internet. You're just browsing something, the details regarding Python. And after that, you are just going to the calculator. You're performing some calculations. Like simultaneously, you're executing many things. So multiple tasks are running behind. But the main, what is your main task? It's like you're in the call. You're in the call and that is executing always. So simultaneously, it is executing. Your call, it's not getting disconnected as you're using the calculator or you're browsing something. It is getting executed simultaneously. So we are joining the function that joins both the threads to the main thread. So my main thread is my call. Simultaneously, I'm adding the calculator and the Google Chrome. I'm joining to my main thread. It joins to the main thread. So this means the threads can execute concurrently using the multitasking. So here the sleep function, what will it do? It will keep in the wait state. That's it. So it will keep in the waiting state and then it will proceed further. Bit confusing. Just try to understand the mobile example which I gave you just now. What will be your main thread and what will be your thread 1 and thread 2? Thread 1 will be my calculator. Thread 2 will be my Google Chrome. So thread 1 and calculator and Google Chrome, I'm joining it to my phone. I mean, phone in the sense to the call. So that is how multi-threading will work.
Right, let's take a look at what is a linked list. So a linked list is a linear data structure. Now, a linear data structure basically means that data inside this data structure is stored in a linear fashion. Linearity basically means that there is an order. One data point comes after the next data point, and that comes after the next data point. So this is how linear data structures work. The most common and famous example of a linear data structure is an array or a list in Python. If you have used other languages such as Java and C++, then you are using arrays, and those have linear data. Those are linear data structures as well. So each element or node in a linked list, and node is a term that we use to define a particular data point in our data structure, which is linked list. So node contains two things or two pieces of information, the value that we want it to hold and a reference or a pointer to the next element. Now that pointer could point to the next element if there is one. If there is no next element, it points to none in Python. None basically refers to an absence of value. So this piece of information comes in handy, which we will take a look at when we're implementing the linked list. So as you can see that a linked list we use node. Now node is one way to refer to what we are describing. You can use other terminologies such as elements or any other thing. But node is what the community has settled down on. That's the keyword here. And it uses reference or pointer for the next element. Now the reason why we're using the word reference and pointer is because depending on the language you call them different things. In Java and in Python you use reference, which basically means you ask for the address of an object in memory and it will be given to you by the runtime environment. On the other hand, in languages where you get to manipulate the raw internal memory of a system, such as C++ and other languages, you can use pointers. Pointers also allow you to do arithmetic on the addresses, where you can add a few things and get the next address. But that's not possible in references. In any case, you can implement these data structures in any language that you desire. Whether it's Python, whether it's Java, whether it's C++, whether it's any other language, you can use them in all of those. Right?
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let's take a look at the benefits of using linked list. So a linked list, using a linked list has several benefits. The first one is that it is dynamically sized. A dynamically sized linked list basically means that it is a list in which you can add as much data as you can or as many nodes as you want to, as long as there is space in memory for you. Now you might be wondering that that's also the case with arrays or lists in Python, and we'll get to that in a moment. But since lists are also dynamically sized, there is one tiny bit of problem with lists that we'll discuss later on. But the important aspect is that they are dynamically sized. Now, similar concept to list in Java and C++ and other statically typed languages is arrays. Arrays are not dynamically sized. They cannot be sized dynamically. They only have one type, and you cannot add more data to it after a certain point. You have to define the capacity of an array when you're declaring it and when you're instantiating it. In C++ and Java, if you have created an array that can hold 10 memory items, you can't add 11th one. That would be considered an illegal operation and that would cause your program to crash. Just know what the error is and how you can use linked list to solve those errors. Arrays are not bad. They are used for specific purposes, and if you want to only store 10 memories, then using a linked list is just an overkill. So understand the problem and then use it. In any case, linked list can be dynamically sized. It allows for faster insertion operations. So let's compare it to other data structures such as arrays, as that's the only one we know right now. In an array, let's say we have 1,000,000 elements, and I want to add something right at the beginning of the array. Even though it might be dynamically sized, what I would have to do is firstly grow the size of the array. So from 1,000,000, it should now be able to store 101,000,001 element. Then I have to shift all the elements one place back. So the element that was at the uh, uh, that was at the millionth place now needs to go to the million and first place, and that way we need to shift all the elements available, and then all I have to do is rewrite the element that is the zeroth index at the beginning. Similarly, if I had to do the same thing for any other place in my array, such as the 10th index, 15th index, 17th index, I would have to do the same kind of process. Just I would have to stop at the 10th index and not go till the end. Now that's useful, but as you can see, it's quite inefficient. I just want to add one element at the beginning. That's not what I want to do. So in linked list, you can do it quite easily. Since in linked list, all you have to do is just create a pointer, point its next pointer or reference, store the next reference to the beginning of the list, and point the pointer that's pointing at the beginning of the list to the current pointer. It might look sound very typical, but don't worry, we'll take a look at that in the demo. So you don't have to worry about that. That's the way it works. So this is why insertions are much faster in linked lists. This is why linked lists are preferred in situations where we have data that is being dynamically added. So we need to figure out where we want to add it and how we can do that. Next, let's take a look at faster deletion. So again, it's the same problem. If I wish to delete 10 elements from my array at random points and I want to shrink the array, now I have to firstly remove one element, shrink the array from the back, then do the same thing again and again and again. That is also quite inefficient. In linked list, all I have to do is just make sure that there are no dangling pointers. That means that if I'm removing an array or I'm removing a node, I just want to make sure that the node that is occurring previous to the current node and the node that is occurring next to the next node are connected to each other. That's the only thing that I need to take care of. Other than that, we just have to remove the data. The rest all will be managed by the garbage collector, or it's something that I would have to take care of on my own. Now, again, depending on how you are implementing these structures, you can implement them in several different ways, but it generally leads to a faster deletion time. Then comes memory utilization. Now, many data structures need contiguous blocks of memory. In linked list, you don't need continuous blocks of memory. So, for instance, if I want to store 10 million data points or 10 million nodes of linked list, I just need to find 10 million small patches of memory where I can store my linked list items, and the rest I can just point to the memory address of the next element in each of the node, and it will work just fine. On the other hand, the memory utilization is not going to be great in arrays, because in arrays we have a lot of we need to have contiguous blocks of memory. This is how arrays are implemented underneath the hood. This is also why we need to define a fixed size right at the beginning, because it's more efficient that way. So when we have an array and we want 10 million data points, what we need to do is we need to firstly find out a block of memory in which I can store 10 million data points, and assign that block of memory, that block of contiguous memory, to my program, so that it can add 10 million arrays, 10 million indexes inside my arrays, inside my memory. Now, that's easier for us to do, but it causes a lot of overhead on our memory's part, because let's say that there are few patches of memory that can store 2 million, 4 million, and 4 million again. Now, for our memory to be able to be used by arrays, our computer or our operating system would have to defragment the memory, which basically means just rearrange the memory in such a way that all the empty space is patched at the bottom, so we can easily use this again. That takes a lot of time and could hang our computer and could lead to degradation in our computer's performance and speed. So let's take a look at how we can fix something like this. So we use linked list for that. But before that, let's take a look at lists versus linked lists. So what is the difference between a list and a linked list? List is a Python programming construct. So when we're talking about list, we're talking about the native Python implementation of a list. And a linked list is going to be something that we will be implementing in a few moments time. So in Python, we already have a built-in data structure named list, but it is a little different than linked list. So although it might seem that the internal implementation of Python's list might be the same as linked list, mainly because we are using dynamically sized linear data structures. There's some key differences. A list is stored as a contiguous block of memory, while a linked list is stored as a bunch of nodes scattered around memory connected to each other. So if you want to store some small pieces of data, then you can use lists. But if you are going to store a large bunch of data and you need to be able to dynamically size it and want to add and remove data continuously from it, then you can use, instead of using list, you can use linked list. Linked list is much more efficient for that purpose. You can use lists for that as well, but the memory consumption is going to be high and it's going to lead a degradation of performance. So it's up to you which one you use. You just need to understand how to use or in which situation to use which one. Both these are tools. Understanding which tool to use when is going to be really going to be the key to building good software. So now let's take a look at the types of linked list. So there are many types of linked list. Since linked list is a very versatile language, we are going to mention only three of the most used types of linked list, but you can use other kinds of linked list as well. The first one is singly linked list. In a singly linked list, we only share a single reference to the next one. So basically what it means is that we have a data point that contains, or a node that contains some data and reference to the next element. If I go to the next element, I can't go back to the previous element. There is no dual connection. It's just a single line of traversal. So this is what a singly linked list is. Then comes doubly linked list. In a doubly linked list, we have both pointer to go from current to the next node and from the current to the previous node. So that way we can traverse both front and back in our data structure. So these are two different kinds of data structures. And then there's circular linked list, in which the last element of my node is going to point to the first element, so that we have a circular linked list. Instead of storing it in a linear fashion in which we have the beginning and the end, we have, instead of having a beginning and the end, we have a circular structure. Now all of these can be used for their own purposes. In single linked list, we use data structures to implement a single data point. These are called nodes. The main important aspect that is different from singly and doubly is the memory usage. The memory usage of doubly linked list is going to be significantly more because it's storing three pieces of information, not two. Whereas in singly linked list, you're only going to be storing the data and the reference to the next element or next node. So that's the thing. Now, another thing is that they are used in different things. So singly linked list can be used in the back and forth feature. It can be used to develop stacks, which can be used to develop the forward and backward features in web browser. So when you visit a browser, then you go forward, then you go backward, then you go to another address, then you go backward, and then you go forward. All of this is implemented by singly linked list, and it's quite easy to do it with doubly linked list. In singly linked list, it's a little difficult, but it could be done if you do it using stacks. On the other hand, in doubly linked list, you can perform many different kinds of things as well. And circular linked list can be used for developing caches, something that is called LRU, or least recently used cache. And that's one of the most important implementations of circular linked list. So you can use it that way. And you can implement circular linked list using singly and doubly linked list, which basically means using a single link or double links. Double links means something that points to both the current next node and the previous node as well. So you can use that way as well. Now let's take a look at a demo of implementing linked list in Python. So as promised, I have a Jupyter notebook, and here I'm going to implement the linked list. So you don't have to worry about how I'm going to do it. Just follow along with the code. If you have Jupyter notebook with you, you can do it quite easily. So Jupyter notebook is not really necessary in this case. You can also write the code inside a simple Python file and then run it. I'm using Jupyter notebook because it's easier for me to show how things are being implemented. Since we need a node, the first thing I'm going to do is implement a node. So just create a class, call it node. That node class needs to have a constructor. In Python, a constructor is called an initializing method. Call it self. In the self method, inside the self, after the self keyword, I need some data and the next pointer, next, should be pointing to null. As you can see in Jupyter Notebook, this is highlighted as green because next is a keyword in Python. In case you don't wish to use the next keyword, you can use something else, some other keyword that makes sense. I'm going to use it here. It doesn't really make much difference here, but you can use it for something else as well. And by default, it's none. So if there is no other point that is given to us, it's going to be next. So now all I have to do is just give it some data. And also I can use the data to be none as well. So it just doesn't contain any data. And now self dot data is equals to data, and self dot next is equals to next, and that is done. So that's our node class. This is what is going to contain a single data point. If I run this, I don't see any error. If I were to create a new data, let's call it n1, and I don't do anything, press n1 dot data, run it, doesn't print anything. If I press n1 dot next, doesn't print anything. On the other hand, if I were to pass in 1, and if I were to print n1 dot data, it contains 1. And if I were to pass in as the next element a new node with the value of 2, this is 1, n1 dot next would give me the address, and I want the data here, and that's no. And I can do the same thing again and again. So here after this I can do it node 3. This is what it looks like, and I can go to the next element, and it's this. So it's quite easy to use it that way. But we want to do it in a little more efficient manner. So all I can do is I can implement it using a linked list. Now inside the linked list, I don't need to inherit it from any other class. Here I am initializing it, and all I need is self. So self, and you can call it anything. Many people call it start, I call it head. So head is going to be the element that is pointing at the beginning of our list. If head is null, which means there is no beginning, that means our list is empty. And if your head is not none, that means that there is some element at the beginning. How many elements are there? That can only be determined by going through the entire list. But we know that there is something at the beginning. That's all we want to know. So with that, we have created the initializer or the constructor function. Now comes the meat of our application. Here we have to implement the insert function or the insert method, since it's inside a class. First parameter is self, second parameter is data. Now comes the interesting aspect. So what we do is we create the new node here. So it contains the data, and the next pointer is going to be pointing to nothing. Now it is up to you how you want to implement it. What many people do is that they create two separate functions: insert front and insert back. Now this depends on how you want to implement it. I want to keep this simple, so I'm just going to call it insert. Insert front and insert back basically mean I want to insert some data at the beginning of my list, and insert back would mean insert some data at the end of my list. Depending on how you wish to implement it, both are valid reasons. Just understand why you want to implement it at the front or at the back. Now, all I want to check is if, not if self.head is not null. Now, I could simply just do this, if self.head. That would lead to the same thing, but I want to be more explicit here. So basically means if there is some value in the head, the head is pointing to, that means our list is initialized and there are some elements already there, and I want to put it at the end. All I have to do is I have to current is equals to self dot head while current dot next is not none. So all I'm checking is, so I'm going to go to the next element till I don't reach the end. So right at the beginning of the end, which I'll show you, current is equals to current dot next. So what I'm doing is, let's say that I have a list in which I have one that point to 2, that point to 3. Let me just make it a little easier to read. Now what happens is I take a look at the head. Head is going to be pointing to 1. From here, I take a look at the head and I understand that there are elements here. So I assign this to current, which is here, and then I keep checking, does it have any next element? It does. So I go to the next point, which is here, current is equal to current dot next. Then I check if there's some element after it. There is. So I go there. Then I check if there's some element after it. There is not. So current is currently pointing to the end of the list, right? So after reaching there, all I want to do is current dot next is equals to new node. So let's say the new node is 4. Now current dot next is going to be equal to 4. In actuality, it's going to be pointing to none here. So I'm checking if the next element is not none, then move ahead. It is none, so I'm going to go to 4, and its next element is none. And now we're done. So this is how this is working. We have inserted an element when there is no element present inside our, when there is some element present inside our list. But what if there is no element? Well, then we can just basically do it this way. Self dot head is equals to new node, and we're done. I'll have to add an else clause here, and we're done. So we have created the insert function. Now insertion is fine, but what if you want to print the list? That is where we come here. So def print list, and I don't need any argument other than self current is equals to self dot head, and while current is not none, all I have to do is print current dot data. Okay, so this is done. Now all I have to do here is create a linked list, which I can call it anything. I'll call it list, or for simplicity's sake, I'll just call it L. Linked list. I have created an object of linked list, which means this code ran completely, this portion of it. Now I have to insert some data here. So L dot insert 1, that works. 2, that works. 3, that works as well. So as you can see, I didn't have to define a particular size. The size is being automatically generated for me. It's automatically being increased in its size. Now, if I print the list, as you can see that it is going on uninterrupted, right? That's a problem. So let me just call cell dot, and this is a problem that we're going to see in a moment. Restart and clear output is going to be the one. This is also one of the reasons why I chose Jupyter Notebook. And now let's take a look at why this failed. And the reason is quite simple, because we have not moved ahead in our list. What happened is, after we print the data, we want current is equals to current dot next. This is a mistake that many of us make many times. What's happening is printing the current data, and we're going to the next value, and we're checking, okay, now am I pointing to nothing? If not, then that means there is some data left to be displayed. So I'll just rerun it again from the start. Linked list, insert, and print. And as you can see, it's being printed correctly. Now, if I want to print it entirely on one line, I can just, and now it's done. So this is what it looks like. As you can see, it's not really difficult to implement. It's basically 15 lines of code, creating, insertion, and printing. You can also delete the nodes. There's many different articles and different ways of doing it. And now I'd like to show you how you can implement a doubly linked list. So we'll implement it from scratch again so that it gets settled in your memory. To implementing a doubly linked list, you have to implement it the same way you implemented singly linked list. Firstly, you have to create a node that's going to be a little different from the singly linked list node, and I'll show you why. Hopefully you remember why, but let me just show you anyway. So we need self, then we need data, which could be none. Then we need the next pointer, which is by default none. And then finally, we need a previous pointer, which is going to be equal to none as well. And this is the crucial bit of difference. We didn't have this earlier. So now all I have to do is just self dot data is equals to data, and do the same thing here. Self dot next, and self dot previous is equals to previous. Run this. This is working. Now let's just check if it's working correctly before moving ahead. Node data is 1. Okay. Okay, so I print n dot data. This is what it prints. Now I want something to be before and after this, right? So I can just do it this way. Node 1, node 2 is going to be this. Or we can do it this way. We can create 3 nodes. 2 and 3. N1, N2, and N3. So N1 dot next is going to be N2. So right now what we have done is this. We have created 3 nodes, N1, which is 1, which is pointing to 1, N2, which is pointing to 2, and N3, which is pointing to 3. Now what we want to do is, we want to convert it to this. N3 plus N2 should also be pointing backwards, and N3 should also be pointing backwards. This is the whole reason why we do doubly linked list. So n1 should have a reference to the n2. n2 dot previous should have a reference to n1. So this could be done. Then n2 next should be n3, and n3 dot previous is equals to n2. If I do this now, if I were to print n1 dot data, prints 1. If I were to print n1 dot next dot data, I have an invalid syntax error here, n3. Now if I were to do it, if I want to go a step back, I can just do previous, it should print 2. And again, I try to go previous, it should print 1. That's how that looks like. Now if I were to do this, here's if I want to implement a doubly linked list, all I have to do is type class doubly linked list, def init, we pass in self, and that's about it. What we need to pass in, the implementation is going to be quite similar. It's just going to be one piece of difference, which I will highlight. By default, it's not pointing to anything, so it is working. Def insert. To insert something, what we need is the reference to self and some data. So all we have to do, if self.head is not none, which means that there is some value in self.head, then all we have to do is, firstly we have to create a new node as we had done earlier with the data. And now if there are some values, first we have to get to the end of the data. So current is equals to self.head, while current dot next is not none, current is equals to current dot next, and we keep doing that. Once we reach till the end, we make current dot next to be equal to new node, and now comes the new bit. New node dot previous is equals to current. So what happens is, let me just visualize it for you. As we had done earlier, let me just use this. So we have the first node, which is head. It is pointing to 1, let's say, which is pointing to 2, which is also pointing backwards, right? And now we are here.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
The next of 2 is pointing to none thus far. We create a new element, which is 3. So we go here, we remove it with 3, and we create the previous pointer to be pointing to 2. This is what we're doing, right? So it's easy to understand, and this is, we can do it very easily. But if there is no element, then basically all we have to do is self.head equals to new node. Quite simply the same code that we had earlier. And similarly, all we have to do is call the print list function, pass in self, while, and also we can current is equals to self.head, and just check if current is not none. We print current.data, and we go to current next pointer. Run this. We have run into an error, which is if self.head is not none. We are running into an error in line number 7. So it's here. Let's see what is the issue. Is not none, not in, not none. That is the issue. So now we have come up with the issue. Now let's create a new node. Let's call it L again, and I'll call it W linked list. Don't need to pass anything. L dot insert 1. Now we want to insert 2. Now we want to insert 3. And now all I have to do is go through the entire thing as we had done earlier. So L dot head dot data, L dot head dot next dot data, L dot head dot next dot previous. So we go one step forward and then one step backwards. Should print 1, which it does. Next dot data 3, previous dot data, and should 2. So as you can see, we have a way to move forward as well as backwards here as well. So that's what W linked list is. You can do other things as well. Deleting items here is going to be a little tricky. So just make sure that you have access to the previous and the next nodes. And that way you can take the previous node's next pointer, point it to the current element's next node. And the next element's previous node should be pointed to current element's previous node. And then you can just remove the data that you have. It's very easy to do, quite easy to do in many ways. So we're done here.
So what are these operators? Well, these are some specific characters which have a specific task to perform. And based on the function and the task, the operators are further segregated into 7 different types of operators. Arithmetic operator, assignment operator, comparison operator, logical operator, bitwise, identity, and membership operator. Fine. So let me discuss them one by one. So starting with arithmetic operator. Well, arithmetic operators are the one which is used to perform some arithmetic calculation. So what it does, it takes 2 operand to perform operation on them. For example, 2 plus 3. So here 2 and 3 are operand, and the character plus over here is nothing but arithmetic operator. Alright. So there are other arithmetic operators too, like plus, minus, multiplication, division, mod. All these characters are a part of arithmetic operator. Let me just show you one more example. Like 1 plus 2. So here 1 and 2 are the operand, and plus here is a arithmetic operator. 1 minus 2. Again minus is a arithmetic operator. 2 mod 1. Mod is what? Arithmetic operator. Alright, let's move ahead. Next we have is the assignment operator. Well, this assignment operator is used to assign a value to a variable. The character which comes under this operator are equal to, plus equal to, minus equal to, multiplication equal to, and etc. For example, you declare a variable as var equal 10. So this equal to is your assignment operator and is used to assign value to a variable. Let's get back to our Jupyter notebook and learn more about it. So, for example, I'm defining a variable var equal 10. So this equal to is nothing but an assignment operator. Var plus equal 10, again an assignment operator. But what does this mean? So what does this mean? Well, it means that var equal var plus 10. Alright. So if you print the value of var, what do you think the output should be? Well, you'll get the output as 20. Since the value of var is already 10, so 10 plus 10, it's 20. So the updated value of var is 20. Similarly, you can perform var minus equal to 10 and again get your value printed. So again, the updated value of var would be 20 minus 10, 10. So this plus equal to or minus equal to, it is generally named as a shorthand, which means add or subtract and assign value to self. Alright.
Same example is mentioned over here, like a equal 10, a multiply equal to 10. So it means that a equal 10 into 10. When you print a, you'll get the output as 100. Alright. So next we have is comparison operator. Well, it is used to compare two values and it returns true or false as the output. Alright. The operators which are a part of it are less than, greater than, less than equal to, greater than equal to, or not equal to. For example, let's see what example we have up here. A equal 10, B equal 20. A is greater than B. Obviously 10 is not greater than 20, right? So it is giving me false as the output. Alright, fine. So let's move ahead. Next is the logical operator. Well, these logical operators are used to perform some logical calculation. And the operators or the keywords which are a part of it are and, or, and not. For example, we have a equal 10 is less than 10 and 2 is greater than minus 1. Then print a. So you are getting output as false. Okay, let's jump back to our Jupyter notebook and see why we are getting the output as false. So you had a equal 10 is less than 10 and 2 is greater than minus 1. So if you see, we have two comparison operator up here. So what is the value of 10 less than 10? Since it is a comparison operator, so it will give me a false, right? 10 is not less than 10. And 2 is greater than minus 1. This is true. So you can summarize this as false and true. Alright. So since it's false and true, therefore it equals to false. Well, how? Well, do you remember the binary calculation that you have learned in your college? It's like 1.1 equal 1 or 1.0 equals 0 or 1 and 1 equal 1 or 1 and 0 is 0. So consider true as 1 and false as 0. So false and true is false. Alright, that's why you got the result as false. Now if you print the value of a, you'll get the output as false. Alright, so next we have is the bitwise operator. So this operator is used to perform the bitwise calculation. This operator includes and, or, left shift, right shift, not. Alright, so let's see their use one by one. Let's see the example what we have up here. So we have 7 or 5, the output is 7. 7 and 5, the output is 5. So how do you think we are getting this output? Let's see the calculation. So how it is calculated. So if you convert 7 into its binary form, it's 111. And if you convert 5 into its binary form, it's 101. Now if you are performing OR, so basically you are performing a binary addition on it. And if you are performing an AND, you are performing a binary multiplication on it. Alright, so let's see. So if you are performing a binary addition on it, so 1 plus 1 is 1. 1 plus 0 is again 1. And again 1 plus 1 is 1. So that's why you are getting the OR of 7 and 5 as 7. Even you can verify this using the calculator. Open a calculator. Yeah, it's a programmer calculator. So 7 or 5. So you'll get the output as 7. That's correct. Fine. Next operator that we have got up here is tilde operator or the not operator. Well, this operator is used to perform a not operation. So what is not of 7? What is not of 7? It's minus 8, right? How it is minus 8? Let me just show you using a notepad. Let's open notepad. Okay. So 7 in its binary form with 4 bits, what it is? 0, 1, 1, 1. Alright, if you perform a not of 7, that is not of 7, what you will get? All the bits would be switched. Like 0 would be converted to 1, again 1 to 0, again 1 to 0. So you'll get 1000 and automatically a negative sign would be added at the beginning. So you'll get minus 1000 in binary form, which you convert into decimal, you'll get it as minus of 8. Alright. That's why the output of not of 7 is minus 8. Fine. Next is the left shift and right shift operator. Let's see what is the output first. For example, I'm trying for a right shift. Then 10 right shift 2. What is the output? It's 2. Let's see how we got the output as 2. Open our notepad. Let's remove this. So 10 in its binary form, what it is? It's 1010. Alright. Well, when you're performing the right shift, you're telling the interpreter that you want to shift your bits toward right. And how many bits you want to shift is basically 2, since you have mentioned 10 right shift 2. Alright. So 1010 shifted 2 bits to the right, 00, and remove 10 from the end. Alright. So this is how you are shifting 2 bits towards the right. So you got the result as 0010.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now if you convert this into decimal form, you'll get the output as 2. Fine. So it's like you're trying to push 2 bits from the left towards the right. Is it clear? Alright, fine. Let's move ahead. Next we have is 10 left shift 2. What is the output? It's 40. Let's see how we got that output. Again, 10 in its binary form is 1010. So when you're performing a left shift, it's like pushing the bits from right towards the left. So 10 left shift 2 is like 1010, and you're adding 2 bits in the end, since you are shifting 2 bits to the left. So you're getting 101000. So let's convert this into its decimal form. So 101000 in its decimal form is what? 40. So that is why you're getting the result as 40. So there's a shortcut trick. Well, the shortcut trick is that just add zeros equal to the number of bits that you want to shift towards the left. Alright. For example, I want to perform 10 left shift 3. So my output should be 101 triple 0 and one more 0. Alright. Since I'm moving 3 zeros. Alright. Since I'm moving 3 zeros towards the left. So let's convert it. So it's 80. So you are getting the output as 80. Let's verify it again. Well, if you perform 10 left shift 3, you'll get the output as 80. Fine. Well, I hope the bitwise operator is clear to you guys. Well, in case you have slightest doubt, please add your doubt to the comment section below and we'll try to reply them at the earliest. For now, we can just move ahead to the identity operator. Well, these operators are used to test if two operands shares an identity. The operators which are a part of it are is and is not. These are basically two keywords. Alright? For example, what we have up here, x equal 10, x is 10, it's true. Or x equal 10, x is not 10, it's false. Alright? It is just used to test if the operand shares an identity or not. Alright? So next and the final operator in Python is the membership operator. Well, this operator is used to test whether a value is a member of a sequence or not. The sequence may be a list, it can be a string, or it can be a tuple. I know some of you guys might be thinking, what is this list or what is this tuple? And guys, I'd say that just be patient. I'll teach you about them in detail during this session. For now, you can just understand that this list is almost same as array, which you had already studied in C, C++ or Java. It's almost same as that. Alright? And this membership operator, it is used when you want to check if a certain element is present in a list or not. So let's see what are the operators which are a part of it. So well, we have in and not in keywords which are a part of this membership operator. Alright, let's see an example. So what's the example up here? So we have defined a list, or you can say we have defined an array, which consists of dog, cat, and wolf. So we are checking for lion and pets. Since pet is the name of a list or an array, you can say. So we are searching for lion and pet. So since there is no lion in it, so the result is false. Next, what we are doing, we are seeing for wolf and pets. So yeah, wolf is present in pet. So we are getting output as true. Alright. So this was all about the Python token. So moving on ahead, we'll learn about data type in Python. Well, Python has majorly two data types: immutable data type and mutable data type. Immutable are the one which cannot be changed or modified, and mutables are the one which can be changed. Alright? Immutable data type consists of numbers, strings, and tuples. On the other hand, mutable data type, they consist of lists, dictionaries, and sets. Alright? So let's discuss about them one by one, starting with numbers. So under the topic of numeric literal, I have already discussed that Python has four different types of numeric literals: integer, long integer, floating number, and complex number. Well, I have also told you that you don't need to specify the data type of a variable while you are declaring it. Remember, Python would automatically convert a number from one type to another if it needs. Fine. Don't worry if you want to explicitly convert one data type to another. You can do it using int function, long function, float function, or complex function. Alright. You have that option available with you. For now, let's just move ahead and see how we can find the data type of a variable. Let's see. Suppose I'm declaring an integer variable a equal 10. Let's define a name. As Jill. Now, what if I want to check the data type of these variables? So how can I do that? So for that, we have type function. So print the type of variable A. Alright? Or print the type of variable name. Or print the type of variable salary. Fine. Execute it. Sorry, there's a typo. It's type. Alright. So you can see that variable A is of type integer, variable name is of type string, and variable salary is of type float. Fine. Alright. Let's get back to our tutorial. So this was about the numbers. Next is strings. Well, anything which is written under the single or double quotes is treated as a string. Alright, let's perform some operations on string and understand them in detail. Suppose I have first string as hello world, and my second string is Intellipaat. Alright. Now, what if I want to print first character from the string 1 and the last character from string 2? So how will I do that? Let's see. So what you can do, print str1 and I need the first character. So my first character is at index number 0. I'll just mention str1 of 0. And I want the last character from string 2, right? So print str2. So if you want the last character, just specify -1. Execute it. So you got the output as capital H and small t. Since capital H is the first character from string 1 and small t is the last character from string 2. Alright. So now what if I need to extract hello from hello world? So how will I do that? What I need to do? Extract hello from hello world. So all you need to do is print from which string? String 1. Hello, starting from 0, and it should end till 0, 1, 2, 3, 4. It should end till 5. Alright. And execute it. So you'll get the output as hello. Fine. This is how you can collect the substring from a string. One thing to remember is that if you check the index number of hello, so it would end at 0, 1, 2, 3, 4, 4, right? So when you want a substring, so you have to mention it as +1. So 4 plus 1 is 5. So 0 till 5. It won't include the fifth position. Generally, if you are extracting a substring, the last number which you are including, that thing is not included. It means that everything which would be between 0 and less than 5 would come as the substring. Alright, let's perform some operations on it. So first we have is the find function. So what are these find function? Well, this find function returns the position of the string. Let's take an example. For example, I have a string as str equal attachment. And what I need to do, I want to find the position of the substring me from it. So str.find, and inside that just mention what you want to find. Like I want to find the position of me. Let's execute it. So you got the output as 6. Why? Since me starts from 6. 0, 1, 2, 3, 4, 5, and it's on 6th position. So that's why you got the position as 6. Next is replace. Well, this replace function is used to replace one character or string with other. Fine. It's like, what if I want to replace this me with m? So str.replace. What I want to replace? First mention that I want to replace me. With what I want to replace? It's m. Fine. Execute it. So you got the output as attachment. attachmnt. Fine. me is replaced with m. One more thing that you can do up here is, let me just show you. You can convert the word attachment into attach. Let's see how. Attach.replace. So what you need to replace from here is ment. You don't want ment from here. So what should you replace it with? You can replace it with space. That's it. If you execute it, you'll get the word attach. What if I don't mention the space up here? So you'll get the output as attach. Even that work. Alright? Fine. Next we have is the split function. Well, this function is used to create split on the base of a character. For example, I have a split string which consists of word 1, comma, word 2, comma, word 3. So all these 3 different words are separated by comma. So what I want to do, I want to split the entire string on the base of comma. So I'll write split str dot split on the base of comma and execute it. So as you can see, I got the output as 3 different words. Word 1, word 2 and word 3. Let's move ahead. Next is the count function. Well, count function returns the count of the character in the string. For example, let's take a string as str3 equals Intellipaat. Now I want to find the count of letter I from this particular string. So str3 dot count, I'll mention I. Let's execute it. So what do you think the output should be? INTELLIPAAT. So do you think it should be 2? Well, according to me, it will be 1. I'll tell you why. See, the output is 1. Because well, remember I told you Python is case sensitive, so both the uppercase and lower cases are treated differently. So if I'm searching for small I, that small I is just appearing once. So I got the count of small I as 1. Now, what if I convert this string to uppercase? Dot u dot upper. Let's convert it to uppercase. Okay, that's it. str3 dot upper. So it gave me Intellipaat. Let's store it in some variable like str4 equal str3 dot upper. Fine. Now if you count the number of i's in str4, you'll get the output as 2. Why? Since in capital Intellipaat you have 2 i's. Alright? Fine. So we discussed about the upper, which converts the character string to the uppercase. Fine. Next is the max or min function. Well, these functions are used to return the max or min ASCII values. For example, let's take a string 5 as anything. For example, exclamation mark, at the rate, hash, 123, capital A, small b, small a, c, capital C. Alright. So this is my string 5. Now I want to find the maximum ASCII value from it. So what I'll do, I'll just write max str5. Execute it. I must to mention this. Put it under the quotes. Execute it. So the character with maximum ASCII value is small c. Alright? Or what if I want to find the minimum ASCII value from string 5? Let's check for that. So minimum ASCII value in string 5 is of exclamation mark. Fine.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So, well, next we have is the tuple. Tuple are a group of values within the parentheses, and since they are immutable data type, so the values within the tuples cannot be changed. For example, we have defined a tuple up here as my group equal A, B, C and D. Alright. So this is the example of a tuple. So let's move ahead and perform some operations on it to understand it in detail. Let's get back to our Jupyter notebook. Let's define a tuple as my tuple equal within the parentheses. I'll mention A, then B, then C and D. Alright, so this is my tuple. So the very first function that we are going to perform on it is concatenation. So what are these concatenation? It is used to add two strings or character. Alright. Basically concatenation is used to add two or more tuples. Alright. For example, I'll define another tuple as my tuple 1 equal E and F. So if I need to concatenate it, I'll just write my tuple plus equal my tuple 1. And let's print it. Print my tuple. Let's see the output. You got an error as invalid syntax. What is the invalid syntax up here? Something is invalid here. Let's define it again. Okay, the semicolon is missing up here. Fine. Executed. So yeah. So this concatenated me and gave me the result as A, B, C, D, E, and F. So this is how concatenation is done in tuple. Concatenation. Next we have is the repetition. Repetition is used to duplicate the string or character for a given number of times. For example, what if I want to double the contents in my tuple? So I'll just write my tuple multiplied by 2. And again, that's it. My tuple multiplied by 2 and hit enter. So you'll get the output as double values of A, B, C, D, E, and F. Fine. So this is how a repetition is done in a tuple. So let's move ahead. Next function that we need to perform is indexing. Indexing shows the index position of a character or a string within the group or within the tuple. For example, I want to find what character is present at the index number 1. So I'll just write my tuple of 1. So at first index, B is present over there. It's like A is present as 0th index, B at 1, C at 2, D at 3, and so on. Fine. So this is how indexing is done in tuple. Next is slicing. Slicing shows a specific set of index character or string. Fine. For example, I want a specific set of strings which lies between the index number 1 to 4. So my tuple, I want a specific set of string which lies between 1 to 4. So this is my 0th, 1, 2, 3, and 4. Fine. So I'll get the output as B, C, D, and E. Let's check it. So I got the output as B, C, D, and E. Fine. Alright. So let's move ahead. So next we have is the list. List is a sequence of mutable Python data type which is defined within the square brackets. And now since they are mutable, they can be easily changed. Let's move ahead and perform some operations on it and understand it in detail. So what is an example? Okay. So we define a list as A, 10, 7.12 and data. So it is consisting of mixed data type values. It even has an integer, a float and a string. Fine. Let's get back to our notebook and define a list. So this is my list. My list equal within parentheses a string, a number, a decimal, and a string with multiple character. Fine. So this is my list. Now let's see what are the operations that we need to perform on it. First is concatenation. Well, again the concatenation is same as the one which we learned in tuple. It is used to add two or more lists together. Let's define another list as my list 2. My list 2 consists of element as, let's take Python, or it consists of an integer. Now what if I want to concatenate my list with my list 2? So what I'll do, my list plus equal my list 2. Let's see what is the result. Let's print the value of my list. So you got the result as A123 3.14 John Python 20 Python 20. So you got this result 2 times because yeah, I executed it twice. It's my fault. So what you can do, you can just mylist dot remove. Hold on, I don't want to execute this entire list of statement, so I'll define it under different block. So my list dot remove Python. Okay, I have misspelled Python as okay. Remove this. Again, remove this. And remove 20 and again remove 20. If you again remove it, you'll get an error. Fine. So let's see what we have currently in my list. Let's print it. Okay. Let's get back up here and execute it just once. Okay. So as you can see, my list got updated with Python and 20. Fine. Next is repetition. Well, repetition is again same as tuple. It is used to duplicate your list with n number of times. Well, next is repetition. It is used to multiply your list by n number of time. For example, my list into 2 would duplicate your list with each element appearing twice in the list. Alright? Fine. Next is slicing. Again, same as tuple, if you want a specific portion of a list, we can just mention the starting index number and the ending index number plus 1, and it would return us the sliced list. Alright. For example, as you can see here on the screen, we have my list, and inside that we have A1 3.14 and Python, and we want a sublist from 1 to 4th index number, like 1 2 3 0 1 2 3 plus 1. 4th won't be included, so we'll get the output as 1 3.4 and 3.14 and Python. Alright. Next is append. Well, appending is adding any value to a list. It's almost same as the function what we did up here. Right. It's like my list dot append and add any values with which you want to append. Like I want to append with 10 and print my list. That's it. So as you can see, we got 10 in the end. Fine. So moving on ahead, next we have is extend. Well, again, extend is another function which is used to concatenate two different string. Alright. Example, I'll define my list 3 as C and D, and I want to append my list with my list 3. Let's print and see what result do we get. So as you can see up here, C and D got added with my list. Fine. Well, next is insert. Well, using the index number, you can specify any value in between the list. For example, I want to insert a number before 3.14. So I'll write my list dot insert. I'll mention the index number. My index number is 0, 1. I want it after 1. And what value I want? For example, I want to insert a 20, 30. Alright. Let's print my list and see what is the result. You cannot use a string up here. You just have to mention the number, index number. So yeah, you got my list at first position. So what if I want to insert it before 3.14? That was my target, right? Now your updated string is this 0, 1, 2, 3. So you want to insert it at third position and you want to insert 40. So at third position, that is 0, 1, 2, 3. So after 1, 2, 3, 40 would come. So after 1, 2, 3, 40 is up here. Alright. So this is how you can insert any number at a given index number. So this was all about list. I hope you understood the difference between list and a tuple. If not, let me just summarize it again. A tuple is immutable while a list is mutable. Open and close brackets are used when you are grouping items under it. And in the case of list, square brackets are used. Fine. So this was all about the list. So let's move ahead and discuss about dictionaries. Well, these are more flexible data type in Python. And you define a group within the curly braces. Fine. While defining the elements in a dictionary, you have two elements, key and its value. Fine. Or in other words, we can say that we define an index for each element. Let's explore various operations that we can perform using dictionary. So first one is defining an empty dictionary. Don't mention anything within the curly braces. That would be an empty dictionary. Alright. Next is integer keys. That is dictionary with integer keys. For example, 1 apple, 2 ball. So the key 1 and 2 are just integer, right? So it's a dictionary with integer keys. Next is mixed keys. Dictionary with mixed keys. That is, we have key of mixed data type. For example, name is string up here, 1 is integer, right? So this is mixed key. Next we have is pairing. That is from sequence having each item as a pair. Dictionary, 1 apple, 2 ball, all are taken as a pair element. Fine. Next is accessing dictionary. So what if I want to access a dictionary? So I can directly access using the key. Fine. For example, the word 1 is associated with key 1 and word 2 is associated with key 2. So if I want to access word 1, I can directly write my dictionary of 1 and it will give me output as word 1. Fine. Let's move ahead. Now what if I want to find the length of the dictionary? Then I can directly do it using the len function. Len of my dictionary is giving me the output as 2. Why? Since it consists of two elements, word 1 and word 2. Fine. Next is key. Now what if I want to find the key of my dictionary? So I can just use the key function. My dictionary.key. It is returning me all the keys within the dictionary. Fine. It is returning me all the key defined within the dictionary. Next is value. Well, this function is used to return all the values defined within the dictionary. For example, we have apple and ball as value within this dictionary, my dict. Alright, so that's why using value function, we got the output as apple and ball. Fine. Let's move ahead. Okay, so now that you have learned about dictionary, so let's discuss about the last data type, that is set. Sets are the unordered collection of items within the curly braces. That is, items are defined within the opening and the closing curly braces, and you don't have to define the key value in it. It is basically unordered collection of items. If you are adding elements in the set, then make sure that every element in the set is unique. For example, you can define a set as my set equal 1 to 3. Well, it's almost similar to as dictionary, right? But it does not has any key value associated to it. It's the only difference between a set and a dictionary. Alright? Let's perform some of the function using set and understand it in a better way. So the first one is creating set. You already created a set. Alright. Next is union. Well, union of two sets return the common value from both the set. For example, my set S1 equal 1, 2 and C. My set S2 consists of 1, B and C. So if I am performing a union on it, so it is returning me with 1, 2, C and B. So basically what it is doing, it is returning me the common values of both the set. Fine. Next is the intersection. Well, intersection is used to return the common result from both of them. That is AND of my set S1 and my set S2. So what are the common elements in both of them? We have 1 2C, 1 BC. So we have 1 and C common in both the set. So we got the output as 1 and C. Fine. Next is the difference. Well, this difference would omit all the common value from both the set, and it will return the only value which is a unique in first set. For example, we have 1 2C in set 1 and 1 BC in set 2. So if you subtract it, so you have 1 in both the set, so it will emit it. 2 and B, so nothing can be done about it. C and C, again it will emit it. Now since only 2 is left in set 1, so you get the output as 2. Alright. So this was all about the data type in Python. So now that your base is clear, let's have a quiz. So what would be the output of the following code? Test1 equal Python programming and print test1 from 2 to 6. In order to know the correct result, do post your answer in the comment section below. Alright, so let's move ahead. Next is the Python flow control. Well, these flow controls are the one which control the flow of execution of your program. So we have 6 different types of flow control in Python: if else, nested if else, for, while, break and continue. Let's discuss them one by one, starting with if else. So what is this if else? Let's see its syntax. If the condition is true, then execute statement 1, else execute statement 2. It's as simple as that. Then execute statement 3. Let's check the flow control of it. Start, check for condition 1. That is, if condition 1 is true. So if condition 1 is true, then the statement executed with the if block is executed. That is, execute block 1. If first condition is false, then go and check for the second condition. That is, else if condition. Now if else if condition is true, then your second block would be executed. If none of them are true, then finally the else block would be executed. That is, execute block 3. And yeah, remember one thing, there is no condition associated with a else block. Else block would only execute if all the above conditions are false. Fine? Alright. Next is the for. Let's see the syntax. For iterating variable in sequence, colon execute statement. Let's check. Well, it's the example of a program. Like start, we are defining a variable as count equals 0. Then execute statement. Then increment the value of count by 1. And then check the condition if count is less than 10. Is 1 less than 10? Yeah, the condition is true. So again repeat it and again execute the statement, again increment the value of count by 1, that is count become 2, and again check if 2 is less than 3, and so on. Continue this till 10 is less than 10, and when this thing arrives that 10 is less than 10, your condition become false and you exit the loop. So this is how a for loop works. Let's understand this in a better way with an example. So this is our code. Alright, we have defined a list fruits as apple, banana and cherry. For x in fruits, x in fruit of 0 is apple. Then print x. X is what? Apple. So apple would be printed as the output. Now again, what we'll do? We'll again go back and check for x in fruits. Now x of 1 is banana. Then print x. X is what? Banana. So it would print as banana. Again, it will go back. X and fruit of 2 is what? Cherry. Print x. Cherry would be printed. Now if it goes back, there's nothing left in the fruit. So nothing would be printed. Alright. So you got the final output as apple, banana and cherry. Fine. Alright. So let's move ahead. Next is the while. The syntax for this is while condition is true, then execute set of statement under the while. Start, check for the condition. If it is true, then execute block 1 and then again repeat the loop until the condition is true. In case the condition is false, then just exit the loop. Let's understand this better with an example. This is my code. Like a equal 1. In variable part I got a equal 1. While a is less than 5. Is a equal 1 less than 5? Yeah, condition is true. Then what? Print the value of a. Alright, so we got the output as 1. After getting the output, increase the value of a by 2. So a plus equal to 2. That is 1 plus 2 equal 3. Now again go back to the loop. Check for the condition. Is 3 less than 5? Condition is true. Then again go to the print a part. What is a? 3. So print a. So you will get the output as 3. Again increment the value of a to 2. That is a equal 5. Now check the condition. Is 5 less than 5? No. I think here we got the condition as false. So we got the final output as 1 and 3. Alright. Let's move ahead. Here's another example. A equal 1. In the variable part a equal 1. Check the condition. While a is less than 3. Is 1 less than 3? Yeah, condition is true. Inside the while part, the first condition that we check, if a mod 2 equal 0. Is 1 mod 2 equal 0? No, the condition is false. So we'll jump to the else part. So we'll jump to the else part and print a is odd. Now since the value of a currently is 1, so 1 is odd. Fine. Then what we'll do, we'll increment the value of a by 1. That is 1 plus 1 equal 2. Fine. Now again we'll go back to the while part. Now we'll check if 2 is less than 3. Yeah, the condition is true. Fine. Now what we'll do, we'll jump to the if part and check if 2 mod 2 equal 0. Yeah, the condition is true. So this time we'll check if 2 mod 2 equal 0. So yeah, the condition is true. So what it will do, it will print the if part statement. That is a is even. A in this case was 2. So 2 is even. Fine. So this is our output. Next, again it will go and increment the value of a by 1. So now 2 becomes 3. Again it will go back to the while part. Is 3 less than 3? The condition is false. So your final output is 1 is odd and 2 is even. Fine. So this was about the while statement. Let's move ahead and learn about break. So this break statement, it is used to break the loop at a certain condition. Alright. Let's understand this with the help of this flowchart. Start it, check the condition. If the condition is true, then check the break condition. If the break condition is false, then only execute block 1 and repeat the loop. If the break condition comes to be true, then break the entire loop and then exit the loop. Alright. Let's check it with an example up here. For example, a equal 10. While a is greater than 0, check for if a is not equal to 5. If a is not equal to 5, then print a. Else break it. Fine. Let's execute it. Sorry. Just manage. A minus.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So we got the output as 9, 8, 7 and 6. Fine. So the moment loop becomes 5, we got exited out of the loop. Next we have is the continue statement. Well, the continue statement won't break the loop. So it will just skip the statement in case the condition is true. Let's understand this with the help of this flowchart. So start, check for condition 1. If it is true, then check for continue condition. If it is false, then execute block and repeat. Then in case if the condition is true, then stop executing that particular block for that particular loop and cut for that particular iteration, and again go back and repeat and check the condition. Alright, let me just show you. Let's just replace this break with continue and let's see what is the result. So yeah, see, got the output as 9, 8, 7, 6, 4, 3, 2, 1, but you didn't got 5 up here, right? Why? So as I told you, this 5 was skipped. Fine.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this was all about the flow control. So let's proceed and learn about function. So what are these functions? Well, a function is a block of organized reusable set of instructions that is used to perform some related action. But why do you even need a function? Well, what if you have to write a program in which you have to use same set of code again and again? For example, you wrote a code of 20 lines or 40 lines, and those 40 lines of code are coming in your main program at 10 different places. And you have to use those 40 lines of code 10 different times in the program. So I don't think that none of you would be interested in writing the same lines of code again and again. So in order to resolve this issue, they created function. So well, this function is a block where you write your code which you think you might use it again at some point of time. Therefore, it allows the reusability of the code and thus minimizes the redundancy. In Python, there are basically two types of function. The first one is the user-defined and the second is built-in function. Let's see them one by one. So what is a user-defined function? Well, any function defined by user is a user-defined function, right? Syntax. It starts with the keyword def. After that, an identifier for a function name, and then you pass the arguments into it. Alright, followed by semicolon, and after that you mention the set of statement inside it. Alright, let's see an example. For example, if you want to add two arguments, so you define a function as add, and inside add you pass two parameters as a and b. So sum equal a plus b and return sum. That's it. So it's as simple as, let me just define a user defined function for you. It's like it starts with the keyword def. After that I'll write a function name as add. Inside that I'll pass two arguments, a and b, semicolon, and this function should return me the sum of a and b. Alright, fine. So this is my user defined function. Next is the built-in function. Now these built-in functions are a predefined set of functions in Python. We have abs function, which returns the absolute value of a number. We have all function, which returns true if all items in an iterable objects are true. We have any function, ASCII function, ben function, bool function, and many other built-in functions are available there in Python. If you want more information about it, you can just check out the Python official doc. Alright. Now that we have defined a function, now let's see how we can call a function. So calling a function, well, there are two ways of calling a function. You can either call it by passing a value or by passing a reference. Let's see them one by one. So first is pass by value. Calling a function by passing the value. For example, a equal 10. Def, that is keyword. So we are defining the function as print the value of b is b. And again inside the function we are updating the value of b to be 100. And print the new value of b is b. And then what we are doing? Change it and we are passing a. Now since the value of a was 10, so this function would take the value of b as 10. So print value of b is 10 and new value of b is 100. Let me just show you how to resolve this issue. Let's define the value as a equal 10. Define my function. Inside that I'll pass an argument as b. Print the value of b is b. You have to concat. Fine. And next we'll update the value of b to be 100 and again print the new value of b is b. Fine. So this is my function. Now what I'll do, I'll call my function by passing a value. Calling a function by passing a value to it. So I'll write my function and inside that I'll pass the value as a. Since the value of a was 10, let's see the output. See, so we got the output as the value of b is 10 and the new value of b is 100. So this was about calling a function by passing a value to it. Next we have is pass by reference. Calling a function by passing the reference. For example, so we have a list as c, 10, 20, 30. So we are defining a function as change them and we are passing an argument d to it. Inside the function we have print value of d is d. D of 0, it's a numeric constant. We are defining it as 99. D of 1 as 98. Then print the value of d is d. Then change them. Now when we are calling a function by passing the reference, so what we are doing, we are just passing the entire list to it. So what will get the output? We'll get the output as value of d is 10, 20 and 30. And the new value of d is 99, 98 and 30. Let me just show you with an example. C equal 10, 20, 30, right? Now let's define my function 2 inside this D is what? Print the value of D is D. Alright. Next we'll define some numeric literals like D of 0 is equal to 99. D of 1 equals 98. And then print the new value of D is again D. Fine. This is my function. Now if I call my function using pass by reference, so my function 2, and I pass the value C into it. So let's see what we get the output. So we got the output as the value of D is 10, 20, 30 and the new value of D is 99, 98 and 30. Fine. Let's move ahead. Well, when a parameter is passed by reference, the caller and the callee uses the same variable for the parameter. Well, if the callee modifies the parameter variable, the effect is visible to the caller's variable. But when a parameter is passed by value, the caller and callee have two independent variables with the same value. If the callee modifies the parameter variable, the effect is not visible to the caller. Well, the things that you need to note in this definition are, well, the variable word here means the caller variable itself. That is, if I pass a local variable by reference and assign to it, it will assign the caller's variable itself. Do you know what is the meaning of reference and pass by reference? Well, it is different from the general term reference. It is that this reference is temporary and implicit. What the callee basically get is a variable that is somehow the same as the original one. Here on the screen is a very good example of pass by reference and pass by value. Alright. In pass by reference, you are filling a cup using the reference of the cup, and in pass by value, you are actually filling the cup using some values. So this was all about how you can define a function and how you can call it in Python. Now let's discuss about the lambda function in Python. So what is this lambda function? Well, a lambda function is a small anonymous function. Lambda function can take any number of arguments but can only have one expression. Note the fact that lambda function cannot have more than one expression. So here's the syntax. Lambda argument colon expression. For example, we have x equal lambda a colon a plus 10 and print x of 5. So what it is basically doing, it's defining a lambda function that adds 10 to the number passed in as an argument and then print the result. Let me just show you in our Jupyter notebook. Let's define a lambda function as x equal lambda of a such that a plus 10 and then print x. Inside that will pass the value of 5. So what do you think the output should be? 5 plus 10, it would be 15. Alright. If you change 5 to 10, the output would be 20. Alright. Let's move ahead. So next is function versus lambda function. So what we are doing up here, we are comparing function with a lambda function. So here's a normal function which takes two arguments and return the multiplication result of both of them. And here is a lambda function for the same. It's like r equal lambda x comma y such that x multiplied by y, and if you call r 12 3, what it will do, it will return the result of 12 multiplied by 3, that is 36. I'll just show you this in our Jupyter notebook. For example, I'm defining a function as def. Let's name my function as multi. I'll pass two arguments up here, x and y, colon. Now return me the product of x and y. That's it. It's done, right? Now, what if I have to define a lambda function for this? So I'll write like z equal lambda of x comma y such that it equals to x multiplied by y. Fine. Now if I want to test this, I'll write print z of, I'll pass two values in it, 12 comma 3. So it should return me as 36, right? So yeah, I got the output as 36. Fine. Let's move ahead. Next is the power of lambda function. Well, the power of lambda function is better shown when you use them as an anonymous function inside another function. For example, let's say you have a function definition that takes one argument and that argument will be multiplied with an unknown number, right? For example, you have my function as n returns lambda a such that a plus n. So you are defining a variable my sum equal my function of 3. For example, let's see in our Jupyter notebook, define my function and we'll pass an argument as n such that it should return lambda of a such that a multiplied by n. Alright. Now you can use this function definition to make another function that always doubles the number you send in. For example, I can write double me equal my function. I want to double it. So my function of 2. I need to multiply it with 2. Now print what number do I need to multiply? So double me for, I want the double of 12. So double me 12, the output would be 24. So if you want to triple it, just change it to 3, your output would be 36. And so on. Alright. So this was all about the lambda function. Fine. Next we have is Python classes and object. So what is a class and object in Python? Well, Python is an object-oriented programming language and almost everything in Python is an object with its properties and method. And a class, it's like a blueprint for creating objects. Let's see an example of a class. We define a class as class space class name colon and inside that you define its objects. If you want to call an object, let's see how you call it. You're defining a variable as obj1 and you are assigning all the object of my class to it. And if you want to print one of the variable of my class, so you can access it using obj1. Alright. So this was about the classes and object in Python. So coming to our last topic of file handling in Python. Well, file handling is a very important of any web application. Well, you have 4 different features which you can perform in a file handling. You can open, read, write and delete a file using Python. Alright, let's see them one by one. The first one being open. So you can use open function to open a file and it takes 2 parameters, the file name and the mode. Let's see the syntax. Syntax is f equal open path of the file. So you have the syntax as f equal open path of the file and its mode. Fine. Let's see what are the modes. So we have 4 different types of mode: read, append, write and create. For reading, you specify R. It's a default value and it opens the file for reading. And if the file does not exist, it will return you an error. Next is the append. And the mode is A. Alright. What it will do, it will open a file for appending. And in case if the file does not exist, it would create a new one. Next mode is W, which is write. It opens a file for writing and creates a file if it does not exist. Fine, I'll tell you about the difference of appending and writing later in this section. Alright. Next and the final one is create, that is X. It creates the specified file and it returns an error if the file with the same name exists. It creates the specified file and it returns an error if you already have a file with same name. Fine. Let me just show you. Like f equal open path of the file. I'll open it in my D drive, D slash name of the file, test file dot txt, and comma, what should be my mode? It is a reading mode, R. Hit enter. Okay. So as I told you earlier, it would throw you an error if the file does not exist, right? If you want to create it, you have to mention X up here and it will create your file. Let's go to our D directory and let me just show you the file. D, so you can see the test file up here, right? So this is how you can open a file in Python, or you can even write W up here. It won't throw you an error, since it creates a file if it does not exist, but it won't throw you an error in case the file with same name exists. Alright. Next is the read function. Well, suppose this is our file. It consists of the document hello welcome to demo file.txt. This file is for testing purpose. Good luck. Let's open our demo file. Test file. Hello everyone. Welcome to Intellipaat. Good luck. Save it. Save it as test file.1. Fine. Let's see what operation we can perform on it. Now, what if I want to read it? So how will I do? So f equal open demo file.txt comma mode r. R is what? Reading mode. And then print f.read. Fine. Let me just open that file for you. F equal open the path of the file. It was d:/test file1.txt, and in what mode? I want to open it in read mode, and I want to print all the content which is present in that particular text file. So f dot read it first and then print it. Hit enter. So these are the content of my file. Hello everyone, welcome to Intellipaat and good luck. Fine. Now what if I want to read some parts of the file? Like I want to read the first 5 characters of the file. So what will I do? Let's see. Just copy and paste it. I want to read the first 5 characters. So just mention 5 up here. What will it do? Print first 5 characters from the text file. Hit enter. So you got the output as hello 0, 1, 2, 3, 4 and 5. So these are the first 5 characters from the string. Alright. Fine. Now what if you want to read the first line? So for that you have a function as readLine. Alright. You have a function as readLine, which would be used to return one line or the first line. Again copy it. Paste it up here. Read line. Just hit enter. Sorry, you got an error. Okay, read line. Okay, sorry, L is small. Read line. So you got the output as hello everyone. This is my first line. Next, what if I need to read first 2 line of my document? So what will I do in that case? So in that case, what you can do, you can use read line twice and it will print first 2 line of your text. like this. Again, do it once more. F dot read line, hit enter. Again, the same error. Okay. So what you got? So you got the first two line from your text. All right. Now looping through the file. Now what if you want to read the file line by line? So you can use a for loop in that case. So it's like for x in f such that print x. If x is 1, then print first line, x is 2, then print second line, 3, so on. Alright. So you'll be able to read the file line by line. Hello everyone, welcome to Intellipaat and good luck. Next is reading and creating. Now to write to an existing file, you must add a parameter to the open function. Like you can write a or w. A will append the file, that it will append or add something at the end of the file, and w, it will overwrite any other existing content. For example, let's copy paste it up here. Instead of r, let's mention a, it's for appending. And f dot write whatever you want to write. This is the appending statement. Execute it. Fine. Now if you will check the file, let's check the existing file. Open it in a read line mode. R for x and f, print x, execute it. So yeah, so as you can see, this is the appending statement got added at the end of the file. Now what if I use w instead of a? So what will it do? This will overwrite my statements. So here I can write print f dot write this will overwrite everything. Execute it. Done. Now let's check it again. What are the contents of my file? So if you check it, so only this is left. This will overwrite everything. Fine. So this was about how you can write to an existing file. Alright. Next we have is creating a new file. Well, you can create it using X, A or W. Using X creates a file and it returns an error if the file exists. Append, it creates a file if the specified file does not exist. And finally W, it creates the file if the specified file does not exist. For example, fopen myfile.txtx, it will just create a new file. And in case you are attempting to create a file with the same name, it will throw you an error. For example, remove this. This file already exists, right? If I'm trying to create it again, it will throw me an error. Alright, as file already exists or file exists. Fine. Next and the last we have is the delete. Well, import OS module is used to delete a file. How you can delete it? Import the OS module, os.remove demofile.txt. That's it. But for that, what you have to do, you have to first close the open file. So f.close, inside this, mention the name of the file, or the path of the file, d:/test file1.txt. First close it. It's like f.close. Close the file. Now, if you want to delete it, you need to import OS module to it. Import OS and os.remove inside that name of the file. What is the name of the file? Test file1.txt. That's it. Got the error. The system cannot find the specified file. So I guess the file is, no, it's not deleted. Okay, I haven't specified the path of the file. I just written the name of it. So I'll write d:/ and the file got deleted. So yeah, there is no test file 1. Alright, fine.
Data visualization, why it is needed, what we are, how you are going to do with data visualization in Python. So that's what we are going to see. Okay, first comes into picture what is data visualization. So data visualization is basically presenting numeric or any kind of data with using using charts and graphs and or any other pictorial formats, right? So by that, what it does is, if you this is a proved theory that written instead of going for a written or some reading some written thing, and between visualizing a picture or seeing a graph, the second one, that this graph or this image technique helps to remember or grab the context much more easier. Okay, also it gets easier to explain what we are going to do with these graphs and charts, right? So that's why we do use so many graphs and charts in our ppts, in our excel files, right? So to make the client understand easily, like, see, this is the data that we drill down and this is what we have found out. So this is the trend that you have. So that's why you need to tweak in here or tweak in there to change your parameters, like that. So that's why these things, this data visualization thing gets really important for being data scientist, data analytics, or in any field, right? In any field, this is very important. So if you are working in IT industry or banking or finance, doesn't matter, you will always need this visualization technique. So Python provides a really powerful tool. So a few libraries are there. So as I already told, in Python you would generally not be required to write those long codes, like with the algorithms with displaying pictures and all those things. You are not you will write it, but it's pretty less. So most of the time, what you will do is, you will grab a already defined and already optimized library that is available in net. Those are all the time will be open sourced. So those open source libraries you can grab and you can use those to use those as it fits your purpose. Okay, so that's what and why is data visualization important. Next is, if we go to this visualization, this helps the clients to understand the data much more clearly. Also, if you see a few numbers over the years, let's say we are going to give a summation, like a project estimate for a new project that our company wants to onboard, right? So in that case also, what we would need to do, we would need to analyze the data, right? How the shifts will cover, what is the AD work, what is the AMS work that we have, like the support work or the development work, what we have and what we don't have, those kind of things. Those are basically done by taking data from clients, like, okay, fine, I can give you an estimate, provide me this details. Or what we can do, we can take experience from our previous projects in in our company that is currently being run. We can analyze their data and we can shoot them, like, okay, this is what is the thing. Okay, and we can ask data from clients also, so that's how we can do. Okay.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So in those cases, data visualization comes really handy. Okay, and data visualization is presenting the data that you have in a graphical format. So that means, let's say you are collecting trends for something over a few years. So what you will have 2013, let's say it is education ratio, male 98%, female 100%, like that. This distributed data you will have. So 2013, 14, 15 till 19 you will have some till 18 you will have some xyz kind of data, but that won't really make sense, right? So if you just plot it, real sense, right? How the ratios have changed, how, what is the trend, right? Like girls are more initiative in this, or if you have a more drill down, let's say to like those rural and urban area levels, then which level girls are performing better. Okay, so that's what is data visualization all about. So that's where we use it, and that's why we use it. So if you I will show you some example also, real world things where this data visualization comes into picture and how this comes handy. Okay, so that we are going to see in a few minutes. Okay, so that is what is about this, and next is data visualization example. See here, we are trying to explain some difference of mammoth and saber-tooth cat. So if you see those pictorial way, if you tell them it has long teeth, both of them will have long teeth, right? So it will get confused. But if you just just plot this data, if you just show them with the picture, like compare the upper table and the below pictures, then later one, the picture one is much more clear, right? So that's where data visualization comes handy. Okay, so that's what the idea, that's why we use it. And as a data scientist, you will almost always always be using this technique to get some insight from the data, like that. Okay. Okay, so now the things that I was telling you, like this data visualization, why it is important and how different it becomes when we plot the graphs from seeing the data points only. Let's say in this one, in this chart, there are four data sets, right? They are just points of x and y. Okay, they are just 2D points of x and y. So this, if you see all these four data sets and if you see their basic stats, right? Like some average, standard deviation, and all this kind of average basic stats, then you will see that those have almost the similar kind of values, right? Some is always like 99, some for x is 99, for y is 82.51, average for x is 9, like that. So all the basic stats of these data sets are similar. So if you just see those with naked eye, like this, then you will not find any difference between these data sets. You will basically go ahead and comment, okay, these four data sets are same, nothing to no need to worry, all these are same, all the characteristics are same. Now the next thing I will show you will, where you will see how different the data sets are, how different the data sets are, you will see that. So if you are going to plot this data in this 2D plots, right? So see here what it happens. Do we have it in example? I believe we don't have it. Okay, fine. So if you plot this data in a 2D plane, right, this will look something like this, that is in my screen. So let me just grab my piece of code for this NSCOM portrait. So that's how it becomes, but the data visualization comes handy. Okay, so that's where it comes handy. So I will just get it and will run this one. I have this in my screen. So see, this is how the data sets differ from differ when you just go ahead and plot this in a graph. Okay, I will show you the code, but no need to be worried, that that is already given. So if you see, this is the same kind of data that we got here, right? So if you see here, for the first data set, the data is almost evenly spread and it fits a linear equation, right? Almost fits a linear equation. It's almost there, right? For the second one, see a S-shaped curve is there. For the third data set, it is again a straight line. Okay, only 1 or 2 points are here and there. Those are outliers, so can be safely excluded. So this is almost there. But in the fourth line, see that type of data. It is stacked. All the points are stacked in here. Because if you check this, all the x values for the last one is set as 8 except one. For one value, that is 19, right? So all the values are stacked in here for x, and this is the 19 one for which x equals 19. So this is how different the data sets are. Okay, this is how much different the data sets are. But if you see their correlation coefficients, mean, standard, and everything that is printed over here, R is for correlation coefficient. So if you see here, you see all the values are same. I mean, there is not much of a difference. Okay, so one thing need to be remembered, that this ANASCOM cohort rate is a unique data set. Okay, this ANASCOM just found out these points, these sets of data with this 2, 4, 6, 8, 10, 11 data points to be having this kind of characteristics. This is a pretty unique thing. After this ANASCOM quadrant was discussed, there are many attempts to revisit those, and almost everyone who is related to this data science and machine learning or maths or stats things, they always have tried to back calculate thing and tried to predict different kinds of data set to have the same kind of thing, like where the descriptive stats are almost same with 4 data set, obviously with 4 x and y data sets. So for 4 of them, the descriptive stats are almost equals. So that's what I am telling Rajiv. Just let me finish. So this for these data sets, this is the unique data set. Okay, so for in here, those 4 of them are all the 4 of them have same kind of descriptive stats, but it just differs radically when you plot those. Okay, so that is where this comes handy. So for data visualization starting purpose, this is a very good example, and there is no other data set till now discovered which has this kind of values with four different data sets having same kind of descriptive stats, but differ in this radical way, like how these graphs are. Okay, how these graphs are different. Okay, so that's where this thing comes into that's where this thing comes into picture. Okay, that's where it comes handy actually. Okay, now if you check the code that I have pasted here, so see, this is how we import Matplotlib into our Python code. So Matplotlib, why Matplotlib? Coming to it, just as I'm explaining the code, I will explain this and then we will go ahead and discuss this. So this Matplotlib code, right? So that's where what we are doing is, in this Matplotlib code, what we are doing, we are just, I mean, this is a Matplotlib library, and this is a object-oriented library also. Okay, so that things we will discuss later. If you want to do that, you can just take this XY points, and you can try plotting these points in the plot like we showed in the last class, right? How to plot a line chart. So you can try it that way also. If you are not having the data set also, so then also you can do this. Okay, then also you can do this from this picture itself. I believe in this file, this ANASCOM quadrant picture won't be given. I think so, because I don't have it. If they have updated, then fine, you can take it from that code part also, but I don't have this one. Okay, so I just had my own version. So anyway, it will work. No need to be worried. Okay, and also the data set is already present, right? So what you can do, you take 2 arrays x, y, x1, y1, x2, y2, x3, y3, 4 arrays you can take of x and y, then merge those, like for x, y plot together, x1, y1 plot together in the line chart, and then only you can see this kind of plot. This is nothing much. Okay, so that's how you can do. No need to be worried on that part. That's really easy codes. Once I explain this, you will understand. Okay, so what we are doing, we have taken all these x points here, then we have calculated y point with this equation, and if you see the equation will fit this one to some extent. So yeah, that will be better. So if now if you focus on this, I will show you how those are plotted. Okay, so that will be helpful for you. So see here we have used plt.plot x and y1. If you even if you for now if you don't even I mean if you don't give this parameters, it is fine. It doesn't, it is not required. It will give you some kind of plot also. So for now keep it to plt.plot x comma y1, and you can have the color also. If you don't give it, it's fine. It will give you a nice good color. So that's how it works. Okay, so that's how these are plotted. So others that I have, those are really advanced level things, no need to be worried for now. I will skip those. We will discuss those later. That's fine for now. For now, just see, we have plotted x and y2, x and y1 like that. Okay, so that's how we have done xy1, xy2, xy3, x like x sorry, yeah, like that, xy1, xy2, xy3, and x4 and y4. Why is that? Because if you see the x part for all these three data sets are same, right? So only one array would do, and for y we have four different arrays, and we have plotted those. Okay, we have plotted those using this plt.plot line. Other lines that are there, even if you don't give it, not an issue, it will still run. Okay, you I mean if you have that in the code, you can try. Yeah, label the variable means which one? Like x and y, it will take automatically. So plt.plot, as if you remember, I showed you yesterday, the first one it will take the horizontal axis, second one it will take the vertical axis, so it will have x and y too. Okay, other things we are we will be coming in shortly. We have this in far more detail shortly. Okay. Okay, so that's what is Anascom Quadrat. So next is data visualization libraries. We have a lot of libraries available for Python to plot these graphs. Okay, plot different kinds of graphs. We have Matplotlib, ggplot, Seaborn, Plotly, and GeoPlotlib. So all these plots comes handy in data visualization, but the Matplotlib, it has a really good interface. It has OOP models included. It has different kinds of graphs predefined in it. It can, like as you saw, right, we have a setup function, we have a access function, text function. Those all those functions are for customizing the graphs. They are very high level things. So this is just to change your graph, and then that can radically change your graph. Your graphs can be very beautiful. If you explore this more and more, you will see your graphs are getting really beautiful. For presenting it to someone, those will be required. But for data science related purpose, for your solutions, when you are experimenting with the data sets, that is not really required. But again, when you are presenting it to someone, it can come handy. But that's fair enough. I mean, if even if you don't get it right now, it's fair enough. You have time for that. Okay, so that's how it is. Sorry, what is happening? Okay, so next is Matplotlib is there. Next is Seaborn. Seaborn is again built on top of Matplotlib, and that's also a very good plotting library. So, but and generally we use Matplotlib the most. Then comes the Seaborn plot. Others we really don't use it for now. Okay, we really don't use it because those are having some here and there limitations and all. Okay, so this can create 2D graphs and plots using Python scripts. Obviously, whatever we are seeing, it can create multi-dimensional graphs also, but those are not for now. Those are not required. When we see machine learning, we will see that, like the contour plots are there. What are those and how they look? We will see that. Okay, those are kind of multi-dimensional graphs. So 2D graphs and plots can be created easily using Python script. It can produce the output in a various hard copy format. That means whatever graph you see here, you can save it to a PNG file, JPEG file, or whatever. So that's where this comes really handy. Okay, that's where it really comes handy. Okay, next is this is a next is why to choose Matplotlib, because it has a, first of all, it is a OOP based API. Okay, the library is almost based on OOP settings. So that means it will have the same kind of structure as classes and objects when you try and refer the Matplotlib module. So that's why you must have seen we have used matplotlib.pyplot, right? So matplotlib is the basic class and pyplot is a function of it. So that's why class name dot object name, object name dot function name. That's how we use it, right? That's the OP basic. So that's how we do it. Okay. Yesterday you saw we can integrate this using pandas, and as pandas is based on numpy, so numpy is also possible. I have shown you examples, but this matplotlib was not known to you, so you can go back and check the examples where I showed you. Okay. Next is very wide variety of graphs. We will see that next, like what all types of graphs we have in Matplotlib and how that can be used and what are the usage of those graphs and where do we use it, like that. We have simple functions used for visualization. So if you go ahead and see here, forget about the first example, see this basic. What we have done, we have taken a np.a range. Okay, we have taken a x variable np.a range, and we have the values from 0 to 10 with 0.1 separated. Okay, then we have taken a y value which is 2x plus 5, so that is an x and y linear equation. Okay, and we have plotted the xy points, and this is how it looks like. So this is how you plot a line plot in Matplotlib. Okay, next what we have done, plt.show to show this plot. Okay, to show this plot to you. So that's how easy is that's how easily you can visualize a function in Matplotlib. Okay, so with this plt.show function you can see the graph in here, and plt.plot will show you the plt.plot will plot you this line. Okay, so that's how easy it gets when you use Matplotlib functions for data visualization. Okay, so that's how it is. And always remember one thing, the behind the scene, the main module that is responsible for this data visualization is called pyplot. Okay, so that's why if I go back to the code, you will always see we have imported the module matplotlib.pyplot. Okay, we always have used it, right? And we have used the alias just to have a ease of reference, right? So that we don't need to write the entire thing in there. So that's how it is. Okay, so that's where this matplotlib is. That's how easy matplotlib is.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
What are exceptions? So let us understand that. Firstly, let us look at the definition of exceptions with regards to programming. In programming, an exception is defined as an event which stops or interrupts the intended flow of a program's execution. So as a programmer, when you write code, you have an intended flow of how your code blocks will execute, in what particular order, and what exactly you need to execute. So anything that comes in between, anything that occurs out of the blue, any exception, so to speak, any error that happens that is unaccounted for will totally interrupt your flow, and that is called an exception. And we need to deal with that in programming sense, because otherwise we can break our applications, right? So let's look at this from a technical perspective. There are two types of programming languages that exist. So the first is compiler based languages, and the second is interpreter based languages, right? So in compiler based languages, what happens is all of the code is firstly compiled and converted into bytecode so that the machine can execute it all at once. So in this particular case, before the execution of the code is converted into low level language, right? The entirety of the code. So in this particular case, what will happen is you'll basically have your code structure where the code starts. There will be a code module 1, a code block 1 that will execute, which doesn't have any errors or exceptions. So it will execute successfully. And then if you encounter a code block or a part of the code where there is an exception, a code block, so it will simply throw a compiler error that there is an exception over there, or there is a code error over there. Simply go and fix that. But it will not interrupt the code module 3, at least in the compiler sense of way. The module 3 will compile successfully, and you can even run the code and it has a chance of running successfully. So this is called compiler-based languages. These are like, for example, we can take C, C++, Java. These are compiler-based languages. All of the code is first compiled and then it is executed. So on contrary to that, we have interpreter-based languages. Now, in interpreter-based languages, the entirety of the code is not compiled. It is just executed line by line, right? So Python is one of those languages. Obviously, Python is an interpreter-based language. So the workflow of interpreter-based languages goes something like this. So the code starts line by line, right? The first code module is executed because it does not have any exceptions. It is correct, so it is executed. So the next code module where there is an exception, when that is encountered, right? What that will do in interpreter-based languages is that it will stop the execution altogether. So the next code module will not execute either, right? So what happens essentially in this particular case is that even if the code module 3 does not have any exceptions, it is completely logically correct, right? It will still not execute. So in interpreter-based languages, not handling exceptions could lead to the entire application breaking, right? So we want to execute things that are correct, right? Even if code module 2 is wrong, we want to resolve that particular issue and we want to move on to code module 3. So unless we handle these exceptions, that is not going to be possible, right? So exception handling is meant to deal with exactly this. So let us look at the workflow of this particular case if we handle the exceptions. So how to handle exceptions in interpreter-based languages? It is sort of the same for compiler-based languages as well, except we all know the logic of whether all the code modules will compile or not in compiler-based languages. In interpreter-based languages, we do not need to concern ourselves with that. Uh, what exactly happens over here is that the code module 1 will execute successfully as it should. When the exception is encountered in code module 3, we can see a little bit of change in the flowchart, except for the arrow, instead of the arrow pointing downwards from code module 3, right over here, as we can see, the arrow goes to the right and it basically goes into the condition which says that if there is an exception, execute this part of the code on the right hand side and then continue as usual to code module 3. So even if there is an error in code module 2, we have created a fail safe for that essentially in this if exception clause. So whenever there is an error which is encountered, we go to the if exception clause and then the if exception clause continues on to code module 3 and we are able to execute the entirety of the program as much as possible without actually having to stop the execution at all, right? So this is how exception handling happens in a diagrammatic view. So now that we understand the workflow of exception handling in Python, we can look at some examples of exceptions that can actually occur in Python in day-to-day programming. So we'll look at some simple ones so you understand the concept. The first one we are going to look at is called the zero division error. Now, the error name is pretty straightforward. It happens when you try to divide a value by zero, or you basically try to get the remainder of that particular value by zero. So, the modulo operator or the division operator. So, essentially, if you understand this arithmetically, when you try to actually do this in theory, what happens is you get infinity when you divide a number by zero, right? In computational terms, you cannot actually compute infinity. So to deal with that particular issue, what programming languages do is that they throw an exception when you try to run this particular operation, right? So you can design cases to deal with this particular exception if it happens. Other than that, this is what the error is called. It's called the zero division error. Then we have the name error. Now in name error, what happens is when there is a variable name that you're using, which has not been defined previously, right? And you're directly using it, it'll throw a name error. For instance, if you try to write a statement which is a equals to b plus 3 and you haven't defined the value of b, right? Then it'll throw a name error because this b variable has not been defined. Then next up you have type error. Now the type error refers to data type mismatch essentially. So what happens in this is when you try to basically perform an operation where there is a data type mismatch. For instance, in this particular example, we can see that a equals to hello, which is a string value, plus 4, which is an integer value. We are trying to add an integer to a string without any implicit or explicit conversion, right? We're not trying to convert this particular integer to a string value and then trying to add it. We're trying to add it as a numeric value itself. Now, in programming logic, that cannot happen. We need to convert this 4 into a string if we want to add it to our hello value, right? So in this particular case, it'll throw a type error because there is a data type mismatch between string and an integer. So if programming languages have defined a variety of exceptions, there must be a way to deal with these exceptions as well. So what happens essentially is that every programming language has its own way of dealing with these exceptions, right? In Python, there are ways as well. So let us understand what is exception handling first. Exception handling theoretically is defined as the process of adding fail-safe measures into the code to keep the program running in case of an exception, right? So it's essentially used from the application point of view to stop the application from breaking when an error is encountered, right? So let us understand the various methodologies that Python implements to deal with these particular exceptions. So firstly, we use the try block, right? So the try clause is used to define the block of code that you intend to successfully execute if no exceptions occur, right? So instead of writing code straightforward, like writing printx without the try block, what you'll do is you'll simply write the try and then you'll indent a print statement after the try, right? So this print statement is now under the try clause. So if an exception happens, you can now handle this particular exception. Instead of the program simply giving you an error and stopping, you can now find a way to deal with this particular exception. You can try this code. If this does not work out, you can deal with the exception that happens. So next up we have the except block, right? So the except clause is used to define the block of code that you would want to execute if and when an exception is encountered in the try block, right? So say in this particular case, suppose the print statement fails. So when it fails, the control goes to the except block and it will print exception, right? So you can deal with this various ways. You can add various categories of exception in front of the except clause to deal with that particular exception only, which we will see in the example that we are going to execute. But this is how you would deal with a particular exception. When you try a part of code and it does not execute successfully, you can straightforward go to the except block and execute that statement, which is present in the except block. Then you have the else block. Now this is an optional block of code that you can use. It is used to define the block of code that you would want to execute optionally if no errors occur in the try block. So say if the print statement executes successfully, the except statement will obviously not execute because you haven't encountered an exception, but the else statement will execute because the try statement did not have any exceptions essentially. So it will basically print the value of X and then it will print no errors. Then finally, we have the finally block, right? So this particular block of code is also optional in exception handling. You can use this particular block of code when you want to execute a particular set of instructions regardless of whether an exception is encountered or not. So the finally block of code will execute whether an exception has been found in the try block or whether the try block has successfully executed. It will still execute. So in this particular case, whether the exception prints or the value of x prints, the will always execute will always print. So this is essentially how you handle exceptions in Python. So now that we understand how these four particular clauses work, we can now move on to the demonstration part of this particular tutorial. So let us see how exception handling works in an hands-on experiment. So let us now see some of these exceptions in action. So firstly, let us try to execute the name error. So if we try to do this, a equals to b plus 1, right? And we execute that. So it simply gives us a name error, right? So the way we can deal with this is by simply going over here and adding a try clause, right? So when we add a try clause, we can put a tab statement over here and add an except statement and print the message that we want to print in case this particular exception occurs, right? So exception has occurred. We do that and we click on play. So we can see that instead of this particular statement executing and giving us a name error, we can see the message an exception has occurred, right? So next up, what we can try is something different. We can write over here except name error, right? So this is the category of exception that we want to deal with specifically instead of dealing with all of the exceptions. That is what happened, right? So if we play this as well, we can see the statement exception has occurred, right? So let us try something else with this. We can also add a finally clause over here or an else clause. Let us first try an else clause, right? So when we add an else clause, we can type print no exception has occurred, right? When we do that and we click on play, it still gives us the message exception has occurred because the exception is actually occurring, right? But instead of that, if we simply change the b to 1, right? Now the statement should successfully execute because there is no exception over here now. We click on that and it'll simply print no exception has occurred. And if we type something like print a over here and click on play again, so it'll first print the value of a in the try block, right? And then it'll go to else and say no exception has occurred. So next up, we can try something else. Let us try the zero division error. So in this particular case, what we will do is a equals to 100 modulo 0. Let's try that. And print a, right? Now we can type except name error. So we know that this is not the name error, this is the zero division error, right? But we'll still write that and we'll see which exception is actually caught, right? So print name error has occurred except zero division error will print zero div has occurred. Then we play that and we can see that instead of this particular exception printing, the zero division exception has printed, right? So since we did not catch any name errors, the zero division error was caught when this particular statement tried to execute, right? So instead of that, if we simply go over here and change this to 1, right, it'll simply print the actual output. So when we divide 100 by 1, the remainder is 0, right? We can add something else over here, which is called the finally block, and print hello, right? So in this particular case, what will happen is we play this and we get the 0 from the try block and the finally from the hello block. But that is not all. Say if we change this back to 0, right? Now this means that we get the zero division error once again, right? So now what will happen is we'll get this statement, which is zero div has occurred, in which in this particular case the error was caught, the zero division error, and then the finally block was executed regardless of whether the try block executed successfully or an exception block executed, right? So that is how the finally block works. And finally, to look at the last error, which is the try, which is the type error, we'll simply type try b equals to hello plus 17, which is an integer value, right? We do that. We type print over here, type b. We go to except, and we type in the type error, which is the error that we are probably going to catch over here. Print type error. We do that, and then we can try to add an else statement over here. Print the print statement over here will say something like no exception has occurred. And finally, we get the finally block, which says I am going to print regardless, right? So when we try to execute that, we can see the exact workflow of how this is working out. So the tried statements tries to execute. We get this p equals to hello plus 17. This does not execute because there's a type mismatch, the data type mismatch, string and integer. We go to the type error, right? Now, since an error was actually encountered, an exception was actually encountered, the else statement will not execute as well. So this statement will not execute because error was encountered, right? And then finally block, the finally block that we have over here will execute regardless because it executes regardless anyway. So if we simply go back and change this to say 11, which makes this a valid statement now. So it'll change the output. So firstly, we will get the 28, which is 11 plus 17. We get the 28. We get the output from the else statement, which says no exception has occurred, no exception was encountered. And then finally, we get the finally statement anyway. So I am going to print regardless, right? So this essentially explains how exception handling works in Python. Now, additionally, we have the option of raising exceptions as well, right? So we have the option of specifically specifying conditions in which we would raise exceptions instead of relying on the predefined exceptions that Python already gives us. So say if we want to throw a type error or an exception in general. So let us type in something like x equals to 14. Right? So this is a value, and now x is equal to 14. Now what we can do is simply type in if x is equal to 14, in which case we will write if x equals to 14, and then given the condition of that particular statement, And then what we would do is raise an exception. This is an exception is the message that we're going to use. So when we do that and click on play, it throws that particular exception, which is this is an exception, right? So we can even configure Python in a way, or we can configure our code in a way to throw exceptions on our custom predefined conditions, right? So the raise statement is used for that. We can also do other exceptions with this particular statement. Now, if I simply start a code block again over here, right, I can raise another exception. Say, for instance, I type in a variable. Now I give the variable a string data type. So let us call this string data. Right now, what we will do is we will check the type of this particular variable. Now, to do that, we'll simply type in if not type a. Now we're checking the data type is int, which is the data type that we're actually checking whether the a variable is of integer data type or not. Raise type error and say that integers are allowed. When we do that and we click on play, we get an exception which says the exact message that we typed in, which is a type error and integers are allowed. So that was the example of how exception handling works. I hope you understand the workflow of it and the exact pattern of how these exceptions occur and how you can handle them very easily. You can also see how you can create your own exceptions by using the raise keyword.
Now let's take a look at the features that will be available in Python. Python is very frequently updated, so new features are going to be available with every new version, and old features are going to be deprecated in every new version. So we recommend you take a look at the new feature list in Python whenever new version releases. So Python will have several features added to it in 2021. So one of those features is bit count, then there's strict zipping, and then there's the read-only proxy of dictionaries. Firstly, it's bit count. So as we know that computers don't really understand the source code that we write. To it, it's just a large blob of text. It's the job of the interpreter or the compiler to convert the code that we write into machine code. Machine instructions are at their very basic level written in binary. Binary is a number system which works with either 0 or 1, and it has a binary digit system. Binary digits in short are called bit. So if you ever hear 1 bit or 2 bit information, you mean there are two binary digits that represent the information. Both of them could either be 0 or 1. Now, the bit count function is there so that you can count the number of ones in a binary format of a number or a string or whatever. So once that code is getting compiled and the value that you have is compiled, what will be the number of bits or ones in the entire string? Don't worry if you don't understand it. We'll take a look at that in the hands-on section as well so that you can get a better understanding. Then comes strict zipping. In case you have not heard of zipping before, you might not have used Python that much because zipping is by far one of the most common things that has happened. So zipping basically allows you to create a tuple out of two lists. If you have two lists with different values and you want to create tuples of the same indexes, you use the zip function. Strict zipping basically means that if the lists that you are providing to zip are of different lengths, you will get an error. Before this, what you would have to do is you would have to check them manually and say, okay, this is not working. You have given us different length of lists to zip, and we can't process this list. And then you move ahead. But this was a check that you have to do on your own, and sometimes you'd forget. So in Python, they have added this new feature in which when you create a dictionary, when you create a zipped version of two lists, you will have to provide lists of same length. If not, then you will run into an error. And we'll take a look at that as well. Finally, there are the read-only proxies of dictionaries. So in dictionaries, many times we want to create a read-only version of the dictionary. Now there are ways you can do that, but it's difficult to create a read-only version of a dictionary right at the beginning. So in order to use it correctly, we will have to use the newer versions of Python because they come with a feature set that allows us to do that. And we'll take a look at that as well. So let's get started right from the beginning and let's have a hands-on in which we understand all of this. So let's get started. Now for the hands-on, you would have to install Python. So let me just show you. You have to go to this programming python.org website. Here you can download the newest version of Python, and if you want to follow along, you can do that here. The code you write here is going to be interpreted in Python 3.9, and we want to use the latest pre-release version. So go to the download section, click on the operating system that you want to use it for. I will be using Windows. If you're on Mac, you can use it here. If you have some other platform like Linux, you can click here. So I go to Windows, it opens it up, and it shows us look into this section which is on the right hand side. It's called the pre-release section. The stable releases are the versions that have been checked and all the bugs have been removed that were reported while the software was being developed. On the other hand, in the pre-release section, we might have some bugs, but you can try out the new features as well. So you can go here in Python 3.10.0. Before that, you would get Python 3.8.7 release candidate 1. But we want this to be the one. It was released on 7th of December 2020, so not too long ago, and you can download the installer here. If you want the help file, it's available. If you want the embeddable package, it's available as well. Choose the architecture correctly, install it, and you will be good to go. I have it installed and running, so I'll just show you what it allows us to do, right? So the first thing that we have to take a look at is something that we refer to as a bit count. So let me just show you. So I will create a number and I will save it inside X. Let's call it 108. Take a look at 108 and we have the value embedded in a variable X. Now, if I want to take a look at its binary representation, I have to use the function bin. This has been available for a long time. This is not Python's current version. As you can see, we have 1, 2, 3, 4 bits. So if I want to check how many ones are there, all I have to do is type bit count, press enter, and I get 4. If you are using some other version, as you can see, this is Python 3.10.0 A3. A3 is the third alpha version. If you're using older versions of Python such as 3.9, you might run into an error saying numbers don't have a property or a method named x.bit count. So in that case, you would have to upgrade. So this is how it happens. Now, if I were to change x to be equal to -108. Now, if I were to go back, take a look at the binary representation. It's the same thing, but I have a negative symbol added at the beginning to show me that it's a negative number. If I take a look at the bit count again, I get 4. So the number of binary numbers that are 1 here is the same. There's 3 zeros and there's 4 ones. So that's one way you can do it. So how does it work? Well, in a very basic sense, the way it works is what you do is you calculate the binary number, it returns a string, and here what you can do is you can just count the occurrence of 1. This should return the same thing, which is 4. So in case you're using older versions of Python, you can just create a function on your own, call it bit count, so just call it def bit count get a number, and here all you have to do is return the binary representation of x and then count 1 in it, right? So if I go bit count 108, you get the same thing. So if you're using older versions of Python and you want to use this feature, this is available for you to use it this way. All right, now let's take a look at zipping. Again, for those of you who are unaware of how zips work, let me just show you. I'll just scroll down a bit. Create a zipped version. I need to create 2 lists. I'll call them A. A is going to contain, I'm going to call it small a. Now I'm going to create few things here. I'll call them names. So John, Jane, Jenny, and Johnny. So we have a list. I'll create another list. This will be called 3 things. We'll call it the number of the percentage that they acquired. So let's say 88, 44, and 98. So I will only keep 3 here as of now. Let me just add one another to show you how this works. And 77. So I have two lists, A and B. I want to create a tuple of these two values, these two values, these two values, and these two values. The code I would have to write for this is going to be a little cumbersome. But since Python provides me with the zipping feature, all I have to do is pass in A and B, and it returns a zip object. If I want to create a list of the tuples, I can do so as well. It's going to be list. There you are. John has 88%, Jane has 44%, Jenny has 98%, and Johnny has 77. As you can see, the corresponding values are being used. But suppose instead of B being this, I change the size. Now it's the length of A is 4, length of B 3, and length of B is equals to length of A. We are going to get false. But if I try to create a new list of zip and A, then I get only 3 values. So that's the thing that you have to understand when you're trying to use zipping. One of the values get removed from this. So this is how it works. But if I want to be a little strict here, I can pass in a parameter in the zipping function, and I'll call strict is equals to true. Now I have passed in. So argument 2 is shorter than argument 1. So I have both the features. Earlier this feature was not available, and passing strict is equals to 2 was going to raise an error that it doesn't understand what strict means. But now since I have two lists that are of different lengths, if I want to opt in for stricter versions of zipping, then I can do so. The reason why this was added, strict true, was because to make it backwards compatible, so that other code that used the older syntax in which different lengths would be accommodated for, in cases like this, they would not want to break the older code but just want to add a new feature, and that's the way they chose to go with it. In case we were doing this, then we would have to just create another function, call it strict underscore zip, pass in A and B, def strict zip A and B, and then I have to just check if length of A is not equal to length of B, then I have to raise an error or something like that. So I could do it like this, or I can, here I have to use the word except and throw a new exception. Now that's possible, but I won't be doing that. So that's how you can do the new zipping feature. Finally, the third thing that we have to do is take a look at the dictionary. So let me just show you how that works. First things first, I have to create a dictionary. Now again, the same way I did earlier, I had two lists. I'll create a dictionary out of those. So if I pass in dict with A and B, I think yeah, so because they are of different lengths, it's not going to work. So let me just take a look at it. I'll just create a dictionary easily. Jane had 88%, John had 44%, Jenny had 87%, and Johnny had 98%. So let me just store it inside this is a dictionary that I have, but right now I can change the values if I want to, whether knowingly or unknowingly. So for instance, instead of John having 44, I can just make it up to be 77, and it works the same. Now the dictionary has been updated, and it could be a problem if you are someone who doesn't want to change that. So that's the way you can do that. But if you want to extract these things, let's take a look at that first. So first of all, let's take a look at how you can extract the keys. So d.keep, and this is how you get. For values, you just have to type in d.values, and you get the values. So these are two different types, dict keys and dict values. So after getting these things, if I want to create a read-only proxy of the original dictionary, all I can do is just create a new dictionary. I'll call it d.mappings, and it's getting me an error because I have to do it on values. So let me just do it here, values, and then do it. Oh, and it's mapping, not mappings. Sorry about that. If I press enter, this is a mapping proxy. So if I want, I can just take a look at how much did Jane get. It's 88. How much did John get? It's 77. If I want to delete, I can't do it because mapping proxy does not support item deletion. So I can't delete the items out of it. So that's the way this works. Again, these are not fit for being used in production. So we recommend that you don't use them in production, just use them where you can. Just try them out and see if this works.
So, coming to the important aspect of this particular video, what are the steps that will help you land a job as a Python developer, guys? So, I've broken it down to a couple of simple steps, and I believe the first important step here is to master the basics of Python. Because I've seen a lot of Python developers in my time pretty much aiming for jobs at Fortune 500 companies, and they have a very strong foundation of Python. And I asked around a couple of guys just before I came up with this video, and everyone suggests that you need to be really strong with all of the basics of Python. Probably with respect to intermediate components and advanced concepts, you can pretty much learn it from a certified organization and get certified with respect to the same. But having and mastering the basics is a very important first step, which will pretty much help you land the developer's job, guys. And coming to the second most important step here, which I believe is knowing all your data structures, guys. Because if you've ever interviewed for an IT job or a job which requires a developer role, then pretty much you already realize that everyone emphasizes a lot on data structures, right? So data structures, people believe it is a very alluring concept. It just goes around people's head, and people think it's very tough. Well, guys, it actually isn't. You just need to understand. If your foundation isn't really good, you will find a lot of difficulty with respect to data structures. And hey, it's always good to go back to your roots, right? So if you're not strong in data structures, just head back to your basics, learn everything again. I mean, there's no harm in learning it again, learning it right. So you need to have the data structures knowledge, and then you need to know that a couple of data structures in Python. We have lists, dictionaries, and so much more. So you need to know how all of these works, and just not just knowing how they work, but then knowing how you can make use of them efficiently is again the second most important thing with respect to making use of data structures using Python, in my opinion, guys. So you need to know how you can turn a pseudocode into an algorithm into flowchart, probably a flowchart into your Python code directly, and work with your other teams on this as well. And step number 3, this is one of the directions that you can head to, is by learning Django and Flask. Well, these are very well reputed frameworks for web development which support Python, guys. So Django and Flask are pretty much again being used everywhere. It's so subtly integrated that we would actually not know. Let's say as consumers or non-technical people, it is not known of what's being used to develop a website or what's going on in the back end, right? So Django and Flask are very important modules, and I believe they're extremely vital frameworks for a Python developer to at least know. I would recommend you just learn the basics of what's going on with respect to Django, what's going on with respect to Flask, and see if you can exploit something out of it, make a mini project of sorts which you can add to your resume, and which will eventually give it a lot of weightage as well, right? So this is step number 3, guys. Step number 4. So step number 4 pretty much involves all the majority concepts that you've pretty much learned in step number 3 with respect to Django and Flask, and actually using all of the skills that you mastered from it to perform a couple of web scraping activities from a couple of sites, guys. Well, web scraping, again, there is a lot of jobs with respect to web scraping, which again which is an amusing fact for me, because I just thought this was a couple of years ago, so I thought web scraping was a small thing in this world, but no, web scraping has its foot really strong. It has a very good hold in the world of IT. And then making sure that you guys can get to this step, guys, you will need a good web development framework and knowledge in this framework, right? Hence step 3 was an important one. Well, in my personal opinion, step 5 has to be the reason why most of you guys are here, or your goal would be something this, right? To achieve artificial intelligence with respect to machine learning by making use of Python, right? Guys, there are many frameworks and many libraries out here for Python. Again, Python is scikit-learn, TensorFlow, PyTorch for neural networks, deep learning, and machine learning as well. I mean, there are so many frameworks for Python, it will take you a really long time to learn all of these. I mean, my intention here is to not overwhelm you with all of the concepts that are present here, but I do want to inform you that there are opportunities present there and you can exploit it to land a very good job, guys. So step 5 would be to pretty much familiarize yourself with respect to machine learning using Python, because probably from 2017 onwards, this was the most, and this is the most trending thing when someone talks about Python. It's either deep learning or it's machine learning, guys, and we already know know the end goal of machine learning and deep learning is just to achieve artificial intelligence, right? So step 5 again is very important, and if you have a certificate that you've worked in machine learning using Python, that's a biggest bonus, let's say, or an upgrade you can give to your resume, and this will help you on your path to become a Python developer, guys. And step 6 is the next important thing after you work on your machine learning projects, is to know that you have to have a couple of projects. Let's say it can be beginner projects, intermediate projects, and advanced projects, right? So you can pretty much go on to build a calculator as your beginner project, have an intermediate project where you just make a game, and then have an advanced project where, let's say, you're doing some binary classification using machine learning, or let's say you're probably making use of recurrent neural networks and so much more. So you need to have some sort of projects, you need some sort of validation, because at the end of it, in an interview, you're just trying to sell yourself, right? Let's say your resume is just 2 pages, so you need to put everything that you've done in these 2 pages and sell yourself to the interviewer to convince him that you deserve the Python job, right? I mean, Python jobs pay a lot, actually, in fact, to be honest, compared to other programming jobs. I am not biased, but I just these are just the facts that are present, guys. And guys, stick to the end of the video where we'll be talking about salaries and so much more, and you'll get to know the figures of what a Python developer earns as well. So this important step here is to tell you that you need to work on some projects, you need to get your hands dirty with respect to code, and then work with it and go with it to pretty much land a good Python developer's job, guys. So after all of these, there are still some skills this is my personal set of skills that I would push for you guys. And the first most important thing is effective verbal and visual communication skills, guys. Because when you're working a technical job, I've been in situations where, people are trying to explain concepts to a non-technical person, let's say in a business meeting or a business review, and those people are not understanding what the developer is trying to tell us. So basically what happens is you need to dumb down your concepts from the world of IT, and probably you need to have that verbal skill to explain your code to a developer and to explain your code and concept to a non-technical person as well. So in my opinion, a good verbal skill is always not just a Python developer job, it's just great to have for any job, guys. And then the second thing is good team working ability, because if you are a hardcore Python developer, then you'll be writing hundreds or thousands of lines of code every day, right? Pretty much you will not be the only one working on an entire project in a Fortune 500 company. You will have a team, you will have a team lead, you will be working alongside your peers. So you need to coordinate with everyone. Then you need to have that ability where you can work together as a team and then just push all your skills together, bring everything into one umbrella and then work with it, right? So good team working ability is what I push for, guys. So, and then the third most important thing is you need to have this interest in collecting and analyzing a lot of data, because with respect to Python, most of the applications are either big data, machine learning, or neural networks. So you need to have this thriving desire to delve into data and understand data better, guys. So that I think is a good skill to have. And then lastly, it has to be good problem solving skills, because if you're taking the machine learning or the neural network path, it's a lot of mathematics and computer science, right? So you need to be very good at calculus as well. So I mean, not just calculus, you won't be using calculus all the time, but then hey guys, you will require that particular skill. And not just calculus, not just mathematics, good problem solving skills in general, guys. And then most of the Python developers have an educational background which is pretty much from computer science, information technologies, or they have a major in mathematics, statistics, and so much more. Well, this is again the requirement from all of the companies hiring a Python developer. Well, if you are not from a computer science background or an IT background and you still learned how to become a Python developer, let's say you just picked up our Intellipaat's certification and you got certified, well, you still apply for a very good job, and then you just need the skills. Well, people these days are not checking a lot of education, guys. They just need the skills that you have and pretty much a good couple of abilities like team working abilities, communication skills, and problem solving skills. And if you're good at this and Python, well, you're just into the organization, right? So on that note, let us quickly check out what a Python developer's resume looks like. Here is a very small sample resume that I picked up. So this person has pretty much worked as a junior Python developer at this company called as NRG from 1 year. She worked as a Python developer at this company called Morningstar in San Francisco.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts
The description pretty much says delivering projects with 1 or 2 days turnaround time or even within hours. So you need to have the ability to sit and code and finish a project having a less turnaround time. Designed and implemented the boot menu in 2-line displays in 3 weeks. So again, that is a very good achievement, probably in 3 weeks for this particular person. And then another Python ongoing job at Makerspace, made over 800 insertions, 150 deletions to 4 central framework repositories in less than 3 months. Took a position which combined 2 roles, Python developers and Scrum Master as well. Scrum Master for a team of 9 people. Introduced a new approach to submit render for layout and crowd department. I mean, this just should give you the overall picture of what a Python developer would do, right? So at the end of it, Python developer you need to be good with your time ability as well, guys. So how good are you at maintaining time? Because as you can see, usually the turnaround time for a Python developer is less, but then this depends on your organization as well. But you need to be good with time, you need to be good with code, you need to be good with working with a team, and that is a very important part of being a Python developer, guys. I mean, you can just check out pretty much you can just Google it out, a Python developer's resume, and you can pretty much go on to read what these people have actually done in their course at the particular firms, and it's staggering to see that the achievements of people can make even as junior Python developers or an experienced Python developer as well, guys. So on that note, coming to the next concept, pretty much you guys will be wondering by now, so what are the roles and responsibilities of a Python developer, right? I've broken it down to 3 important roles and responsibilities in this particular slide. And the first one is writing effective and scalable code, guys. Because as a beginner and an intermediate learner, you will be learning to just write code. It might not be efficient, it might not be scalable, but then just working more and more on it, doing projects on this, getting your hands dirty with code at a majority part of your time and learning will make sure that your code becomes effective and scalable. Because in an organization, in a huge organization which you pretty much will want a job in, will have a system which is already scaled, right? So you need to make sure that the tiny piece of code that you write will work across their spectrum of devices and networks as well. And the second most important roles and responsibility part is pretty much developing the backend components effectively.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Just as important as developing the front end is with respect to an organization, the back end is pretty much neglected, or for the common non-technical person, it is not seen, right? So it is an abstraction for the common user, but they will not know what's going on in the back end. But as a Python developer, you must be very good at developing good solutions for backend components and handling them very effectively and efficiently as well, guys. So coming to the third thing, it's pretty much integrating this particular backend with respect to the front end easily. So you need to know how you can go about with a merger with respect to all the backend, let's say databases, data storage units, and so much more. And you need to bring these together with your front end to integrate this well, guys. So these 3, I believe, are a very important role for a Python developer, and there are more as well. I mean, you can just go on to find many roles and responsibilities of a Python developer, but I think those 3 are the most important ones, guys. So coming to a Python developer's job description, here is an actual job description from Accenture. I picked this up from the website indeed.com, which is very famous for searching and hunting for new jobs. And this is their requirement, guys. They say that they require very strong quantitative and analytical skills, and they require 2 years of experience in data science as well. And this includes Python, R, Scala, Julia, or SAS. They require 2 years of implementing and delivering project in using CI/CD pipeline as well. So they require the continuous integration, continuous delivery pipelines here as well. And then they pretty much want you to have experience working with Git, Jenkins, Docker, Kubernetes, Kubeflow pipelines, and so much more. Again, 2 years experience in data science and using statistical methodologies. Well, this is the job description for a plain Python developer, guys. So look at the concepts that they pretty much ask you. You need to know Kubernetes, you need to know Python, you need to have worked with data science. Again, you will require some experience in machine learning methods, familiarity with clustering, regression, optimization, recommendation, neural networks, and other machine learning methodologies as well. Well, as I've been mentioned, mentioning, machine learning has been a big part in the world of Python, and then if you're strong in that, you can pretty much go on to hunt and get a really good job, guys. So here is another job description from this one's from Bank of America. Well, here they say you need to have exceptional development skills in Python on Unix, knowledge of agile development. Again, these guys need Scrum and Kanban and so much more as well. Solid object oriented design skills. OO is object oriented. With respect to distributed low latency, high availability systems, you need to have excellent problem solving capabilities, analytical skills in a high pressure environment. You must have a degree in computer science, physics, engineering, mathematics, or an analytical degree as well. A strong understanding of algorithms and data structures. See, I told you. And then a strong understanding of all the design patterns and why there has to be a pattern that needs to be used. Well, this responsibility, this role and responsibility again is exactly what we discussed a couple of slides ago, right? You need to give importance to data science. You need to have a degree in computer science. Well, again, this is debatable. If you do not, then you can pretty much get there. Because I personally know a couple of electrical engineers who had the interest to pretty much pick up computer science a decade ago, and now they are pretty much vice presidents of big companies, working with respect to Python, working with respect to C# and so much more, guys. So a degree is debatable, but then it would be really great if you actually have that. If not, you will need to work your way up the ladder of development, and you need to prove to people that you can pretty much handle the development job, guys. So coming to the next important thing in this particular video is the Python developer's salary, guys. So in America, in the United States of America, the average pay for a Python developer is somewhere around $95,000, guys. This is American dollars. And then throughout the world, let's say in India, it's about 10 lakh rupees per annum, which is again great if you are just starting out or if you're an intermediate developer. But then this is just the average pay, guys. So the pay lasts from somewhere around 6 lakhs all the way till 15 lakhs per annum for a Python developer, from a beginner to an intermediate scale. I mean, if you're an advanced developer, then you can pretty much get a bigger salary here as well. But the comparing the entire world's average, I mean Australia, Europe, London, and so much more, the average base pay per year comes down to somewhere around $92,000. It can go as low as 60,000 American dollars and as high as almost $140,000 per year, guys. So this is really good amount, and you can tap into these with all the potential that you guys have. And I've seen a couple of comments from learners. You guys are just unstoppable. So you can pretty much get here. You can get here really quick, but then you need to sell yourself well. And I believe that having a certification will.
Why you should learn Python. So basically, three simple facts are out there. First is that it is ranked third in the index of the popularity for programming languages. It is ranked third, and it tops the list given by IEEE Spectrum as the #1 language to learn. So in terms of popularity, as in the number of people who are using different programming languages, and there are a lot of programming languages with different company uses. So there are different companies who have created their own programming languages as well. So a lot of people work on those programming languages, like there's a programming language called ABAP, which is for SAP, where they do business-based programming. And then there is programming language called Apex for Salesforce. Then there is C++, C, Java, C#, and a lot of different languages which are out there. Among those, it ranks third in the popularity of languages which is being used. And it ranks #1 in the language that you should learn. So since it is very easy to learn, very easy to interact with, so easy to use, that's why it tops the list for being the #1 language that you should learn in order to begin your path in the programming field, if you will. And again, coming back to the point, the preferred domains like the data science, machine learning, and artificial intelligence, all inside of Python. And if you talk about it, even the web development, a lot of companies use Django for writing their backend. There also Python, that is a Python library which is again being used. Python there will also help you with that. So why we mention something data science again and again and again is, if you go about by the words of Harvard Business Review, which is given by Harvard, which is an extremely prestigious university, they claim that the data science is the sexiest job of the 21st century. It is the most highest paying job for people who are in the IT sector. So who are doing technical programming, data science is the field which will fetch you the most amount of money, and it has the highest average paid salary across the board, across all the different jobs that you might have. So there are business analysts, there are, let's say, program developers, there is system architects, there are a lot of different people. So in those, data scientists are the one who are paid more on an average than the others. So that is why learning Python is very important if you want to step in the field of data science. Okay, let's move along and talk about the different companies that you will be hiring. So if you see these companies on the screen right now: Facebook, Google, NASA, Quora, Amazon, Reddit, Instagram, Dropbox, Netflix is somewhere, it's an extremely good company if you are interested in data science. They do not pick anyone very easily because Netflix, again, the data science department is crazy good in there. So these are the dream companies of almost every programmer who is out there. They want to work for the tech giants like Google, Facebook, or Netflix, and going for these if you want to land a job in these places, Python is like a staple that you must have at the back of your hand if you want to apply to these companies and be there as may be as a very good developer for them. Then if you're looking along those lines, you must learn Python if you're looking at any of these companies, or NASA for that matter, because NASA again uses a lot of data science, and for that Python is very important. So with that, let's move along, talk about how you should go about your journey of learning Python, right? So there will be different stages. So the first stage would be where you are Jon Snow and you know nothing, and at that stage it's fine. And then you start off with a few basic concepts. You learn about a few different things here and there, and then you become an intermediate. And once you're an intermediate, you must be dedicated enough to learn a lot of different things, and that is then in where you try to specialize across different things in Python. So as I mentioned before, there's a lot of different ways to go about in your career in Python, and once you reach the stage 2 where you have experimented with a lot of different things, a lot of different libraries, a lot of different career paths, what it looks like to get in there, once you know what is that something which excites you most. Let's say if machine learning algorithms and programming and finding out data insights is something which is that something that you like, then you're looking to go inside the field of data science. But if you are someone who is very good at writing Django backend, then you are looking at someone who wants to go ahead and learn that with respect to that, and then you can go ahead and follow your passion in there. So whatever works for you, you can go there. Or for that matter, let's say if you start learning Python and you realize that there is some other way that you should go about in your career, then also I would say that Python is a very good place to enter this field. So if you want to learn basic programming concepts and if you want to understand how programming is done, Python is a good step to get inside of it, learn various concepts, various data structures, learn various algorithms through Python. And then if you feel like, okay, maybe I'd be someone who is better at working with, let's say, some BI tools like Salesforce, or if I'm someone who should pursue some other paths, but which will probably have some tool usage or something like that, or some other programming language for that matter, having those concepts in the bag by learning Python, because it is very easy to learn, having those oops concept in the bag will help you learn any other language also very quickly, because you understand how programming is being done, right? So that is about this developers map. So how we go about in steps would be like to decide first and foremost, why do you want to learn Python? A lot of people have this aspiration that they want to get inside of computer science and they want to do programming, they want to do a lot of different things. So decide why you want to learn Python. If it's just a time pass for you, is it something that you want to just finish your semester with, or is it something that you want to use to build a great career? So if you're looking to learn a great career, then you want to learn inside and learn various different concepts which are in there. So a lot of different basic programming things that you need to understand will be in there, which you have to start with. Once you have that, so now you know that, okay, I want to learn Python for, let's say, data science, right? Or I want to learn Python for learning Django. Then in those scenarios, you need to understand that you must have great material to study with. And what I mean by a great material is that something that starts from very basic. So a lot of different things like if-else concepts and different concepts like which will be there, which you want to understand inside of Python, and you have to work with those Python size dictionaries and lists and or whatever. So these concepts you have to get in the bag and first and foremost, and then you can maybe branch out of there. So find good material to study with, where you can understand how Python works, how programming works, how you write and structure the code is very important. And from there, we move on and enroll in an online training program for Python. So while learning, if you understand that, okay, I'm doing good now, it's time for me to step up my game. I want to do use Python into something where it is more useful. So enroll in some online Python certification course or any other certification course that you find which aligns with some kind of certification. Just enroll in there and learn Python in and out, because doing these will give you the hands-on practice problems and different things which will enable you to learn algorithms and different data science. And once you have that in the bag, read the official Python documentation. And this step is only recommended like if you are very interested in Python and you want to get deep inside of it, then you need to learn about the official documentation. You can go ahead and understand what the company is doing, sorry, what the programming language is doing, and you can get into the depth of things in there and understand how things are working. From there, what I want you to do is once you have Python in the bag, let's say you have an all-writing program, or if you have just aced Python in the bag, so you have Python in the bag, you understand how Python works. I'm gonna tell you honestly, just learning Python will not be enough. If you want to have a very lucrative career, then you have to learn about various different libraries inside of Python. You have to get this is somewhere you have to grind and you have to learn about the various different things. And for this, you can enroll into various different data science courses or machine learning courses and AI courses, and find out different libraries which are there inside of Python, like Django and etc. You should branch out and explore whatever different libraries are out there across different fields, and find the thing that interests you the most, right? So there's a lot of different fields out there, again, as I mentioned before, in Python itself. From there, you need to branch out and find out what is your passion, something doing what kind of programming makes you the happiest. So branch out from there and learn about these different libraries which are out there. And if you have let's say programming languages, then look into the I say this again and again, watching and learning through Python, you need to look at different source codes which are available out there. So there's a lot of free open source materials, free open source programming programs which are out there present with their source code for Python programs. Just look into it, what people are doing, how people are programming, learn about it, and think about your own project problems, and then solve those projects through, let's say, it might be an artificial intelligence project where you recognize a guy's eye opening or closing, or if you want to recognize if that is an apple or an orange. It could be anything. So you just start learning through these different things and writing Python programs for them, and just find out what your passion is. And looking through the programming of different people will help you understand what is the industry standard and how clever people can be when they want to write code. So there are people who are extremely clever at writing code. Their code will be very efficient. By efficient, I mean 2-3 different things. I mean that their big O of n, which is with respect to the time complexity. So what is the time complexity that their code is taking? So the code will not take that much of a time. And then like let's say if you want to do one simple thing of, let's say, going across and reading different elements in array and finding a match, you can do it in different ways, right? So even if I can do it in various different kinds of ways. Some ways will require more time than the others, and finding that way which will take the least amount of time, and being that clever, being that cheeky, you get that when you see a lot of different kinds of codes that people have written, and you get a zest of different things, and then you start applying it yourself. So for that, it's very important that you explore different source codes which are present out there, so that you get a zest of things, right? So for that is there. So next point is, what makes a good Python developer? Again, any good Python developer or any good C++ developer or any good developer for that matter will have this same skill set. They will be the people who are excellent at problem solving. These people are excellent at problem solving, and this, you're not someone who has to be it's like not a god-given talent like problem solving. You get problem solving through practice. So you see n number of problems and you understand that n number of solutions. So you see, let's say, n+1 problem. You have now n plus solutions that you can combine or mismatch and find out, okay, this might belong to this kind of problem, and this is how it is being solved. So having that knack will only come from let's say a lot of practice, a lot of work on it, and a lot of seeing a lot of different problems. So having that problem solving mindset is very important. Then you have then there is a lot of people who have n number of solutions, right? So they see a problem, they have the solution, but having strong technical skills to implement that solutions in a very efficient manner is a whole new department, right? Even in computer science department, you'll see a lot of different people who are very good at problem solving, but they do not have that technical skills, or they do not have the knowledge about how it can be done in the most efficient way, and that's why their code maybe does not perform up to the level of their solution that they thought of. So implementing that solution to the level of the solution that you thought of is also very important when it comes to programming, and having strong technical skills can help you with that. Then you have to have good communication skills. This goes up across every job description which you find out, that strong communication skills is very important. That's why it's very important that you communicate across the board, because you may have a lot of good ideas, but you need to communicate that across the people. What you have done, what you are doing, and how it is better from the previous version, that has to be communicated, and that comes through strong communication skills. And finally, there is this eagerness to learn. So it goes without saying that, as I mentioned before, a lot of people learn Python and then they have to branch out, because there's so many libraries that you have to learn. And if you don't have the eagerness to learn these different libraries, then I'd say it's not worth it for you. So if you have that eagerness to learn, and if you have that knack for programming, and if you have that satisfaction of seeing your code run properly, then it is something that you should consider building your career in. Now, what next? So let's say we are at a stage now where we have, let's say, done the Python course. We understand Python, we have a Python certification as well, and I started seeing it across various different libraries. I know, let's say, 5-10 libraries by now. So what should I do now? The next step would be do as many projects as you can. So the only thing that will help your resume, apart from certifications or publications or a good work experience, is your projects, especially for people who are freshers. Any job interview that you go, you will be grilled on the projects that you have done, and do as many good projects as you can, because these projects basically, why, if you ask yourself, why would many interviewer ask you about your projects if you have done it? So having a project basically gives them a problem statement, and how you solve that using your programming language is a great solution, and it gives an insight of how much depth you have in the understanding of the programming language, and how good your problem solving skills is. So it gives you both of that in the same place, and they can grill you about the technical aspect of things, so that they can understand uh, how much depth you have in the programming language fundamentals. And some of the good projects to start with is here mentioned on my screen. So if you're interested, you can go for Twitter sentiment analysis using Python. Then there is Hangman game. You can make a lot of different kinds of game. You can make the snake game and different games which are out there, which you can start as mini projects. But as you move along and learn different libraries, you make more complex projects, make more better projects, which will basically help you enhance your resume and land you those better jobs tomorrow.
First, we'll see about Python. So Python is a high level interpreted and interactive language that is used in various fields of development. So it is also an object oriented and a scripting language that is designed to be highly readable, and it uses English keywords frequently, whereas other languages uses punctuation, and also it has a fewer syntactical construction than other languages. So Python is a must for any working professional to become a great software engineer, especially when they are working in the field of various fields like web development, data science, machine learning, artificial intelligence, and big data. So the features that makes Python unique is easy to code. It is a very simple language that anyone can learn very easily, and it is also free and open source. Then it is an object oriented programming language, so it supports object oriented style or technique of programming that encapsulates code within objects. So it is also Python also supports GUI applications that can be created and ported to many system calls, libraries, and Windows systems such as Windows MFC, Macintosh, and the X Window systems of Unix. So it is also a high level programming language. It is extensible, that you can add low level modules to the Python interpreter, and the modules enable programmers to add to or customize their tools to be more efficient. So this extensible features makes it more unique for the use in various development tasks. Then it is a portable language, and that can run on a wide variety of hardware platforms and has the same interface on all the platforms. Then comes integrated language, so it can integrate various other applications and technologies. Then Python is an interpreted language. So Python is processed at runtime by the interpreter, and you do not need to compile your program before executing it. And this is similar to the programming languages such as Perl and PHP. Also, it has a large standard library which makes the development in the various fields such as web development, desktop application development, software development, data science, big data, machine learning, and artificial intelligence. And finally, it has a large standard library. So there are various libraries and packages which helps in the field of web development, desktop application development, data science, big data, machine learning, and artificial intelligence. So these features makes Python a very unique programming language for development, and it is widely used across the industries, and there are top multinational companies who uses Python for their development tasks. Now moving on to the next part, that is R programming language. So R is a programming language in software environment used for statistical analysis and graphics representation and reporting. So R is freely available and it is an open source programming language. So the core of R is an interpreted computer language which allows branching and looping as well as modular programming using functions. So R also allows integration with procedures written in the programming languages such as C, C++, .NET, Python, or Fortran languages. So there are various features of R programming language. So it starts with open source, then it is a comprehensive language. It has a wide array of packages that is used in the statistical analysis. Then it has various graphical libraries that are used in data visualization tasks. So the task of data visualization can be handled using R programming very efficiently. Then it does not need any compiler for compiling its codes. It also performs fast calculations. And the next feature is integration with other technologies. So it can very efficiently integrate with other technologies to develop software applications. And then cross platform compatibility, that is R is platform independent. It can run on any hardware or more than one hardware or operating systems. So R is a well defined and simple effective programming language which includes conditionals, loops, and user defined recursive functions and input output facilities. It has an effective data handling and storage facility. Also, R provides a suite of operations for calculations that helps in the analysis and visualizations of the data. And R provides various graphical facilities and libraries for data analysis that you already know. So as a conclusion, R is world's most widely used statistical programming language, and it's the number one choice of data scientists, statisticians, and researchers that who works on data. It is supported by a vibrant and talented community of various contributors. Now we will move on to another programming language, that is SAS. So it stands for Statistical Analysis Software. Going to the definition or detail, SAS is a software suite that can mine, alter, manage, and retrieve data from a variety of sources and perform statistical analysis on it. And SAS provides a graphical point and click user interface for non-technical users. So it allows for data to be read from databases and spreadsheets from various statistical analysis. So SAS is a leader in business analytics. Through innovative analytics, it caters to business intelligence and data management. So it gives various software and services for business analytics. SAS transforms data into insight which can give a fresh perspective on business. So unlike other BI tools available in the market, SAS takes an extensive programming approach to data transformation and analysis rather than a pure drag and drop and connect approach. This makes it stand out from the crowd as it gives much finer control over data manipulation. And SaaS has a very large number of components customized for specific industries and data analysis tasks. Also, SAS is a platform independent programming language, which means you can run SAS on any operating system, either Linux or Windows. Now, let us look at some of the features of SAS. So, it helps in strong data analysis, it is highly flexible, it helps in efficient data management, support data encryption algorithms, support various types of data format. So we have SAS Studio where we can implement the queries or codes of using SAS programming for data analytics. Then finally, it has a report output format that we can get. Now we'll move on to the next part, that is fields of usage for these programming languages. So talking about Python, it is widely used for various sectors or various development fields such as web development, desktop application development. It is used for GUIs, it is used for game development, big data analytics, data science, machine learning, and deep learning. Python has a wide set of libraries used in various development fields. So for web development, it uses Django, Flask, and for GUI, it uses tkinter. For game development, it uses Pygame, and in big data, data science, machine learning, and deep learning, there are various libraries such as Pandas, scikit-learn, SkyPy, NumPy, TensorFlow, Keras, Caffe. So there are n number of libraries Python has to develop various applications. Now talking about R programming, so it is basically used for data mining, data analysis, data visualization, and it is also used for building predictive models in data science, machine learning. And the main purpose of using R programming is statistical computing. It is mainly used by industries or organizations to analyze the data, to visualize the data, and draw some meaningful insights from it by using statistical computing. So, this is the sole purpose of using R programming. So, it also has a rich set of libraries that helps us in performing various techniques of data mining, analysis, and visualization. Now, moving on to the next part, that is SAS programming. SAS, that is statistical analysis software, it is used to output the statistical analysis in the form of tables and graphs, which is processed from spreadsheets and databases. The significant use of SAS is in the financial analytics. So it offers the full range of statistical functions and also provides the best GUI for data analytics application deployment. So it is used in advanced analytics, data management, business intelligence, and predictive analytics. So SAS is preferred over Python and R when the organizations need to analyze and visualize their financial data, and which needs confidentiality. So that is why SAS is a very expensive software. Now we will look at the applications of Python, R, and SAS. So starting with Python programming, so it has various applications. So Amazon, Twitter, Flipkart, YouTube, Google, Facebook, and there are many more Fortune 500 companies who uses Python programming for developing their robust softwares. So talking about Amazon, so it uses Python for their recommendation engines. There are various libraries and packages in Python which helps in developing machine learning algorithms that runs the recommendation engine. And same is the case with Flipkart. It uses recommendation engine, which again involves the usage of Python programming. Then talking about Twitter, so it uses Python for analyzing and text analysis for the users. So same is the case with YouTube. It analyzes its data of customers. And then talking about Google, so there are various applications of Python, and Google uses Python for implementing natural language processing, for implementing its text analysis, optimizing the search results of the website. Then same is the case with Facebook. Now moving on to the applications of R programming. So here are the companies, that is Gartner, Deloitte, Genpact, Ford, McKinsey, and Facebook, Google again, then Zalando, which is again an e-commerce website, and Paytm. So they uses R programming for analyzing and visualizing their business data and implementing machine learning algorithms to make predictive models.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Then coming to SaaS programming, here are the companies, that is Amazon, Netflix, YouTube, Twitter, Fractal, Cognizant, HP, Citibank, Dell, and it also consists of various other Fortune 500 companies, that is Google, Tesla. So these all uses SaaS programming for their business analytics. So there are a very few companies who uses SaaS for their business intelligence tasks, and not all companies can afford SaaS programming because it is a very expensive tool to use for their organization. Now moving on to the next part, that is support and community for these programming languages. So starting with Python, so it is an open source programming language and it provides no customer service. So you have to search for your doubts and queries in Google. But it has a very large community of Python developers who are from various fields such as web development, they can be data scientists, machine learning engineer, data analyst, big data engineers, game developers, and many others. So it has a very large community that can help you out in solving your queries. Now moving on to R programming. So again, it is an open source and free tool, and it does not provide any customer service, and it has a large community that can help you out to solve your queries, your doubts, and various R professionals who are expert in R programming and working can help you out in various data analytics tasks that you need to perform. Now coming to SaaS, so it provides a 24/7 customer service as it is a paid tool and it is a very expensive tool to use. So it has a very good customer service. So you can clear all your doubts, and there is also SaaS community that can help you out if you are stuck in a particular problem. Now let us move on to the final part of this video, that is job scope for these programming languages. So starting with Python and talking about number of jobs. So according to Forbes, in India there are 15,000 plus job available for Python developer in 2020, and in the United States the number of jobs are more than 50,000. So it is a very big number, and there are a plethora of opportunities for a Python developer. Talking about salary, so the average salary in India is 7,25,000, and in USA it is $1,15,500. Then moving on to the R programming. So number of jobs for R programming according to Indeed.com. In India there are 2,500 jobs available for R professional in 2020, and in the United States the number of jobs are close to 8,000. The average salary for R professional in India is close to 6,53,000 per year, and in the United States it is close to $1,05,000 per year. Now moving on to the next part, that is SaaS programming. So number of jobs according to Naukri.com. In India there are 1245 jobs available for a SaaS programmer in 2020, and as per the stats from Glassdoor, for SaaS programmer there are 4518 openings in the United States, and the average salary for SaaS programmer is close to 5,40,000 rupees per year in India, and in the United States it is $1,10,000. Now for choosing a career option, if you are into financial analytics, then you should go for SaaS programming, And for getting into the field of web development, data science, big data, artificial intelligence, machine learning, and development of games, you should definitely go for Python, as it is a widely used programming language and it has a plethora of job opportunities with a very good salary. So you must go with Python. Now, if you want to get into the field of data analytics, then you should go with R. So you can see over here in the left hand side there is a Java code. So it prints hello world, and at the right hand side you can see a Python code that prints hello world. So you can see the difference in the length of the code in these two programming languages. So Python just uses a single line of statement using a print keyword to print hello world, and in Java you have to make a class and use various methods. So Python is extremely simple and it is popular due to, so while building robust or complex softwares, it requires a lot of effort and lengthy codes using other programming languages as compared to Python. So basically Python is popular due to its simplicity. So the features that makes it popular is expressive. So it is a very expressive kind of language. It is understandable, easily understandable and readable. Then it offers an easy to understand syntax, simple setup, and has many practical applications in various development processes. And the syntax isn't too annoying compared to other programming languages. And you can import a bunch of modules which can often make your code much shorter. So this is due to its simplicity. So the next thing is, it is an open source programming language. So in simple terms, you can freely distribute copies of this software and read the software's code, make changes to it, use pieces of it in new free programs, and that you can do these things. Now the next thing is, it is open source. So in simple terms, you can freely distribute copies of this software, read the software's source code, make changes to it, use pieces of it in new free programs, and this makes it open source and free for all. Now the next point is, it is object oriented programming language. So the Python supports object oriented features, and compared with other programming languages, Python's class mechanism adds classes with a minimum of new syntax and semantics, and it is a mixture of the class mechanisms found in C++. So Python classes provide all the standard features of object-oriented programming language except strong encapsulation, which is only one of many features associated with the terms object-oriented. Now, Python is also an interpreted language. That means interpreter executes the code line by line at a time. So when you see an interpreted language like Python, there is no separate compilation and execution steps. You just run the program from the source code, and this makes debugging in Python easy, and thus it is very much suitable for beginners. So internally, Python converts the source code into an intermediate form that is called bytecodes, that you might have heard of, and then translates this into the native language of your specific computer and finally runs it. So you just need to run your programs and you never have to worry about linking and loading with libraries and so on. So this makes it, now finally it is also a cross-platform language, and Python can run equally on different platforms such as Windows, Linux, Unix, Macintosh, and so on. A Python program written on a Macintosh computer will run on a Linux system and maybe for others. So thus this makes it a portable language. So it is a cross-platform language. Now let's move on to the next part. So Python is portable and extensible. So this feature allows Python, so Python's extensibility feature, so Python's extensibility features allows us to write some Python code into C or C++ language, and also we can compile that code in C or C++ language. And it is also portable, and Python language is portable, which makes it so if you have a Python code for Windows and if you want to run this code on other platforms such as Linux, Unix and Mac, then we do not need to change it. We can run this code on any platform. So this makes it portable, and it is very useful for building software applications. Now we'll move on to the next point, that is, it is used in web development.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So Python can be used to build server-side web applications, and Python actually is not used in a web browser, but the language executed in the web browsers will be JavaScript, and then the projects are compiled from Python to JavaScript. So the web applications always uses a combination of Python as well as JavaScript to build an application. So the combination of both JavaScript and Python are used to build web applications, where Python is executed on the server side while JavaScript is downloaded to the client and run by the web browser. So there are various frameworks such as Pylaunch, Django, Flask, Web2Py that are used for web development. So starting with Pylaunch, it aims to make web development fast, flexible and easy. And then now if we talk about Django, so it is again an open source and free web application framework that is written in Python, and this framework provides a collection of modules that makes development easier, and also it provides the features that helps in rapid development and clean and pragmatic design of code. Then comes Flask, which is a micro web framework which is also written in Python, and it is classified as a micro framework because it does not require particular tools or libraries to execute. It also supports extensions that can add application features as if they were implemented in Flask itself. Then is Web2Py, and it is also an open source web application framework, again written in Python programming language and designed to help to reduce tedious web application tasks such as developing web from scratch. So this is the use of Web2Py. So there are various frameworks that gives us the benefit of developing Python web applications rapidly and with efficiency. Now let's move on to the next part, which is Python is used in computer graphics and game development. So there are also various frameworks, that is Pygame, Tkinter, WXPython, Jython, which is used for computer graphics and game development. So it is also used to Python is also used to develop desktop applications, beautiful GUIs. So it can be made using modules such as PyQt5, PyQt4, WXPython or Tkinter. Also, PyQt5 is the most popular option for creating graphical apps with Python. Now the next one is Python is used for software testing. So it consists of various frameworks that can be used for testing of softwares. Now there are various frameworks that are used in Python for testing, and it starts with PyTest, Testify, Unit Test, Nose, and Mimesis. So let's check in detail for what type of testing these frameworks are used. So starting with PyTest, it is a testing framework which allows us to write test codes using Python, and you can write code to test anything like database, API, and even you can check UI if you want. So, but PyTest is mainly being used in the industry to write tests for APIs. Now the next one is Testify. That is a replacement for Python's unit test module and Nose. So it is modeled after unit test, and tests written for unit test will run under Testify with a minimum number of adjustments, but it has features above and beyond unit test. And so basically it is the advanced version of unit test. Now checking with unit test. So unit testing is the first level of software testing where the smallest testable parts of a software are tested. So this is used to validate that each unit of the software performs as it is designed to do so. So the unit test frameworks in Pythons are like XUnit style framework, which provides the benefit of checking each and every unit of the software. And then comes nose, that is a testing framework again, and it collects tests from the unit test and also supplies a number of helpful functions for writing time tests, testing for exceptions and other common use cases. Then comes Mimesis, which is also a package for Python which helps generate big volumes of fake data for a variety of purposes, like using it for testing database or populating a testing database, creating beautiful JSON and XML files. So this is the use of Mimesis. So you can see over here that there are various testing frameworks that helps in automated testings and supports easy debugging using Python language. Now let's move on to the next one, which is Python is used in big data. So again, there are frameworks like PySpark, PyDoop, and Dask, which helps in processing big data. So basically, Python and big data are the perfect fit when there is a need for integration between data analysis and web apps or maybe statistical code with the production database. So Python helps in big data analytics, and various Python frameworks helps in writing codes for data analysis. Also, Python provides advanced support for image and voice data. So talking about frameworks, so it is PySpark framework used by big data. So first of all, talking about Apache Spark, that is an open source and it is one of the most popular big data frameworks that is used for scaling up the task in a cluster. So the Spark Python API exposes the Spark programming model to Python. Then comes PyDoop, that offers MapReduce API for solving complex problems with minimum programming efforts. After that comes Dask, which is popularly known as Python Parallel Computing Library. And through its parallel computing features, it allows rapid and efficient scaling of computation. And it also provides an easy way to handle large and big data in Python with minimum extra effort. Now let's move on to the next one, which is data science. So Python is widely used in data science. So there are various libraries such as Matplotlib, scikit-learn, pandas, seaborn, scipy, numpy, and there are thousands of libraries that is used by data science, and it mainly deals with data exploration, manipulation, visualization, and descriptive analytics, and even creating machine learning algorithms. So starting with Matplotlib, it is a plotting library for the Python programming language, and its numerical mathematics extension is numpy. Also, it provides an object-oriented API for embedding plots into applications using general-purpose GUI, like the general-purpose GUI toolkits like they are tkinter, Qt, or WXPython that we already discussed in this previous section of this session. Now, the next one is scikit-learn. So the scikit-learn is probably the most useful library for machine learning in Python, and it is also used for data analysis or data visualization in data science. Now coming to pandas, it is again a software library in computer programming and written for Python programming language. So they are used in Python to deal with data analysis and manipulation tasks. So to put it in a simpler words, pandas help us to organize data and manipulate the data by putting it in a tabular form. After that, seaborn, that is used for statistical data visualization, and it is a Python data visualization library that is based on Matplotlib. So it provides a high level interface for drawing attractive and informative statistical graphics. Then comes scipy, that is an open source Python library that is used to solve scientific and mathematical problems, and it is also built on top of numpy extensions and allows the user to manipulate and visualize the data. So the reason for telling all the details about these Python frameworks is that you get to know about the specific libraries that are used in specific technologies such as data science, machine learning, big data, artificial intelligence, web development, game development, for getting into these fields as a Python developer. So that is the sole purpose of discussing about these libraries as well. Now let's move on to the next part, that is machine learning. So Python supports machine learning software frameworks. So basically Python helps in implementing machine learning algorithms. So here are few of the frameworks to implement machine learning algorithms that are on Python, and it starts with accord.net. So it contains algorithms that perform vision processing, and they are usually used for the task like facial detection, image integration, and tracking moving objects. So after that comes Apache Spark. So it is an open source, also general purpose distributed computing engine that is used for processing and analyzing a large amount of data. So basically Apache Spark is written in Scala programming, and that compiles the program code into bytecode for the JVM. Then the open source for processing of large amounts of data. Then comes SkyPy, which is again a library, Python library used for scientific computation and performing mathematical operations. After that, Caffe, which is a deep learning framework developed by Berkeley Vision, and it is written in C++ and has Python and Matlab bindings. So it is used in integration with machine learning and deep learning. So we'll go to the next part, that is artificial intelligence. So artificial intelligence is one of the where Python is used extensively to build AI based software. So it does so by using various libraries, that is TensorFlow, Pandas, PyTorch, NumPy, Keras, and there are various other libraries that we come across for building various AI based softwares. So starting with TensorFlow, that is one of the popular libraries of AI. So it is a Python library and it is used for fast numerical computing and created and released by Google. So it is a foundation library that can be used to create deep learning models, or it can be used by wrapping libraries that simplify the process built on top of the TensorFlow framework. Then comes Pandas, that is used for data manipulation and visualization tasks. After that, PyTorch, that is native Python package, and that provides a complete end-to-end research framework mainly used for research in deep learning field. After that, NumPy, that is a Python package mainly used for scientific computing. And then Keras, that is a powerful and easy to use open source tool for developing and evaluating deep learning models. Now moving on to the final point of discussion, that is career opportunities and salaries. So we can see various Fortune 500 companies such as Amazon, Google, YouTube, Facebook, Twitter, and Flipkart that are using various AI based technologies, machine learning, data science, big data to enhance their business. So Amazon uses data science to build their recommendation system. Google uses NLP, deep learning, AI, machine learning, data science for voice recognition system, Google Maps, and for search optimization. Then YouTube uses data science to provide their customers a better personalized experience, and so on. Facebook, Twitter, Flipkart uses these technologies. So all these technologies uses Python libraries to implement and to make their product a better version of before. So this wide acceptability of Python makes it one of the popular language in the industry. And due to this, the job scope and career opportunities for a Python developer is rising day by day, and it is very high in comparison to other job profiles. Talking about job profiles, so these are the popular job profiles that are posted by the employers in various job portals. So starting with Python developer, then Django developer, web developer, software developer. After that, data analyst, data scientist, ML engineer, and AI engineer. Now discussing about the salary of Python developer. So the average salary in India is rupees 835k per annum, and in US it is 125k dollar per annum. So it is a very awesome package to start your career with as a Python developer.
So now that we know how popular Python is, let's head on to our interview questions. Right, so this is our first question. What are keywords in Python? So you can consider these keywords to be special reserved words which exist for a specific purpose. Now you cannot use a keyword name as a variable name or an identifier. So these are some of the keywords which exist in Python, such as true, false, not, continue, and so on. And in total, there are 33 keywords in Python 3.7. Now you also need to keep in mind that these keywords are case sensitive. That is, if you look at the keyword true over here, then you see that T needs to be capital. So our next question is, what are literals in Python? And then we'll have to explain about the different types of literals. So literals are the constants used in Python. Or in other words, this is the data which is stored in a variable. And there are 4 types of literals in Python. So we have string literals, numeric literals, boolean literals, and special literals. So let's look at string literals. So you can create string literals by just enclosing the text within quotes. So here we have created 2 string literals, John and James. So we see that John is enclosed double quotes and James is enclosed within single quote. So this is how you can create string literals. Next up, we have numeric literals. So numeric literals comprise of all of your digits. Now if your numeric literal doesn't contain any decimal, then it is of the integer type. And if your integer is too long, then it would be of the long type. And if your literal consists of a decimal point, then it would be a float. And finally, we have a complex number which consists of a real part and an imaginary part. Going ahead, we have Boolean literals. So these Boolean literals comprise of just true and false values. They are generally used when we are dealing with some condition whose output is either true or false. Now we'll head on to special literal. So Python consists of this special literal called as none, and it is used to specify a field that is not created. Here in this example, I have assigned none to the variable val2. So this variable would basically be empty. So this is our third question. What is a dictionary in Python? And we'd also have to create a dictionary where the key is fruit name and there are 4 fruit names as values. So a dictionary is an unordered collection of elements, and these elements in a dictionary are stored as key value pairs. For example, here we have a dictionary with the name my dictionary and we have 3 key value pairs. So here our first key is 1 and the value for this key is John. Second key is 2 and the value for this key is Bob. And then we have the final key which is 3 and the value for this is Alice. Right, now let's head on to Jupyter Notebook and create our own dictionary where the key is fruit name and the values would be 4 fruit names. So I'll name the dictionary as my dictionary and we can create a dictionary with the help of these curly braces over here. So I'll give in the key name which would be fruit name, and after this I'd have to give in values of 4 fruit names. So let's say my first fruit is apple, and then the second fruit is mango, third fruit would be orange, and the fourth fruit would be guava.
Just a quick info guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Now all I have to do is hit on run and then let me print this out. So I'll just type in my dictionary over here. Right, so we have created a dictionary with the name my dictionary where the key is fruit name and the values are apple, mango, orange and guava. And if you want to extract the individual key and individual values, this is how we can do it. Now I'll type in the name of the dictionary which is my dictionary. I'll put in dot and then I'll just type in keys. I'll click on run. And we see that the key for this dictionary is fruit name. Similarly, if I want all of the values, I just have to type in values over here. Now let me click on run. So for this dictionary, the values are apple, mango, orange and guava. So our next question, what are classes and objects in Python? So simply put, you can consider a class to be a blueprint and objects to be real world entities which are defined and created from classes. For example, over here you can see the actual blueprint of a house. Now, this blueprint can be used for the rapid creation of unlimited number of copies. So these copies of the blueprint are nothing but your objects. And here we have created 3 houses, or in other words, 3 objects from the original blueprint, which is our class. So I'm repeating it. So our class is nothing but a blueprint, and from this blueprint, we'll be creating a set of objects which are our real world entities. So over here, this house number 1, house number 2, and house number 3 are our real world entities, which are nothing but objects created from this class. Next, we'd have to create a simple class with the name human, which would give out the name and age of the person. So let's do this. Right, so to create a class, I'd have to use the keyword class, and then I will give in the name of the class, which would be human. Now inside this, I will create 2 variables. So the first variable would be name, and initially I'll just assign none to it. And my second variable would be age. Again, I'll assign none to it. So we have created our variables. Now we'd have to get the value of name and the value of age from the user. So for this, I'd have to create some definitions or methods. And to create a definition, I'll use def. After this, I will give in the name of the method, which would be getName. And inside this, I will pass in self. Right. So now over here, I'll just use the print function and type in enter your name. And after this, I will get the name and the self.name. So basically self.name basically means that whatever value the user enters, it would be stored in this name variable of the object. Right. And I'll just type in input over here. So this input function is used so that we can get a value from the keyboard. Right. So this is how we can get the name of the person. Now similarly, let's go ahead and get the age of the person. So I'll type in def and I'll name this method to be getAge. Again, I'll pass in self inside this. Right. This time I'll use print and I'd have to enter the age. So enter your age, and then I'll store this in self.age equals input again. Right. So we have created 2 get methods where we'll be getting the name and the age of the user. Now after this, we'd have to print out the name and the age. So it'll be def and I'll create the method to be put name. Again, this will be self and I'll just print out the user's name. So your name is self.name, and then similarly, I'll create another method which would be put. Methods would help me to print the name and age of the person. Right, I'll click on run. So we have created this class. Now once we create our class, which is basically our blueprint, we'd have to create the objects from this class. So let's say I create an object and name that object to be person1. Now this would be our first instance and I just have to call in human. So I'm creating a person instance of the human class. Now from this person object, I will invoke the getName and getAge methods. So person1 dot getName. Let me click on run. I'd have to enter the name of the person. Let's say the name of the person is Sam. Right. So now it's time to get the age of the person. So I'll type in person1 dot getAge. I'll click on run. And let's say the age of the person is 28. So now I have successfully fed in the name of the person and the age of the person. Now it's time to print out both of those. So it'll be person1 dot put age and person1 dot put name. So person1 dot put name. Right. So your age is 28 and your name is Sam. Right. So we have successfully created our class which would print out the name of the person and the age of the person. Right. So next question. What do you understand by the init method in Python? And after that, we'd have to give an example of it. So you can just consider the init method to be a sort of constructor in Python. So it is a special method in a Python class which is used to initialize the variables. So now that we've understood what init method is and what it is used for, let's go ahead and work with this init method. So now over here, what I'm going to do is create a student class with the init method in it. So let me do that. Class student, and over here, I'll just create the init method, and these are the parameters of this init method self. So, and after this, it'll take in the name of the person and after name it'll take in the age of the person, and after this it'll take in the branch of the person. Right. Now what I have to do is just store these values inside the original variables. So that'll be self.name equals name, and then our next variable is age, so self.age equals age, and then we have the final variable which is branch, so it would be self.branch equals branch. So we have created our init method. Now after this, wait, so we actually have to put in def over here because this is actually a method, right? So we have created our init method, which is basically a constructor, and going ahead we'll just create another method which would help us to print all of these values. Def print student, and I'll take in self, and all I do over here is print in all of these values. So print of name would be self.name. After this we have age, so let me change this to be age over here, and this would be self.age. After this we'll have to print in the branch, so let me just put in branch over here, and this would be self.branch. Right, so we have created the student class which has the constructor. I'll click on run. Now let me create an object of the student class. I'll name the object to be student1, and let me go ahead and create an instance of this. Now since we have this constructor over here, so I can go ahead and initialize the student object here itself. So I'll give in the name of the student. So let's say the name of the student is Bob. After this, the age of the student is 12, and then which branch is he studying? So let's say this guy is studying engineering. Let me just put in engineering over here. Run. Now student1 dot, I will call in the print student method over here. Right, so we have successfully created this instance student1. Right, so what do you understand by inheritance in Python? And then we'd have to give an example of it. So inheritance refers to the property of one class acquiring the properties of another class. For example, let's say you have inherited your features or properties from your parents. So if you see over this family tree over here, you can understand that traits such as hair color and poor eyesight are passed from one generation to the next generation. So over here, this is generation 1, generation 2 and grandparents. So your parents are inheriting their traits or their features from their grandparents, and you are inheriting your traits from your parents. Now let's go ahead to Jupyter Notebook and work with an example of inheritance. So here what we are doing is we have a base class with the name fruit, and this base class is being inherited by another class, citrus. Now this is our base class fruit, which has a constructor, and this constructor just prints out I am a fruit. Now after this, what we are doing is we are creating another class with the name citrus, and this class inherits from the fruit class, right? So if a class has to inherit another class in Python, we'll just give the name of the base class as a parenthesis inside our new class. Now again, inside the citrus class, we have created another constructor, and inside the constructor of the citrus class, I am using the super method. So with the help of super method, I can invoke the variables and functions from my super class, right? So over here, I want the init method from my super class. So I'll just use the super method, and I'm invoking the init method from this fruit class. Now, apart from this init method from the fruit class, I would also print something else. So over here, I am also printing I'm citrus over here, right? And I'll create an instance of this class citrus, and I'll store it as lemon. Now the result is I'm a fruit, I'm citrus. So this value I'm a fruit is coming from the super class, and this value I'm citrus is coming from our new class or the child class. So this is how we can do single level inheritance in Python. So next, so what is numpy and how can you create a basic 1D and 2D numpy array? Well, numpy is the most widely used Python library for linear algebra, and it is used for performing mathematical and logical operations on arrays. And to import the numpy library in Python, you just have to use the command import numpy. So again, let's head to Jupyter Notebook and create a 1D numpy array and a 2D numpy array. So I'll start off by typing import numpy as np. After this, I'll create my 1D numpy array. So a equals np dot array. Now I will give in a list of values. So this is my 1D array a, and then let me just print it out. So this is my 1D array which comprises of the values 1, 2 and 3. Now I'll go ahead and create a 2D array with the name b. So again, the syntax would be the same, np dot array. So it'll basically comprise of a list of lists. So the first list would comprise of 1, 2 and 3, and the second list would comprise of 4, 5 and 6. Let me print this out. Right, so this is our 2D array which comprises of 1, 2, 3, 4, 5 and 6. So this time we'd have to initialize a 5 cross 5 numpy array comprising of all the zeros. So there's a 5 cross 5 numpy array, that is there need to be 5 rows, 5 columns and all of the values need to be 0. And to initialize an array with all zeros, we can just use np.zeros method from the numpy library. Let me just type in import numpy as np, and inside a I'll just state np.zeros, and I'd have to give in the dimensions of this array. So the dimensions of this array are 5 cross 5. Let me just print out a. So we have successfully created our 5 cross 5 numpy array where all of the values are just zeros. Now let's say we have two numpy arrays like this. So this is our first numpy array, this is our second numpy array. First numpy array comprises of 1, 2 and 3. Second numpy array comprises of 4, 5 and 6. Now I'd have to add the individual elements. So 4 plus 1 needs to become 5, 5 plus 2 needs to become 7 and 6 plus 3 needs to become 9. Again, our first step would be very simple. I'd have to load the numpy library, import numpy as np. I will go ahead and create my first numpy array, a equals np.array, and the values are 1, 2 and 3. Similarly, I'll create my second numpy array which is b. I'll change this variable to be equal to b and the values are 4, 5 and 6. Now to add the individual elements, I'd have to use the np.sum method. Now inside this, I'd have to give in my first parameter. So my first parameter would be the numpy arrays which I'd have to add. So I want to add a and b, and I will set the axis to be equal to 0. So when I set the axis value to be equal to 0, this would individually add the elements. So this will do 4 plus 1, 5 plus 2 and 6 plus 3. Right, and this is what we have. 4 plus 1 is 5, 5 plus 2 is 7 and 6 plus 3 is 9. Now let me actually change the axis value to be 1 and let's see what do we get. Right, so when I change the axis value to be 1, then the addition happens across the row. So when you do 3 plus 2 plus 1, you get 6, and when you do 6 plus 4 plus 5, you get 15. So now we'd have to get the n largest values from a numpy array. So this is our numpy array over here, and this comprises of 1, 2, 3, 4, 5, 6, 7 elements, 12, 43, 200, 54, 5 and 68. And I'd have to get the first two largest values, which over here are 100 and 68. Now let's go to Jupyter Notebook and let's see how can we do this. Right, so again we'll start off by importing the numpy array, import numpy as np, and I'll create this array. X is equal to np.array, and I'll give in all of these values. Now to get the indices of values which are arranged in ascending order, we can use the np.argsort function. Now what I'll do is I'll actually insert a cell below, and I'll go ahead, I'll do Ctrl X, I'll do Ctrl V. So we have successfully created our numpy array. Let me just print in X over here. So this is our numpy array. Now what I'll do is I'll just copy this np.argsort of X and I will print it over here, and let's see what do we get. So what we get over here are index values. So 0, 1, 2, right? 0, 1, 2, this is our lowest value. And then we have 5, so element at index number 5. 0, 1, 2, 3, 4, 5, right? 2, 5, and then we have 0, which is 12, and then we have 43, right? So we basically have the indices of the values arranged in ascending order. So 2, 5, 12, 43, 54, 68 and 100. So this is how it goes. Now if I want the indices of the first two highest values, then I'll just put in -2 colon over here, and I have 6 and 3, right? 0, 1, 2, 3, 4, 5, 6. So 68 is the second highest value, and then we have 3, 0, 1, 2, 3, right? So 100 is the first highest value. Now what I want to do is I want to arrange this in descending order. So to arrange this in descending order, again, I'll put in braces over here, I'll put double colon, and I'll put in -1 over here, and I have sorted the indices in descending order. Now if I take all of this, I'll cut this and I will paste this inside of X. I'll click on run, and this is how I get the first two highest values from this numpy array. So 168 are the two highest values from this numpy array. So now we'll have to give some examples for creating a data frame from list and dictionary. So this is a very common and easy question which is asked in most of the Python interviews, right? So first we'd have to go ahead and create a list, and we'd have to convert that list into a data frame. Similarly, we'd have to create a simple dictionary and convert that dictionary into a data frame. So I'll type in import pandas as PD. So I'd have to start off by importing the pandas library. Now I will go ahead and create a list. So I'll name this list to be equal to L1. So L1 equals 1, 2, 3, 4, 5. So we have created our list. Now to convert this list into a data frame, all I have to do is use pd.dataframe function. So over here we need to keep in mind that D is capital, right? pd.dataframe, and I will pass in L1 inside this, and I will store this in, let's say, data1, and I'll just print out data1 over here. So we have successfully created a data frame from a list where the list values are 1, 2, 3, 4 and 5. Now similarly, we'll create a dictionary and create a data frame out of that dictionary. So I will name this dictionary to be dt1, and the key is fruit name, and the values are apple, mango, and let's say orange. After this, we'd have to create our second key value pair. So our second key value pair would be count, and the values would be, let's say, 12, 24 and 36. Right. So we have created this dictionary. Now again, to convert this dictionary into a data frame, we'd have to use pd.dataframe, and I will pass in dt1 inside this. Right, so we have created this data frame where our first column is fruit name and the second column is count, and fruit name comprises of apple, mango and orange, and the count of the fruits is 12, 24 and 36. So now we have this iris dataset which comprises of all of these columns. So we have sepal length, sepal width, petal width and species. Now out of this we'd have to extract some specified rows based on a condition. So we'd have to extract only those records where the sepal length value is greater than 5 and the sepal width value is greater than 3. So I'll start off by loading the pandas library, import pandas as pd, and after this, to load a CSV file, I'd have to use the pd.readcsv function, and I'll give in the name of the file. So the name of the file would be iris.csv, and I'll just store this in a new object and name that object to be equal to iris. Now let me have a glance at the head of this dataset. Iris.head. So this will give me a list of the first few records, right? Sepal length, sepal width, petal width, and species. Now let's see how can we extract only those records where sepal length is greater than 5 and sepal width is greater than 3. Right. So I'll start off by giving the name of the data frame, and I'll put in these braces over here, and I'll give in the first condition. So the first condition is again iris, and from this I'd have to select only those sepal length columns where it is greater than 5. So sepal dot length, this value needs to be greater than 5. So I've given my first condition. After this, I'll go ahead and give my second condition. And this time I'd have to extract only those records where sepal dot width Let me type this out, and this needs to be greater than 3. Now let me also put this inside these braces over here. Let me cut this and let me paste it over here. I'll click on run. Right, so this is our list of values where sepal length is greater than 5 and sepal width is greater than 3. If I scroll down, you'll see only those values where sepal length is greater than 5 and sepal width is greater than 3. So what we do is, we're given the first condition where sepal length is greater than 5. After that, we'll use the AND operator, and then we give the second condition, which is sepal width is greater than 3. Right, so after this, we again have this iris data frame over here, and we'd have to introduce NaN values or null values in the first 10 rows of sepal width column and petal width columns. So if you see this original data frame over here, you see that these two columns comprise of some values. But then again, we'd have to fill the first 10 rows of these two columns with NaN values. So I'll start off by loading the required packages, which would be pandas and numpy. So import pandas as pd and import numpy as np. After this, I'll load the iris dataset. So iris equal to pd dot read csv, and I will pass in the name of the dataset, which is iris.csv. Let me again have a glance at the head of this dataset. So iris.head. Right. So now to introduce NaN values, I can use the np.nan method. So now what I'll do is I'll actually create a duplicate copy of this object. So iris1, and I will store this data frame into iris1. Now I'll type in iris.ilock, and I would want to make changes in the first 10 rows and the second column and the second column, right? So first 10 rows and the second column. So the index of the second column would be 1. And what I'll do is I will introduce all of the NaN values. So np.nan, let me put an equal to over here. Now let me have a glance at the head of this modified dataset. So iris1.head, right? So we see that this is our original data frame, and with the help of np.nan, I have introduced NA values from actually the first row. So let me actually change this to be 0 over here. I'll click on run. So now I have NA values for the first 10 records. Similarly, I'll also go ahead and introduce NA values in the petal length column. So over here, I just have to change the index of the column, which would be 2. Let me have a glance at the head, iris.head. Right, so now we'd have to get the number of NaN values present in each column of this enhanced data frame. So this is our data frame over here, which comprises of these columns. So we have age, BMI, HYP, and CHL. And we see that these 3 columns over here comprise of NaN values. And we'd have to find the count of the NaN values present in each of these columns. So I'll start off by loading the pandas data frame. I'll type in import pandas as pd. Let me just wait till the package is loaded. Right, so now that we've loaded the package, I'd have to load the CSV file, which is enhance.csv. And for this, I'll be using pd.readcsv function. And I'll give in the name of the file, which is enhance.csv, and I'll store this in a new object and name that object to be enhance. Now, if I want to get the count of number of NaN values, this is what I'd have to do. Enhance dot, so I have this na function, and after this I will just print it out. Let's see what do we get, right? So we just get a bunch of true or false labels. So wherever there is an NaN value present, we have a true label. So over here in the BMI column, the first record, this is an NaN value. This again is an NaN value. So wherever you see true values, it basically represents all those NaN values. And if I want the sum of all of these NaN values, I just have to type in sum, and now I click on run. Right, so we see that age column has no NaN values, BMI column has 9 NaN values, HYP column has 8 NaN values, and CHL column has 10 NaN values. Now we'd have to open and read a file in Python. So let's see how can we do that. So I actually have this file with the name Sparta and it is present in my D drive. So let me actually copy the path over here. Right, so this is just the path which I have to copy. So first, to open a file in Python, I'd have to use the open function. So I'll just type in f equals open, and this takes in two parameters. The first parameter is just the path, and after the path, I'll give in the name of the file, which would be sparta.txt. And the second parameter is the mode which I want to open this file. So I want to open this file in the read mode. So again, I'll just give in double quotes and I'll type in R. So R basically means that I am opening this file in the read mode and I'm storing this in this object F. Now let me go ahead and read this. So F dot read. Right. So this is the sentence which was stored in this file. This is Sparta and we have successfully read the sentence. So let's head to the next question. So what is a lambda function? And we'd have to create a simple lambda function to add 10 to a given number. Well, a lambda function is an anonymous function and it can take any number of arguments, but it should have only one expression. And this is the syntax of a lambda function. So you'll type in lambda and then you'll give in all of your arguments. After that, you'll put in a colon and then you'll give the expression. So let's go ahead to Jupyter Notebook and create a simple lambda function to add 10 to a given number. Right, so let me just type in lambda and I'll give the name of the variable to be a. I'll give a colon and all I have to do is add 10 to whatever variable is sent into this, and I am naming the function to be, let's say, x. So this is how we can create a simple lambda function. Now I'll call the function and pass in a number. So let's say I'll pass in 8. Now this is returning 18. So all I'm doing is adding 10 to the number which I'm passing into this. Now again, let's say if I pass 5 into this, I'll get 15. Similarly, let's say if I pass 100, I'll get 110. So we have successfully created a lambda function which takes in a parameter and adds 10 to the given parameter. So now we'd have to create a simple line plot like this, where x and y axis values range from 0 to 10. And the title of the plot is y versus x label is x-axis, y label is y-axis. So a simple line plot, and we can create this line plot with the help of the Matplotlib package. So let's quickly head on to Jupyter Notebook. I'll start off by loading the required packages. So I would need the numpy package. So I'll type in import numpy as np, and I would also need the Matplotlib package. So I'll type in from Matplotlib import pyplot as plt. Alright, so now that we've loaded the required packages, let's go ahead and create our data. So our x-axis and y-axis values range from 0 to 10. So I will name x and I'll get the values with the help of a range. And since the values go from 0 to 10, 0, 10, and the step factor is 1. So let me just print out x over here and let's see what do we get. Right, so these are all of the values which I have over here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, now similarly, let me also go ahead and create the y values. It'll be the same thing over here. It's just that instead of storing the values in x, I'll be storing them in y. So I have my x and y values to be ready. All I have to do is use these data points and create the line plot. So plt dot plot, and I'll pass in x, comma y, and this is my plot over here. Now I'll also go ahead and add the labels for x-axis, y-axis, and I'll also give them the title. Plt dot x label. So the label would be x-axis. Similarly, plt dot y label, and the label would be y-axis for this. After this, I'd have to give in the title. So the title would be plt dot title and x versus y. Right, so we have created our line plot where the label of x-axis is x-axis, the label of y-axis is y-axis, and the title of the plot is x versus y. So it's as simple as that, guys. So this is how you can create a simple line plot with the help of the Matplotlib package. So now we'd have to create a simple bar plot. And we have these fruits over here represented on the x-axis. So we've got apple, banana, and orange, and we've got the cost of the fruits on the y-axis. So let me start off by loading the required library. From Matplotlib, I'll be importing pyplot as plt. After this, I just have to create my data. So I'll be creating a simple dictionary over here, and I'll name this dictionary as data. I'll put in braces over here, and it consists of 3 fruits, which are apple, banana, and orange. So apple, and cost of apple would be, let's say, $50. After that, we have banana, and the cost of banana is 20. After that, we have orange, and the cost of orange is 30. Right. So now I'll separate the keys and values from this. So let me get the keys first, data.keys, and I'll get the list of this. I'll paste this inside this, and let's say I'll store this in an object named as names. Now let me get all of the values similarly. Values, and I'll be getting data.values. So I have the names, I have the values. Now all I have to do is make a bar plot. And to make a bar plot, I'll be using plt.bar, and I'd have to pass in the names as well as the values. Right, so we have successfully created a bar plot, and on the x-axis we have the names, and on the y-axis we have the cost. Next question. So what do you understand by a module in Python? So when we write everything in a single page, it becomes difficult to track. And not just this, let's say if you want to make a change at a certain place in the project, then it would affect the entire project and may prove to be disastrous. And this is where we'll be using the concept of modules. So instead of writing one big software in one page, we would have to break it down into parts. So a module basically helps us to organize our Python code. Now let's say you want to write a program to create a calculator. Now instead of writing all of the features in the same file, you can create separate modules for addition, subtraction, multiplication, and division. Now if you want to perform addition, you can invoke the addition module. Similarly, if you want to perform multiplication, you can invoke the multiplication module. So for every single purpose, you can have a separate module so that your work becomes easier. So now we'd have to randomize the items of a list in place in Python. So let's say we have a list which comprises of these elements. So let's say the first element is Mary, and then we have had a little lamb. Now I'd have to randomly shuffle all of these elements inside the list. And to randomize the items of a list, we can use the shuffle function. And the shuffle function is part of the random library. So I'll type in from random import shuffle. So I have loaded the function. Now let me go ahead and create the list. Mary had a little lamb. Right. Now I will just pass in this inside the shuffle function. Now let me print in X. Right. So this is in place shuffling inside the list. Right. So initially the list was Mary had a little lamb, or the sequence of the elements inside this list was Mary had a little lamb. And after passing this list inside the shuffle function, the elements changed and the sequence now is a lamb Mary had little. So now we'd have to write a program to get the length of the string ophthalmology without using the len function. And to get the length of the string, we can just use the for loop. So what we'll do is we'll start a for loop and it will iterate through all of the characters in this string, and we'll get the count of the number of characters present in the string. So let me name the string. So it is OPHTHALMOLOGY. So let's hope this is actually the spelling of ophthalmology. Right, now let me initialize a counter and set the value of counter to be equal to 0. After this, I'll start the for loop. So for I in A, what would basically happen is count equals count plus 1, and finally I'll print out the value of count. So what is happening over here is Initially, i's value is 0 and it will loop through all of the characters of the string which is present in A. And so let's say the loop starts over here. Initially, i's value is 0 and it will enter O. Now the count increments by 1. Again, it will head to the next character. The count again would increment by 1. It will head to the next character and the count would increment by 1. So till the end of the string, it will keep counting the number of characters present. Right, and we get the result. So the number of characters present in the string is 13. So now we'd have to replace all the odd numbers in this numpy array to -1, right? So this is our numpy array which comprises of the numbers from 0 to 9, and we'd have to replace all of the odd numbers. So 1 would become -1, 3 would become -1, 5 would become -1. So wherever odd numbers are present, all of those odd numbers would become -1. Let me load the numpy library, import numpy as np. After this, what I have to do is create my numpy array. So arr equals np.arange, and it will go from 0 to 10. Let me just print out this numpy array over here. This is my numpy array. Now let me go ahead and replace all of the odd values with -1. So what I'll do is I will basically divide each element with 2 and see what is the remainder. So arr %2, and if it is equal to 1. So what I'll do is I will divide 0 with 2, I'll check the remainder. Similarly, I'll divide 1 with 2 and I'll check the remainder. I'll divide 2 with 2 and I'll check the remainder. So wherever the remainder is equal to 1, those elements I'll be changing it to equal to -1, right? So first I'll divide 0 with 2 and I'll check what is the remainder. And since the remainder is not equal to 1, nothing will happen. After this, I'll divide 1 with 2 and I'll check the remainder. So if the remainder is equal to 1, I'll replace this with -1. Similarly over here, if I divide 3 with 2, the remainder which I'll be getting is 1. And again, this value would be replaced with -1. Right, so the changes have been done. Now let me print this. This was my original array. After performing this step over here, all of the odd values have been replaced with -1. 1 has been replaced with -1, 3 with -1, 5 with -1, 7 with -1, and 9 with -1. Now we'd have to perform an operation so that we get the common items between two numpy arrays. This is our first numpy array. This is our second numpy array. Now let's actually check the common items. So if we look closely at these two arrays, we see that 2 and 4 are the only two common items present among these two arrays, and I'd want to extract these two. Right, so we have created our arrays over here. This is the first numpy array and I'm storing it in A. This is my second numpy array and I'm storing it in B. Now to get the common elements, I have the np.intersect1d method. So np.intersect1d, and I just have to pass in the two numpy arrays inside this as the parameters. So A, B, I'll pass in these two, I'll click on run. Right, so I've got the common elements present in these two arrays. Right, so we have a pandas series over here, and we'd have to convert each of these elements into title case. So Mary had a little lamb, so we see that all of this are in small cases. Now I'd have to convert all of these elements into title case. So let me start off by loading the pandas library. Import pandas as pd. Now I'll create the series pd.series, and I'll pass in the values, which are basically Mary had little lamb. Right, so this is done, and I'll store this in, let's say, ser. So I have created my series. I'll just print it out now. Right, so this is my pandas series. Now I'd have to convert all of these elements into title case. That is, M needs to be capital, H needs to be capital, A, L and L needs to be capital. Right, and as I've already told you, we'll be using the map method, which helps us to replace or substitute values or all of the values inside a pandas series. So ser.map. Now inside this, I'll use a lambda function to convert all of these elements into title case. So let me type in lambda over here, x colon, and I just have to convert this into title case. So let me just put in title over here. Now let me click on run. Right, so we have successfully converted all of these elements into title case. Now let me store it back to ser. Now let me print ser over here, right? So all of these elements have been converted into title case. So now we have the same pandas series. So Mary had a little lamb. Now I'd have to calculate the number of characters in each word of the series. So this is 1, 2, 3, and 4. So there are 4 characters present in the word Mary. There are 3 characters present in the word had. This is a single character, right? So you'd have to find out the total number of characters present in each words or each of these elements inside this pandas series. Import pandas as PD. Let me again create the series. Ser equals pd dot series, and I'll give in all of the elements. Mary had a little lamb. So now to get the length of each of these words present in this pandas series, I'll have to use the map method. So ser dot map, and inside this I'll again create a new lambda function, lam bda a colon, and since I have to get the length, I'll use the length function, and I have to get the length of each of these elements inside a. Right, so we see that the length of the word Mary is of 4 characters. In had there are 3 characters, a is a single character, and in little there are 6 characters, and in the word lamb there are 4 characters. Time for next question. So again we have this iris data frame, and we'd have to change the column name sepal length to s underscore length. Let me load the package, import pandas as pd, and I'll also load the file. So pd dot read csv, and the name of the file is iris.csv, and I'll store it back into iris. Let me have a glance at the head of this data frame. So it'll be iris.head. So we have all of these columns over here, and I'd have to change the name of the sepal.length column to s length. So to rename the columns of a data frame, I have the pandas.rename method. So first I'd have to give in the name of the data frame, which is iris, and then I will invoke the rename method. Now I'd have to give in all of the column names which I'd want to change. So I'll type in columns over here, I'll create a dictionary, and my key would be the name of the column which I'd want to change. So I would want to change the name sepal length to be equal to s underscore length. So it'll be s underscore length. So this is how it goes. So iris dot rename, and the original column name is sepal dot length, and I'd have to change it to s underscore length, and I'll store it in a new object and name that object to be equal to iris1. Now let me just print out the head of this. So iris1 dot head. So now we'd have to build a linear regression model on top of this Boston data frame, where the independent variable is this RM column over here, and the dependent variable is this MEDV column over here, and the train and test split needs to be equal to 80-20. So this question is basically related to machine learning with Python, where we are implementing a linear regression model on top of this data set to understand how does this MEDV column vary with respect to this RM column. Or in other words, MEDV column is our dependent variable and RM column is our independent variable, and we are trying to understand how does MEDV change with respect to RM. So let me start off by loading the pandas library, import pandas as PD. Right, now we'll go ahead and also load up our Boston dataset. So pd.read_csv helps me to load up the dataset, and the name of the dataset is boston.csv, and I'm loading this file in this object Boston, and then I'll have a glance at the head of this. So these are all of the columns which are present in this data frame. So I've got Crim, Zn, Indus, Cas, Nox, RM, and so on. And MEDV is my target and my feature is RM, or in other words, MEDV is my dependent variable and RM is my independent variable. Now I'll separate the feature and the target, right? So pd.data frame, and so from this entire Boston data frame, I am selecting only the RM column and I am storing it into the X object. Similarly, from the entire Boston data frame, I am selecting only this MEDV column and I am storing it into this Y object. So X would have the feature values and Y would have the target value. So now I've extracted the feature and the target. Now it's time to divide this dataset into training and testing set. So the train test split needs to be 80-20, or in other words, 80% of all of the records would be present in the training set and 20% of all of the records would be present in the testing set. And to do this, I'd need the train test split from sklearn.model selection. So I'll type from sklearn.model selection import train test split, and this method takes in these parameters. So first I'd have to pass in the features and then I'd have to pass in the target. So X, Y, and then I'd have to give in the test size. So the test size is 0.20. So this again means that the test set would comprise 20% records and the train set would comprise of the 80% of the records. And the values would be stored in xtrain, xtest, ytrain and ytest. So xtrain would comprise of all of the training values or all of the training records for the features, and xtest is basically the test set for the features. Ytrain is the train set for the target and ytest is the test set for the target. So we have our training and testing sets ready. Let me click on run over here. Alright, now it's finally time to build the model on top of the train set. So from sklearn.linear model, I will import the linear regression and I'll create an instance of this. So I'll name that instance to be regressor and I will fit this model on top of xtrain and ytrain, or in other words, I'm fitting the model on top of the train set. Alright, so now that we've fit the model, it's finally time to predict the values on top of the test set. And to predict the values, I'll use regressor.predict, and the parameter which I'm passing inside this is x_test, and I'll store this in y_pred. Now, once we predicted the values, I have to find out the root mean square error. So I'll import metrics from sklearn, and this is how I'll get the root mean squared error. So metrics.mean squared error, and this takes in two parameters, ytest and ypred. So ytest comprises of all of the actual values and ypred comprises of all of the predicted values, and I will pass these two inside mean squared error. Now when I do this, I'll get only the mean squared error, but I want the root mean squared error. So I'll use np.square root. So I would also have to import the numpy library over here. I'll type in import numpy as np. Now I'll click on run. So now we've arrived at our final interview question, and we'd have to build a decision tree classifier on top of this iris data frame, where the dependent variable is the species column and the independent variables are the rest of the column. So sepal length, sepal width, petal length and petal width would be the independent variables, and your species column is your dependent variable, and the train test split is 70-30. So I'll start off by loading the requisite packages, which are numpy and pandas. So import numpy as np and import pandas as pd. Then after this, I'll load my dataset. So pd.read_csv. I'll pass in the file name iris.csv and I'll store this in the iris object. And we have a glance at the head of this dataset. So these are all of the columns present in this data frame. We've got sepal length, sepal width, petal width, and the species column. Now out of this, the species column is our dependent variable, and these four columns, the numerical columns, are our independent variables. So now I'll go ahead and separate the features and the target variable. So these are all of my features, these first four columns. So I'll just extract sepal length, sepal width, petal length and petal width from this iris data frame, and I'll store that into this X object. Similarly, I'll extract only the species column from the entire iris data frame and I'll store it into Y object. So I have my features and the target ready. Now it's time to divide this entire data frame into train and test split. So I'll have to import train test split from sklearn.model selection, and this takes in these parameters. First parameter are the features, second parameter is the object which comprises of the target label, and the test size is 0.30. So 30% of the records would go into the test set and the rest 70% of the records would go into the training set, and I am storing the results into xtrain, xtest, ytrain and ytest. So xtrain is the training set for the features, xtest is a test set for the features, yTrain is the training set for the target and yTest is the test set for the target. Now we'll import decision tree classifier from sklearn.tree. So I will go ahead and create an instance of this decision tree classifier and I'll name that instance to be classifier, and I will fit this classifier on top of the training set. So classifier.fit, and I'll pass in xtrain and ytrain inside this. So we have successfully fit the model on top of the train set. Now we'll go ahead and predict the values on top of the test set. So classifier.predict. So I'll store the result into ypred. After this, we'll calculate some metrics. So we'll get the confusion metrics and we'll also get the accuracy score. Right. So this is my confusion metrics and this is the accuracy. So the left diagonal which you see in this confusion metrics, all of these are the values which have been predicted or classified correctly. So this first row represents the species of Setosa, second row the species of versicolor, and the third row the species of virginica. Right? So you see that all of the species of Setosa have been classified correctly. When it comes to versicolor, 16 of them have been classified correctly and 2 of them have been classified incorrectly. And when it comes to virginica, 13 of them have been classified correctly and 2 of them have been classified incorrectly. So to get the accuracy, we'll have to add 12 plus 16 plus 13 by all of the values. So let me just do that. 12 plus 16 plus 13 divided by 12 plus 16 plus 13 plus 2 plus 2. So the accuracy is the same and it comes out to be 91.11.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.